Hi everyone and welcome to day 2 of Software Architecture Conference. I'm your host Simon and what an incredible day we have had the other day. We had this conference is for about 3 days. That's all you know. It started the other day. It's gonna run today and it's also gonna run tomorrow. 3 days of a lot of content on software architecture. We are on day 2 and on day 2 we have about 13 sessions. I quickly wanted to show you all actually the sessions that we have today. But before we do that, quick stats, quick reminders. The first thing is that you can still go ahead and register for this conference. If you're someone who has not registered it and you're watching it from YouTube, LinkedIn, Twitter, Twitch, Facebook, or anywhere else, right? We're streaming it to multiple destinations at the same time. If you're watching from anywhere and you have not registered yet, please feel free to go ahead and register. I'm going to drop the conference URL in the chats. What happens is when you register, we send you updates about the tomorrow when the conference is starting, and we also update you about the recordings and all our upcoming conferences that we do at C Sharp TV and C Sharp Corner. So the registration is still open. You can check at the top, it says register. And if you come down, you can actually watch the live stream here. So if you don't know where we're streaming, if you don't know which place and everywhere, in fact, if you're watching on social media, I believe that's where you are. But just in case you're like, okay, where can I find the streams actually? So we are also streaming on our conference website, and we're also streaming on csharp.tv, and we're also streaming on all C Sharp Corner and C Sharp TV, YouTube, and LinkedIn and Twitter handles. For today, keynotes, we have Rodrigo Díaz. He's a 16 times Microsoft MVP and a Microsoft RD. In fact, he has created a lot of LinkedIn courses. He's very popular. He's had years of software architecture experience. So he's the best guy to go ahead and give the keynote on day 2. And I quickly wanted to run through today's session. Okay. All right, so let's look at it. It is August 15th. Happy Independence Day to all the people, those who celebrate. I believe, especially for Indians, it is uh, Independence Day here in India. It's a national holiday, but still we are streaming it only for you because why not? It's a free virtual conference, so everyone gets to attend it. So we're starting first with Siarhei Misko. He works at Viber and he's going to talk about architecting for observability. Observability. He works at Viber. He can actually tell from his background picture that it's purple. It matches his branding. The next is by Zang Zhiya. He's going to talk about bootstrapping a tech stack, architecting for agility. Then you have Yevgen joining, talking about roles in software project. Then you have Jose, a very good friend, AI architecture. Then we have Amira, right? We don't have a lot of female speakers, but she's very good. Microsoft Fabric is very popular these days. You go to any of these Azure data conferences, generally people end up talking about Microsoft Fabric. So I am really looking forward to this session. Then you have Soham. He works at Microsoft Netherlands. Then you have Siri. He's from United States. He also works at Microsoft. Bruno also works at Microsoft. So a lot of folks from Microsoft coming in. Then you have sessions around big data, then keeping it simple, then cloud infrastructure, and a lot more about on best practices. So day 2 is filled with a lot of content. I gently wanted to remind you all to follow the code of conduct that you can follow. That you can get the link in the description wherever you're watching. Generally speaking, we just want you to be kind and be respectful and be welcoming to everyone in the comment chats and everywhere on social media. And when I say on social media, right, we do have a lot of giveaways going on. So if you are, whenever you ask a question to the guest, please feel free to go ahead and use the hashtag software architecture conf in your comments when you ask the question. This way we can track your comments, and towards the end of the session, or no, not the end of the session, towards the end of the conference, or maybe in somewhere in the middle too, we're gonna announce some of the winners. And yeah, the other giveaway that we have is shows your excitement on social media, on Twitter and on LinkedIn. Tag us at csharp.tv. Use this hashtag once again. Take a screenshot of this content that you're watching, and we'll pick winners from social media too. We did announce a winner the other day. I remember Ganesh is one of the winner. With that said, let's welcome. I quickly wanted to give you a brief that the first 2 sessions are actually recorded sessions, so we may not be able to do the Q&A. With that said, all other sessions are for day 2 our live sessions. So the first two sessions, that is by Misko and Zhiya, they are recorded. So let's get started by the very first session, that is by Misko. He's going to talk about architecting for observability in iOS application, building resilient and measurable system. Here's the amazing session for you.
Hi everyone, welcome to Architecting for Observability in iOS Applications. My name is Sergey Misko. I'm iOS team lead with more than 8 years of experience. Today I will briefly tell you about observability in mobile applications and then we'll tell you what you can do in your iOS applications to make implementation of observability easier. How do we ensure that our application is stable and functioning properly? We test it. More often, this is done by the QA team using various test cases, test environments, and specific devices. But such checks are inherently synthetic and don't always reflect the real-world scenario. In reality, things are much more complex, and observability can help organize real-time testing. Observability is a term that originated from the fields of engineering and system analysis. In the context of software development and especially mobile applications, observability can be described as the ability of a system to provide information about its internal state and operation. Simply put, it's a property of the system, like trustability or security. We need to design the system in such a way that it benefits from observability, meaning the system itself reports its state and provides details in case of incidents. It's important to understand that traces, metrics, and logs by themselves are not observability. These are just tools that can help achieve this property. True observability is built upon aggregating all collected information in one place, where it can be analyzed, visualized through graphs or dashboards, and where alerts can be set up to trigger when the number of incidents increases. Good observability allows a team not to quickly respond to emerging issues, but also to anticipate them. This means the system itself hints at what is wrong and helps identify the cause immediately. Imagine not having to figure out where exactly an error occurred and what caused it. The system directly informs you. Observability is a key tool for creating reliable and resilient mobile applications. It minimizes the time needed to detect and fix issues, thereby improving the overall user experience. You can learn about the problem from users when they start complaining, but observability helps solve two crucial aspects. You learn about the problem before it becomes critical, and you have complete information and can immediately start resolving the issue without needing to gather data from various sources. To summarize, with good observability in your project, you don't just find out that a problem occurred, but you immediately get all the necessary information to solve it. The system fully reports its state and the causes of any issues, allowing you to take action promptly. However, it's important to remember that observability does not replace classic testing. Synthetic checks are still necessary. The topic of observability is widely known among backend developers and DevOps engineers. However, in mobile application development, this topic is often overlooked. Even though many teams and projects have already made steps towards observability, perhaps even without realizing it. Let's imagine a hypothetical project, an iOS application. The team that developed it didn't integrate analytics, logging, Crashlytics, or other monitoring tools. It's just a project with a set of features. After releasing a new version, users began to report that app is not working. It crashes by itself. Or when I open the second screen, the app crashes. These reviews indicate that something went wrong, but don't provide clarity on what exactly and why. The team tried to reproduce the problem but found nothing unusual. The app seemed to work fine in their environment. However, users continued to complain, suggesting a possible crash. But since the team couldn't reproduce it, they were left to work blindly, release new version and hope it works. As example, this situation could have been easily solved if the app had been set up with Crashlytics to catch crashes and send information about them. In the world of iOS development, Apple already provides such functionality out of the box, but with certain limitations. For greater flexibility, developers often turn to third-party services like Firebase Crashlytics. Today, collecting crash information has become a standard practice that allows teams to learn about issues before users start complaining in large numbers, while also providing data on the causes of these issues, such as stack traces and technical information about the device. By working with Crashlytics, teams are already taking that step toward observability. However, crashes are far from the only problem that can lead to user complaints or worse, cause a drop in key metrics and revenue. The more complex a system becomes, the more dependent parameters it includes, the more diverse the devices and OS version it supports, the less transparent it becomes in understanding how the app behaves in real-world conditions. For example, if a project uses feature flags to manage the availability of features and the configuration system doesn't validate changes, so a product manager or business analyst could accidentally make an error, such as miscast the data format or skip an important field. This could result in users not receiving certain functionalities, even though the server and Crashlytics don't register any issues. Moreover, given the complexity of modern systems, it's impossible to test and simulate every possible usage scenario. For example, you might release several new features simultaneously. Everything works fine in the test environment, so you release the update. However, on real devices, under certain conditions such as specific phone model, iOS version, internal app settings and other, many users might experience issues. For instance, the app may take a long time to load, or critical flows like registration may start to fail, and you will see nothing on Crashlytics because there are no crashes. So, just like with crashes, you need to build metrics for other aspects of the app's performance and stability. To determine where to start building metrics, I suggest focusing on three key aspects. First is important user stories. For example, registration, login, payment processing, sending messages, generating resources, search results, and etc. It's important to consider not only whether these flows are functioning, but also how well they're performing. As example, how quickly payments are processed or how quickly messages are sent. Next, paths, flows, features, stories that depend heavily on dynamic changing arguments. As example, feature flags, country codes, and location. And flows, features, and stories dependent on external systems. This could be a third-party APIs or services, as well as internal systems developed by another team within your company. It's not guaranteed that these teams consider potential issues that might affect your specific app, as opposed to the entire system. This part of the talk provides a general idea of what observability can look like in mobile application. In the next section, we will explore architectural solutions of the iOS side that can help you implement observability in your app. I recommend exploring articles, talks, and other materials, not limiting yourself to mobile development. The experience and approaches of DevOps and backend developers can be very valuable. Achieving good observability means not only knowing that a problem has occurred in your system, but also providing details that explaining what exactly went wrong. One way to gather such information is by using logs. While metrics provide a general overview of the system state, logs collect detailed information about what happened on the user device, what actions they took, and what might have caused the problem. It's crucial to remember that any tools for achieving observability adds overhead, and logs are like one of the heaviest tools. So let's see how we can collect and deliver logs. First of all, we can use live or on light mode. In this mode, logs are sent immediately after they are recorded in the application in real time. This is often used in the backend development, but may not be the best option for mobile applications, as you'll receive logs even everything is working fine for the user. This creates a large amount of unnecessary data, which can be difficult to process and store. However, it's possible to configure the system so that logs are only sent when a specific flag is activated in the app or when a trigger event occurs. It's essential to test this logic to avoid errors that could lead to either losing all logs or being overwhelmed with unnecessary data. Next is on demand. There are two sub-approaches here. First, automatic, where through a login flag which user receives upon entering the app, indicating that logs should be sent, or via a push notification that also prompts the app to send logs. Or we can do it manually. The user can select an option in the menu to send logs upon your request. And the last one is triggered. Logs can be automatically sent when a specific event occurs in application, such as crash or critical error. And how we can collect our logs. First of all, we can make continuous collection. Logs are recorded continuously, but it's important to consider next things. Avoid recording too many logs at once to prevent overloading the disk with read-write operations. Implement log file rotation to prevent them from becoming too large. For example, you can set a file size limit of 20 megabytes, after which all data is either cleared or overwritten. And carefully manage logging levels. Debug logs, which are useful for testing and beta versions, should not be included in continuous logging for release versions. On-demand log collection can be activated manually by the user through settings or automatically via login flag and push notification. And triggered. Just like with delivery, a trigger event can start the log recording process. The last two approaches are quite convenient, especially when dealing with specific issues encountered by individual users. However, these methods have drawbacks. For example, you might miss the initial problem because the logs will only start recording after you've identified the issue and asked the user to enable the log collection. In such cases, the root cause of the problem may be lost. But also, you can implement a combination of logging approaches. For example, logging at the error, warning and critical levels can happen continuously, while more detailed logs, info and notice, can be enabled when a trigger occurs upon user request or via a login flag. This approach helps maintain a balance between having detailed information and optimizing the costs of storing and processing logs. How we can write logs in iOS devices? First of all, we can use Apple's OS log. Apple offers this powerful tool that includes many optimizations for fast performance, with deep integration into the operation system and support for privacy tools. However, for our purposes, it may be inconvenient. These logs can be difficult to access. There are three ways. First, we can connect the phone to a computer and view the console, which is not so comfortable for the users. Second, we can collect a system diagnostic of the entire device. But it takes up to 15 minutes to collect and results in more than 200 megabytes archive. And also, we can get the logs programmatically from the app, but there is a drawback. You can only get logs from the current process. This means you can't retrieve logs from extensions or from previous launches of the application. So I'm suggesting you not to continue with the OS log. So another approach is to write logs to a text file. You can start by using an existing framework, for example SwiftBeaver, which writes logs to a file. Later, when you become more familiar with logging and understand your needs, You can modify it since it's open source, or implement your own solution, as it's quite simple, just write into a file. Or you can write logs in Firebase Crashlytics. By default, Firebase Crashlytics is used to catch crashes and send stack traces and device information. But you can also log additional data, such as information about subscriptions or user roles. This allows you to more accurately identify the context in which the error occurred, and potentially find a solution more quickly. You can also write logs to Firebase Crashlytics, which will be sent along with the crash report. You can also send a non-fatal event that includes all the information. However, since Firebase is a free service, it has limitations, such as data sampling, so not all events are saved, and a limited number of log times before an error occurs. Additionally, you cannot run custom SQL queries to retrieve the specific data you need. Therefore, it's not advisable to rely on free services for too long. You should consider more specialized solutions or build your own. However, Firebase Crashlytics can be sufficient for a start. And I want to give you a few general advices for writing logs to a text file. Define a login policy and use login levels appropriately. It's important to consider how these levels will be used and to monitor the amount of logging during code review. This helps prevent situations where too many logs are recorded at once, which can negatively impact the system and the disk. This task is as crucial as controlling the number of network requests or database queries as the application functionality grows. To prevent logs from being included in release builds and causing unnecessary overhead, you can use preprocessor directives like if-defined. Instead of adding if-defined to every login statement, you can optimize the login function itself. If defined directive is enabled, the login code is executed. If not, the function remains empty. For example, this can be done for the debug level logs. This allows Swift compiler to exclude unnecessary calls in the release build, ensuring high performance. And also use autoclosure. In your login functions, specify the argument that passes the log text as autoclosure. This allows you to delay the evaluation of the argument until it's actually needed. If logging of this level is not enabled, the evaluation of debug descriptions will not occur, reducing the system load. While logs indeed provide a lot of useful information, they can be cumbersome due to their peak volume. Therefore, it's important to consider various optimizations. One such approach is to transmit a detailed state of the application instead of full logs. For example, you could send information about which screens the user navigated through, which API requests were made, what settings were configured, and which key business logic flags were set. Let's consider an example of notification service extension. This extension is triggered when a push notification with a specific flag is received. The system then allows us to modify the content of the notification or even generate multiple notifications instead of one. For our business logic, we might take an HTTP request to our API, query a database, save changes, and much more. However, there is a catch. iOS strictly enforces a 24 MB RAM limit for your extension. If you exceeded this limit, the system will immediately terminate your process without any notification. This means the user won't even know that something went wrong, and no events will be logged in your metrics or crash reporting tools. Knowing that the notification service extension is not fully executing is not enough. It's crucial to know at which stage it fails. So we need to track every step of our process, send some kind of result, and ensure that we don't introduce so much overhead that we ourselves become the cause of exceeding the RAM limit. A simple solution is to use an option set, where each bit represents a specific step in the notification service extension process. And one of these bits indicates that the extension has reached its logical conclusion. If we complete a step, we set the corresponding bit to 1. Each time a change occurs, we should save the option set value to disk. Then on the next launch, we can check the value of the last option set to determine whether all necessary steps were completed and if the process reached its end. If we detect any deviation, we can send a metric. This way you can see if your extension frequently encountered errors or is being terminated by the system due to exceeding the RAM limit. Thus, instead of large volume of logs, you can focus on capturing specific key events and states, which will not only save resources, but also simplify data analysis. With a well-structured architecture in your application, implementing various metrics becomes much easier. Honestly, there is nothing fundamentally new here. It's important to follow established patterns, and don't forget about the solid principles, especially the single responsibility principle. This will help you better monitor the areas in your code that require attention. For example, let's consider how the coordinator pattern can help us. Using the coordinator pattern for navigation allows us to clearly track the user path through the screens and their current state. Each coordinator calls another, and thus you can easily compile all the information about the user's journey into an optimized string, such as registration, intercode, main screen, more screen settings. Or you can even reduce it into something like this, where each designation represents a specific screen or transition. This data can be easily decoded for analysis. You can also use the coordinator pattern to determine the last screen the user was on before closing the app. You can send such a metric based on the hypothesis that if many users close the app while on a specific screen, there is likely something wrong with this screen, or users are unable to exit the screen, prompting them to restart the app. To achieve this, you simply need to identify the active coordinator in the application will terminate method of the app delegate, ask it for the current screen, log this information, and send it to analytics on the next app launch. With the coordinator pattern, this can be done quite easily while keeping your code clean. We can also build an app start time metric based on how quickly the user gains access to the app after launching it. Again, using coordinator, you can measure the time difference from app startup to when the app reaches a specific state according to your business logic. Or you can monitor how quickly users complete important flows in your application, such as payments. If users suddenly start taking significantly longer to complete a payment flow, you will notice it right away. Additionally, you can work with the API layer by recording which requests were made during app startup or during its operation. This data can be useful for understanding the sequence of user actions and identify potential issues, as well as spotting bottlenecks during app startup. This will be easy to implement if you clearly defined your API and network entities. Another interesting and useful metric I recommend is annoyed tap. This metric tracks situations where the user repeatedly taps on the same UI element, which may indicate frustration due to something not working properly. Such a metric will be easy to implement if you have a clearly defined entity that handles the business logic of the screen, such as interactor, controller, or view model. That's it for today. Thank you for your attention and interest in the topic. I hope you get a better understanding of how to start implement observability in your iOS own projects. Best option. However, implement.
All right, boys and girls, that was your very first session of the day. Unfortunately, that was recorded, so we cannot take a lot of Q&A. But still, if you have any questions, you can make sure that you drop it in the chat, and we will pass it on to speakers. We now move to the next session of the day, which is also actually recorded. But these are really nice sessions, and we really wanted you all to go ahead and actually watch it. So that's why we put it live. You also find it on YouTube. uh, and our other platform on C Sharp TV. So next session we have is actually from Zang. He is actually a senior software engineer at TikTok. Right, that's a very cool app, and he's going to talk about bootstrapping a tech stack, architecting for agility in small business. I'm not going to take a lot of time because I know maybe we're running a little over, and we have to be on time. So the next session is by Zang, who works at TikTok as a senior software engineer.
Everyone, thank you for joining us today. My name is Zhiya Zang, and I'm thrilled to share insights on how small and medium business can effectively bootstrap a tech stack to support agility and growth. In today's competitive market, leveraging technology is not just an option, but a necessity for SMBs to thrive. Over the next 30 minutes, I will explore strategies to build a scalable tech stack with limited resources. We will cover various aspects, including the current SMB tech landscape, key factors to consider when selecting technologies, and the specific recommendations for both front-end and back-end technologies. Additionally, we will dive into infrastructure choices and share some lessons learned from real-world implementations. By the end of this session, you should have a clear roadmap to guide your tech decisions and drive your business forward. So, let's dive right in. Let's begin by understanding the current SMB tech landscape. Small and medium businesses are the backbone of our economy, employing millions and driving innovation. However, this business face unique challenges, especially when it comes to technology adoption. According to recent studies, SMBs contribute to over 40% of the GDP in many countries and are responsible for generating more than 60% of new jobs. Despite their critical role, many SMBs struggle with limited budgets, lack of technical expertise, and the rapid pace of technological change. Technology is not just a tool for SMBs, it's a vital partner for survival and growth. Bill Gates famously said, how you gather, manage, and use information will determine whether you win or lose. This highlights the critical role of technology in managing information and driving business success. As we proceed, keep in mind that the right tech stack can empower SMBs to compete on a level playing field with larger enterprises. It's about making smart strategy choices that align with your business goals and leveraging technology to achieve sustainable growth. Despite the opportunities technology presents, there is a significant digital divide that SMBs must navigate. Many small businesses struggle to keep up with the rapid pace of technological change. According to a recent survey, 45% of SMBs report needing stronger digital tools to compete effectively. This digital divide is exacerbated by several factors: limited access to capital, lack of skilled personnel, and inadequate infrastructure. Smaller businesses often find it challenging to invest in cutting edge technology or hire specialized IT staff. Moreover, the fast evolving tech landscape can be daunting, making it difficult for SMBs to identify and adopt the right solutions. However, this digital divide also presents a tremendous opportunity. By leveraging the right technology, SMB can overcome resource limitations and compete successfully in a digital world. The key is to identify and implement technologies that are both affordable and scalable. providing the flexibility needed to adapt to changing market conditions. Today, we will discuss how to bridge this divide by making informed, strategic tech choices. The challenge for SMBs is clear: building a scalable tech stack with a limited budget and expertise. However, this challenge also presents a significant opportunity. The right tech stack can drive efficiency, growth, and competitive advantage. It can streamline operations, enhance customers' experiences, and provide critical insights for decision making. For instance, automation tools reduce manual workloads, freeing up staff to focus on strategy. Customer relation management systems can provide a unified view of customer interactions, helping to personalize marketing efforts and improve customer satisfaction. Business intelligence tools can transform raw data into actionable insights, guiding strategic decisions. As we discuss specific technologies and strategies, focus on how these solutions can be tailored to fit your business needs and resource constraints. Remember, a well chosen tech stack can transform these challenges into stepping stones for success, enabling SMBs to punch above their weight in a competitive market. Before diving into technology selection, it's essential to define your business goals and requirements. Your technology should serve your business, not the other way around. Start by asking key questions. What are you trying to achieve? What problems are you trying to solve? What specific features do you need? Clearly defining your goals ensures that the technology you choose align with your business objectives and can effectively support your operations. For example, if your goal is to improve customer engagement, focus on technologies that enhance user experience and provide robust analytics. If your objective is to streamline operations, look for solutions that offer automation and integration capabilities. It's also important to consider scalability. Ensure that the technologies you choose can grow with your business, accommodating increased workloads and additional functionalities as needed. The goal-oriented approach will help you make informed decisions and avoid unnecessary investments in technologies that do not add value to your business. Agility and flexibility are crucial when selecting technologies for your tech stack. Cloud-based solutions are particularly beneficial as they offer scalability and flexibility, allowing you to adjust resources as your business grows or as market conditions change. Avoid technologies that lock you into a rigid infrastructure, limiting your ability to adapt. Instead, choose solutions that support modularity and integration, enabling you to add or remove components as needed. For instance, microservices architecture allows you to develop, deploy, and scale services independently, facilitating rapid innovation and adaptation. This flexibility is vital for responding quickly to new opportunities or challenges, ensuring that your tech stack remains aligned with your evolving business needs. Additionally, consider adopting DevOps practices to enhance agility, enabling continuous integration and continuous development to speed up development and release cycle. Cost effectiveness is a key consideration for SMBs, where every dollar counts. Prioritize technologies that offer a good return on investment. Look for solutions with transparent pricing and no hidden costs, which helps you manage your budget more effectively. Open source alternatives can also be a cost-effective option, providing robust functionality without the high costs associated with proprietary software. For example, open source databases like PostgreSQL offer enterprise-grade features without licensing fees. However, it's important to consider the total cost of ownership, including implementation, maintenance, and scalability. Evaluate the long-term benefits and potential cost savings of each technology. Sometimes a higher upfront investment can lead to significant savings and efficiencies over time. For instance, investing in automation tools can reduce operational costs and increase productivity. By carefully assessing the cost effectiveness of each option, you can ensure that your tech investment deliver maximum value for your business. When it comes to web development, a component-based framework like React is highly recommended. React is an excellent choice for front-end development due to its robust component-based architecture, which promotes reusability and efficiency, making it ideal for building scalable applications. With its virtual DOM, React ensures high performance and seamless user experience, even in complex projects. The extensive ecosystem surrounding React, including tools like Redux for state management and Next.js for server-side rendering, offers a comprehensive solution for modern front-end needs. Moreover, React benefits from strong community support, which guarantees continuous updates, a rich library of third-party components, and thorough documentation, helping developers stay at the forefront of technology. Its flexibility and compatibility with various backend frameworks and RESTful APIs make it easy to build dynamic and responsive user interfaces. The declarative syntax and JSX in React allow for more readable and maintainable code, isolating development, and reducing the potential for bugs. By adopting React, developers can streamline their workflow with powerful tools like the React Developer Tools extension, which simplifies the debugging and state management. Its widespread adoption in the industries make it easier to find experienced developers, reducing hiring and onboarding costs. Additionally, React's backward compatibility and long-term support make it a safe, future-proof choice for enterprise-level projects. Finally, React's ability to efficiently manage complex UIs contributes to a more consistent and polished user experience across platforms. For mobile app development, consider using React Native. React Native's architecture promotes code reusability, enabling teams to share logic across web and mobile platforms, which further streamlines the development process. The continuous updates and strong backing from Facebook ensure that React Native remains a reliable and future-proof choice for mobile app development, making it an excellent investment for companies looking to deliver high-performance, cross-platform mobile solutions. React Native is an outstanding choice for creating high-quality native mobile apps for both iOS and Android. From is crucial. Go and Python are both powerful backend programming languages, each with distinct strengths, making them suitable for different types of projects. Python is a highly versatile language known for its simplicity, readability, and extensive libraries, making it an excellent choice for projects that require rapid development, such as web application, data analysis, machine learning, and automation tasks. Its large ecosystem and active community support mean that developers can find ready-made solutions for almost any problem, speeding up the development process. Go, on the other hand, is a statically typed language designed with performance and concurrency in mind. Its lightweight, natural, and efficient memory usage make it ideal for building high-performance, scalable systems such as microservices, cloud-native applications, and network servers. It promotes a clear separation of concerns by organizing the system into distinct layers, each with well-defined responsibilities. By decoupling the core business logic from external dependencies like database frameworks, clean architecture ensures that changes in one part of the system do not have unintended ripple effects throughout the codebase. This separation enhances the testability of the application, as core service can be tested in isolation from other components. Moreover, clean architecture supports long-term maintainability by making the codebase easier to understand, modify, and extend, reducing the technical debt over time. It's particularly beneficial for large complex projects that need to evolve and scale, as it provides a solid foundation for managing change and ensuring that the system remains robust and adaptable to new requirements. When talking about API choice, GraphQL and REST are both powerful API solutions, each suited to different types of projects depending on specific needs and use case. GraphQL is an excellent choice for projects that require efficient data fetching and flexibility. With GraphQL, clients have the ability to request exactly the data they need, reducing overfetching and underfetching issues commonly seen in traditional REST APIs. This fine-grained control over data retrieval makes GraphQL particularly well suited for complex applications, such as those with rich user interfaces or multiple client types, like web, mobile, and IoT devices. Additionally, GraphQL's strong typing and self-documenting schema improve the development experience and reduce the likelihood of errors. REST, on the other hand, is a mature and widely adopted API solution that excels in simplicity and scalability. REST's resource-oriented approach, using standard HTTP methods and status codes, make it easy to implement, understand, and debug. REST APIs are highly compatible with web applications, web technologies, and can be cached and secured using standard web protocols, making them ideal for applications where simplicity, scalability, and compatibility with existing systems are key. REST's stateless nature also allows it to easily scale horizontally, handling a large number of client requests efficiently. Selecting the right database is a crucial decision for your tech stack. PostgreSQL is a powerful and reliable relational database that is highly recommended for projects requiring robust data integrity, advanced features, and scalability. Known for its strong support of ACID properties, PostgreSQL ensures that your data remains accurate and consistent even in the most demanding environments. With its extensive feature set, including support for complex queries, full text search, and JSON data types, PostgreSQL is well suited for applications that need to handle a wide variety of data types and structures. Additionally, PostgreSQL's advanced indexing techniques and ability to optimize complex queries make it ideal for applications with high performance requirements, such as those involving large data sets or real-time analytics. PostgreSQL is an excellent choice for projects that demand a robust, feature-rich, and scalable database solution, particularly with data integrity, complex query capability, and performance top prioritize. Cloud infrastructure is essential for scalability and cost management. Leading providers like AWS, Azure, and Google Cloud offer scalable infrastructure with pay-as-you-go models, allowing you to scale resources up or down based on demands. This flexibility is crucial for managing costs and ensuring that your tech stack can handle growth. Additionally, monitoring tools such as Splunk, Datadog, and Prometheus are essential for real-time insights and issue detection. These tools help you maintain the health of your systems, quickly identify and resolve issues, and optimize performance. As we wrap up, let's reflect on some key lessons learned. First, embrace cutting-edge technologies when it makes sense for your business. Do not be afraid to adopt new solutions, but evaluate them carefully to ensure they meet your goals. Second, keep it simple. Avoid unnecessary complexity that can hinder maintenance and growth. Simplicity often leads to more manageable and scalable systems. Finally, remember that your business model is your architecture. Let your business needs drive your tech decisions. By aligning your tech stack with your business goals, you can create a robust foundation for growth and agility. Thank you for your attention. I hope this presentation has provided valuable insights into bootstrapping a tech stack for agility and growth in small business. If you have any questions, you can reach out to me via email for any further discussions. Thank you once again, and I look forward to your questions.
Well, everyone, that was a recorded session by Zang. Unfortunately, the voice was very low. I totally understand that. We'll make sure that when we upload the recorded version of it, we work on that audio. And now the real conference actually starts. The first two sessions were only recorded, and we all are really looking forward for the next 11 live sessions that we're going to have. I know it's off here in many parts of Asia, right? It's not working day, but I see we still have about 200 people joining in at this instance, and in about an hour and a half, it will reach to 600. The other day, we had around 7 to 8,000 people tuning in. I'm really excited for the next session because the next speaker we have is Yevgen. He's a system architecture consultant, and he's going to talk about socio-technical engineering and the roles in software projects. Kind of tongue twister there, but please welcome Yevgen from, I think he's from Germany. Let's welcome Yevgen to this conference. Hi, Yevgen. Welcome to the conference.
Hi, Steven. Yeah, thanks for having me. So thanks also for the introduction. Now I don't have to introduce myself. And welcome everyone to the session on socio-technical engineering and the role of roles in the software projects. So the topic sounds very complicated, but no worries. It will not require any know-how, any knowledge. So I will just entertain you for 30 minutes or so, and then probably we will have some time for discussions. So I was going to introduce myself, but you already did it, Steven. As you said, I live in Brussels. You see it clearly. It is the middle of the Europe. I am a systems architect. My customers are usually from the transportation area, from logistics, or from medical devices. And as you said, I am an organizer of IT meetups in my home village. And working as a software architect, I did realize a couple of years ago that as a software architecture is being considered as a technical field, but we operate in a more complex socio-technical environment where we have to deal with social and technical aspects. And that made me realize that we have to rethink the role of software architecture at all. And I started to think about the definition of what the software architecture or systems architecture could look like. And to answer this growing complexity of socio-technical work of systems architects. And after reading a lot of definitions of system architecture, I found out the one which was the more appealing to this reality, which is systems architecture would be the navigation of complexity in projects. And I would visualize the role of a systems architect as someone who writes the curve of the residual uncertainty, because the complexity comes from uncertainty. And the role of a systems architect would be to write this curve of residual uncertainty and to understand the sources of the uncertainty. And if an architect faces some discussions about, some technical discussions, for example, about the database technology, he or she would say, okay, guys, this topic is very important, but it is not on the curve of the residual uncertainty for now. And the goal or the mission of the architect would be to understand what are the current topics to be placed on this curve of uncertainty. And while writing this curve of the residual uncertainty, I was trying to understand what are the sources of the uncertainty and complexity. And after some thinking, I've developed this quadrant with 4 different sources. First of all, the technical uncertainty. So this is a classical uncertainty that we as architects are already familiar about, where we have to hedge technical options under the given risks. But there are also different other sources of uncertainty. For example, the domain uncertainty, where we start to develop a project without fully understanding the domain, or operational uncertainty, where we have to plan something without knowing how much time or cost will it take, or even the political uncertainty, where in any organization, political tensions emerge from the interests conflicts of different agents. And for sure, there are already some proper established methods that try to bridge different sources of uncertainty. For example, domain-driven design bridges technical and domain uncertainty, or team topologies or org topologies or unfix try to bridge technical uncertainty with operational uncertainty. But as of today, I don't know any approach which addresses all these 4 sources of uncertainty that we face in reality. And that makes kind of the discrepancy between what the systems architecture can offer today and what is expected from it today. And based on this discrepancy, I was trying to figure out a new holistic approach that really addresses these 4 sources, 4 dimensions of uncertainty, to make the navigation of complexity in software projects easier. And the idea that I want to share with you today is very, very simple. Basically, social technical systems like software projects, where we have social structures like people and teams, and technical structures, like the software we produce, they are very complex. But at the end, they are systems, and we can approach them like any other systems. For example, like for any other systems, we have different phases or different aspects of systems engineering. We have requirements engineering. You see this here on the left picture, the biblical code given Moses, the 10 testaments, commandments as a requirements documentation or specification. After that, we have design phase. You see here the biblical code designing a human being, or you see here on the right the troubleshooting, which we do for the normal systems as well, but we can do it also for the socio-technical systems. You see here this great flood, where as a biblical code have seen, okay, I've created the humanity, but they didn't perform well. I have to troubleshoot it, so I will reset everything by sending this great flood. And by this approach or this mindset, I would define socio-technical engineering basically as classical systems engineering, which is very common, applied to socio-technical systems, which are basically our software organizations, software projects, and so on. And in today's talk, I will just guide you through these three aspects of systems engineering, but applied to socio-technical systems. But first of all, small disclaimer, I don't see socio-technical engineering as a method. It is rather an approach to think about socio-technical systems or mindset. And within this mindset, within this approach, you can use multiple methods: Scrum, Safe, domain-driven design, team topologies, so whatever you like. Socio-technical engineering is just a way of thinking of socio-technical systems as classical systems. So let's start with requirements. As you know, for technical systems, we have functional and non-functional requirements, and we can also define functional and non-functional requirements for socio-technical systems. Let's start with functional requirements. They're quite obvious. For example, the project X should develop the product Y. It sounds very straightforward, but it also is loaded with a lot of information, useful information. For example, it means that the project should just build the product Y, but nothing else. Or it also means that the project X have to build a lot of artifacts with the product Y. It's not only the software, it is also some requirement documentation, it is a test plan, it is maybe a project handbook. And this list of technical artifacts will help to guide both technical and organizational decisions, because if we know the list of these artifacts, we know which roles do we need, and we know which people we have to hire to fulfill these roles to deliver this set of artifacts. This requirement is very simple and obvious, but it showcases the role of requirements because they can help navigating design decisions. We have also other examples. For example, like if you want to sink costs by 40%, it is usually positioned as organizational requirement, but it is actually a socio-technical requirement because we have to make some changes in our social architecture of organization and both in technical organization of the systems and artifacts we create. Another example, we want to build a platform for other products. It's also a socio-technical requirement because one thing is to build a technical product to a technical project platform, but other thing is to make changes in the organization structure so that other teams and departments will use this platform. So these were functional requirements, and as with technical systems, there are also non-functional ones, like availability or development availability. One can specify a requirement like we want to be able to make any technical decision without relying on a single person for approval. Maybe you are familiar with a situation where someone says, oh, we can't make this decision because lead architect or the project lead is on vacation. So this was a case where the development was not available because of the vacation of the single worker that is able to make decisions. And it is not bad or good, and absolutely, the question is what requirements you have. So this requirement clearly conflicts with another requirement, making a project lead, for example, efficient. The question is not what is bad, what is good, but which requirements you have. And making these requirements transparently will have to guide the technical and social decisions. Another example is development scalability, where one might say, okay, we want our organization to be able to increase productivity by hiring more people. But as the experience shows, often what happens is that more people gets hired and the organizations becomes even less performant because the technical architecture is not prepared for it. And having requirements like this will help for sure social and technical architects anticipate those changes and prepare architecture, both social and technical one, for requirements like this. So this was about requirements. So basically, requirements have to navigate both social and technical decisions. They also help to reduce complexity and navigate social and technical discussions. They also help to verify the system design against the set of requirements, because if we don't have requirements, we don't know how to verify our social technical system. Now, having requirements in place, we can go to the next chapter, which is design. And the idea here is very simple. Basically, design of any system is making arrangement decisions about systems elements. And if we understand what are the system elements in socio-technical systems, and what are the arrangement decisions in socio-technical systems, then we get a language to describe our socio-technical design. And with the help of this language, we can express our design, we can communicate it, and we can discuss it. And afterwards, we can even use tactics and design patterns for solving structurally similar requirements in other systems to fulfill also our functional or non-functional requirements. So let's go through these three aspects of system design. First of all, system elements. So what are the system elements in socio-technical systems? One can answer this question by looking on what happens in software projects. In software projects, people work on artifacts according to their roles. Basically, we can visualize this on this entity relationships diagram. We have persons, people, we have roles, and we have artifacts. The roles are allocated to people, people work on artifacts, and other roles could be stakeholders of artifacts. For example, Cassandra is a person, and the role of lead architect is allocated to Cassandra. So it's like allocating some service to a worker instance. And we could define the role of lead architect as responsibility for software architecture documentation. So basically, in this notation, the role is not defined by what the person on who the role is located is expected to do. The role is just defined as a responsibility for certain technical artifact. And we could also say that the role of software engineer is a stakeholder of the artifact software architecture documentation. And what one can do in software projects to draw the socio-technical system design, one can play this role and artifacts mapping by showcasing what artifacts does the system have. For example, in the middle, you see here artifact software architecture documentation, which role you have in the project. For example, here software architect, somewhere here product owner, and so on, and which people you have in the project. For example, here Eva, Chris, and Kate. And then you can look whom we allocate the roles, like here the product owner role is allocated to Kate, or which roles are allocated as responsibilities for artifacts. For example, software architect is responsible for software architecture documentation. And one can draw this infinitely big, large diagrams to showcase the dependencies and relationships in the project. Because following this diagram, one can say, okay, Kate is a product owner. We know that product owner is a stakeholder of this artifact, and this artifact is held responsible by the role software architect, and the role is allocated to Cassandra, which basically means that Kate can go to Cassandra and express her information needs so that Cassandra knows what to put in the software architecture documentation. So basically, these diagrams can help people to get in touch and understand what are the information needs of each other. So these were elements. Another part of this design language would be design decisions, arrangement decisions. So first of all, we have decomposition decisions for example, you want to split project organization into teams, or you want to split the system into subsystems, into subcomponents. This is the first type of this first kind of arrangement decisions. After you split it, the question is how to integrate it. For example, how to integrate two teams. Should they have some scrum of scrums, or some weekly, or just a Slack channel to integrate their work? Or should two components be integrated by middleware or database or synchronous communication and so on? And the third type of arrangement decisions is allocation. As we saw previously, to whom we allocate the role of lead architect, or where do we want to allocate the component X? Should it be allocated on an edge device like smartphone, or should it be allocated in the cloud? So these are the examples of allocation decisions. And with the help of system elements and arrangement decisions, we can now express the socio-technical design of any socio-technical system. We can verify it, comparing it to the set of requirements. We can discuss it with other people, we can communicate it, and so on. But what we also can do is to use patterns and tactics from other systems to fulfill similar requirements. So it is basically the classical biomimicry, where we use in technical design the patterns we see in the nature. Here's an example how it could work. Let's go back to our availability requirement. If we want to be able to make any technical decision without depending on anyone, if this is our requirement, what we can do is to look into the catalogs of available patterns and tactics for availability. For example, in this book, Software Architecture and Practice, you can find nearly 30 tactics to address availability requirements. For sure, not every tactic is applicable for your use case, but you can use these catalogs as checklists for inspiration. I will just pick a couple of them to see how we can approach our availability requirement. First of all is the redundant pair, where we just say, okay, we have one role and we allocate it to two persons, which basically means that every one of these persons will be not so efficient as it would be if it would be the single worker instance, because two persons have to sync with each other on the daily architectural stuff. But this reduction in the performance will ultimately lead to the increase of the socio-technical availability of the role lead architect. Another idea would be to use a combination of two tactics, self-test and the removal from service, where we just will remove one service component from service and see what happens. What we can even do is to write BDD-style tests for it, like given the allocated lead software architect is on vacation, when an external software architecture audit for the project is requested, the audit should not result in any major findings. So what we can do, we send Cassandra on vacation, or just wait until she goes on vacation, and then request the audit and see how the audit results. And then we have either green or red test case, and if it's red, we can change the system design to address this issue. So this was design, basically like for technical systems. If we have a language of elements and decisions, we can express design, we can verify it, and we can reuse other patterns and tactics from other domains to fulfill our own requirements. And the last part of this talk is about troubleshooting, because like any other system, socio-technical systems might have bugs, and we have to fix them. For sure, there is no universal solution to fix all bugs and all systems, but what we can do is to follow generic principles of troubleshooting. And the first is that the bugs are relative. If we don't have requirements, then there are no bugs. For example, if someone complains we have too many technical bugs, and if there is no requirement on quality of the software, then it's works as designed. Maybe the requirement was to deliver something very quickly. It's no wonder there are so many bugs. The same is if someone complains that one has too many meetings, maybe it works as designed. If there were a requirement to have distributed remote teams, then it is clear that they would need to meet often and align on their work. So it might work as designed. And the conclusion here is that there is a difference between bugs, which relate to requirements, and perceived bugs, which are just something not going as expected. And in order to make perceived bugs to real bugs, one has to change requirements and maybe change design. Anyway, if you want to make these bugs as proper bugs, we have to create new requirements to navigate the solution. Another idea would be that in complex systems, it doesn't make sense to solve problems because, as Russell Ackoff, it was a complexity scientist, said that in complex systems you have messes as systems of interconnected problems, and these messes, they basically generate problems. And instead of solving problems, because problems are just symptoms, one has to resolve messes that generates those problems. And we can apply this mindset also for socio-technical systems. For example, let's take the meetings problem. If a project has too many meetings, then it doesn't make any sense to make the meetings more efficient. Like there are common policies. Let's allow people decline meetings if they have nothing to contribute, or one can make meetings more efficient by appointing a moderator, or one can cluster all meetings in the first part of the day, because it makes the meetings more efficient, but it will not solve the mess which creates the meetings. And if you want to understand what is the mess that creates so many meetings, we have to look into the socio-technical architecture of the system, socio-technical system, which could be that there are two teams in the projects. One team is responsible for one component, another one for another one. These two components have fetch dependencies, which results in two teams having meetings over those because neither of the teams can make any decisions on their own. And so this is basically the mess that generates so many meetings. And one can dissolve this mess by bringing two technical components into one and making team A being responsible for this new big component, and the team B is now free. They can go and eat ice cream. Anyway, the meetings problem will be dissolved. So basically, that's it. As I said, the socio-technical engineering is nothing else but systems engineering for socio-technical systems. And with this approach, you can write requirements for socio-technical systems, you can design them, and you can troubleshoot them like any other systems. You can also apply this approach in practice. For example, in your organization, you can run socio-technical engineering workshop where you will understand the context of the socio-technical system. So what is within the system, what is outside of it, which people are inside, which are outside, which artifacts are inside, which are outside. Then one can gather requirements, as we've seen, functional, non-functional ones. One can document design, socio-technical design, by applying, for example, roles and artifacts mapping. And if there are already some existing messes in project, one can dissolve them by following the two generic ideas I've presented today. So if you are interested in socio-technical engineering, I just started to write a book on it on LeanPub. It's just the beginning, but I will publish the progress on LinkedIn and my website, complexitynavigator.rocks. If you're interested in the topic, I would be very glad to stay in touch and exchange ideas with you. Thank you very much and for your time and patience, and I hope that we have some time for questions and discussions.
That was an absolutely great session, Yevgen. First, I would like to ask, how do you say your name? I usually mess it.
Sorry?
How do you say your name? I usually mess people's name. How do you say your name?
Yevgen.
Yevgen. Okay, perfect.
Yeah.
Yevgen. So Yevgen, I think this session was not just for software architect. It was anyone who's who want to take a lead in their organization, right? Anyone, maybe it may be a developer or maybe someone at the leadership, because this is not just about the architecture. Because in one of the last slides, you talked about the meeting mess, right? I think everyone should be thinking about how not to make a mess in the meeting, right? I mean, the slides. I mean, I look at this one. um, this is so cool. I would like if just you could focus on the solution again, right? You said team A, team B, right? They have a lot of dependency, and you take them on an ice cream. I really couldn't actually. If you could just explain that once again, it went over my head.
Okay. So basically, the mess here was that the dependencies between technical components would lead to
Mm-hmm.
dependencies between teams, and dependency means nothing else but meetings.
Yeah.
And if you see there are so many dependencies, why not merging these two subcomponents into one big component and making one team being responsible for it? So this would automatically reduce the need for meeting with another team and maybe even make better technical component. And then team B is now, released from their duties.
Yeah, I was scared about that. Yeah, Yevgen, I was scared about that. What happened to the team B?
Yeah,
They
they can make
fired.
something else. Yeah, no, there is hopefully enough work for everyone.
Yeah.
But
Yeah,
for
I saw
sure,
that
they
ice
can start
cream.
with eating ice, ice
Yeah,
cream.
I saw that ice cream on that side. That's why I kind of got confused that what happened to the team B there. But perhaps they could be moved to some different roles, right? There are many, there are more jobs than the people we
Ah,
have, so it makes sense.
okay, so you're concerned about people who can eat ice cream and not about people who have to do all the work.
Because this is a very true problem, Yevgen, right? We get on n number of calls that are useless. We get on a call to decide on what we're gonna do in the other call. Sometimes that's what happens on Mondays, right? Okay, Simon. Okay, tell what are the meetings that you have? We have a meeting that we're deciding on the number of meetings that we're gonna have this week. So I clearly feel the pain that we end up doing a lot of unnecessary meetings and here and there. So that is I was really concerned about this slide because this got me. Uh, so there's a question coming from one of the comments from the audience, right? And that is by Rohit is asking how do you effectively elect requirement for socio-technical system, and what are the key differences compared to traditional systems engineering?
Phew. So for eliciting, I would just use classical navigation.
Hmm.
Like, okay, we have functional, non-functional ones, so we have already some framework to think about requirements, and within non-functional, we have all this entities like availability, reliability, scalability, and so on. And maybe we can try to reinterpret this classical, even performance or security requirements in the domain of social technical systems.
Hmm.
Key difference, well, I would say the main difference is that these requirements will address both social and technical decisions, even political ones, and one needs someone being able to make those decisions on this higher level. Because if one
Yeah.
has independent project manager and lead architect, everyone is responsible for their own domain, but the domains are interconnected, so it doesn't make any sense to write overarching requirements.
Yeah, I'm also curious, Yevgen, how did you come up with all these solutions? I mean, this problem, then solution. Did you look at any of the resources, or it's all coming from personal experience? Because we have not had this kind of session for the software architecture. This is the third edition we are doing it. This is a very unique presentation. How did you come up with this kind of presentation and these problems and the solutions?
Yeah, maybe from personal pains, because I was not
Yeah.
convinced by the software architecture books. They're purely technical, and they don't
Yeah,
address the social dynamics in the projects. And
that's right.
I was just searching for something more holistic.
Makes sense. There's another question that we got from the C Sharp community. It's by Tilak. He's not here, but the question is: can you discuss the challenges of integrating new rules into an existing socio-technical system? I think that is
Okay.
question number one. Yeah.
Yeah, so basically, my assumption is that we don't need roles because we need them. We need to deliver some artifacts, and roles are responsibilities for those artifacts. And so basically, the creation of new roles means that we need new artifact. And once we create this new artifact, we know, okay, we now need a new role for being responsible for it. We know that we need some people to whom we can allocate this role. We know who are the stakeholders of these artifacts, and we know how to connect the new person or new role with the already existing set of roles and people.
I see. All right, that helped. Thanks for the question, Tilak. Okay, I don't see any other questions here because I think this session, as I say, I'm repeating myself, it's quite a very new, right? So, never mind. So, Yevgen, right? Before we move to the next session, I'm asking this question to everyone. So, I would also like to ask this to you: that other than all this technical stuff or architecture and all this problem solving, what do you do in your free time? What are some of your hobbies?
Okay, I organize IT meetups, as you showed in the introduction.
Yeah. Okay. Yeah, that's right. So, all right, Yevgen, any final thing you want to plug in? Any final thing you wanna say before we wrap it up?
Okay. No. Very many thanks to you for the organization. A great conference, and wish you all great talks today that
Yeah.
are inspiring.
Yeah, thanks to you for putting your word out on social media, right, and helping us promote this conference. Thanks for accepting the invitation. I know it's a work day, so taking out time for us, I really appreciate it. We'll stay connected, and we'll hope to see you in some other conferences that we do.
Thanks, Simon.
Thank
Have a nice day. Have a great
Yes,
conference.
yeah.
Ciao,
You too.
ciao.
Bye bye. All right, ladies and gentlemen, that was Yevgen for you from Germany. Quite a unique presentation. Either I don't think so we're gonna have any presentation like this in next a day and a half. So if you have missed, just in case, you can actually wherever you're watching now, you're watching Facebook, YouTube, Twitter, Twitch, Sharp TV, wherever you're watching, you can actually just go back and move the slide back and rewatch it, or you can all come back to the same link again. Or if you actually register for this conference, we're gonna send you all the recording links by Monday or Tuesday. Hopefully by Tuesday, we'll send you all the recordings along with their links. And before we move to the next session, I really want to talk about some of the in-person events that we do at CSharpCorner. There's a conference happening here in Delhi, India, from October 17 to 18. It's a BCrypt conference that we do. It's around Web3. One of our teammates made a really nice video around it. So let's spend a minute there, and I'll be back.
Hello everyone, join us for BCrypt, one of India's largest Web3 and AI conference, which is taking place in Delhi on the 17th to 18th October 2024. This conference is designed by developers for developers. But why India? We chose India for its vibrant tech scene and its path to becoming a global economic leader by 2027. BCrypt offer a unique platform for professionals to connect, learn, and grow in the field of Web3 and AI. Be a part of this landmark event and seize the opportunity to contribute to India's tech journey. Hoping to see you all in this conference. Visit bcrypt.live for more.
Right, everyone, I'm back once again, and our next speaker is still not here, and the reason being he is having some problem with his system. But I quickly wanted until he joins. Right, we did talk about the Beacon conference that we're doing in October here in person in Delhi. I also want to talk about some of the other events that we do. The upcoming event that we have next week is the React and Chill conference. It's going to take place from August 22nd, and I think we'll extend it to even 2 days. You can go ahead and register for this conference. This conference is just for the React framework or the library or the framework, the way you want to call it. We're still adding few speakers here, but we already have Arna, Benzi, David. We have speakers from Meta. We have speakers from Red Hat. So go ahead and register yourself at the React and Chill conference, and I'll also see you there. This is the second day of architecture conference. Tomorrow it ends, and the next week around the same time, I think it's Wednesday? Yeah, next week actually on Thursday, exactly around the same time, we start the React conference. You'll see more speakers being added here, about like 10 more. So please go and register yourself, and I'll see you there too. With that said, I now see our next speaker has joined behind the scenes. Hooray! Okay, so we'll give him some time as he works on his slides. But let's talk who the next speaker is. Next speaker is he's a very popular guy now in the CSharpCorner community. Definitely here, right? He speaks. He's a very good friend to us. Runs his own community. Speaks at many conferences. He's Jose Luis. I always say the last name wrong, so I'll just say Jose Luis is going to talk about AI architecture, and why not? If you remember, very some time back, we hosted him for the other AI session that was pretty cool. There were some demos. We loved it. He's going to talk about AI architecture, what is possible today, and future trends. So without any further ado, let's bring the gentleman in. So, Jose, how are you doing today?
It's very hot, and yeah, and it's been a busy day, but happy to be here. Presentation was beautiful. Thank you so much, Simon.
Oh, thanks for all that last minute hustle with your system, right? I know it really makes us nervous, right? Hey, I cannot join in 96%. Then again starts to load system. My
So, long story short, my computer decided to crash and reinstall a Windows update just before kind of 4 minutes ago. So,
yeah, but you're on
lucky I'm
time.
here. Yes.
So I won't take much of your time, Jose. Please feel free to go ahead and share your screen, and we shall
Perfect.
do the chit chats toward the end.
I'm going to share my screen. Entire screen, screen 2. I will not share my audios. I don't have it.
I see your screen. I've added it to the stream, and next 35 minutes is all.
Beautiful. So let's count. Let me put my timer because I got it pretty packed. So let's start. All right. Today I'm going to talk about AI architecture, trends and components, and share with you my personal points of view. As a frequent speaker on AI topics and LinkedIn author with some courses on generative AI, I have one in semantic kernel, another in Azure AI that should be published end of this month, and soon starting one in AutoGen, Agentic AI. I hope this gives me some credibility. I will not call myself an expert, as you know, this AI world is crazy. It's super fast evolving, and this makes impossible for anybody to be an expert. But I would say I know one or two things, at least. So yeah, changes. I don't need to ask you if you are familiar with ChatGPT or generative AI, and probably the terms AI orchestrator or even LangChain, and maybe semantic kernel ring a bell, if not many. By now, I'm pretty sure that you have been playing with these technologies, and I can tell you that these are the core technologies of this new generative AI world. Um, so welcome to it. If you did not realize last year, at least in my work, I hear OpenAI, I hear ChatGPT, hi Vanshika, like every now and then. It's incredible amount of times I hear these words. So one thing before getting to it that I love about AI is the feeling when you're doing it that it can do surprising things and it makes you feel like a magician, like orchestra director, when you're playing with literally with digital brains, right? And this is what amazed me as well. The way you have to change your mind when interacting with these components that can think on their own, and listen to these words, think on their own, and they are non-deterministic, right? So for a developer, that's something really, or an architect, it's something really strange at the beginning. It gets you this aha moment when AI delivers an unexpected yet perfect result. That is truly priceless. Already, you will agree on me that this technology AI has a incredible disruptive potential. This writing and translation industry is in shock at the moment. It was already last year. And some call centers professionals lately have already started career conversions due to the voice chat, AI voice, and voice recognition interfaces, which in some products already in the market, they are performing better than 40 and 60% of some of colleagues or people that work on it. I got myself a friend that worked in translation. Well, uh, their business has not grown the last 2 years, and I'm falling quite short. But enough talk. Let's get started. Let's take a look at the current state of AI. Oh yeah, I got some here. Disruptions. Will AI replace the writers? You search for it. AI assisted novels are winning more. AI is disrupting the billion translation industry. Well, yeah, it's quite disrupting everything that we know as complete industries. Now going to call centers. So let's on the current state of AI. I love this slide. Let's start by understanding the limitations of current AI systems. First, RAG, retrieval and generation. Through you always when you do RAG, which RAG is okay, I do some take some text, a book, or some information from your company. I put in a vector database, and through vector similarity, I try to retrieve some information through keywords. So this is often very inaccurate because how much context can we put in there in this vector database? Usually you put that, you have to split in chunks of text, which sometimes you are dividing the knowledge in different pieces. And when you are retrieving, you don't get all of them. And sometimes you retrieve the wrong one, which happens quite a lot. So RAG is really, really hard. It's getting better. We will see that in a moment. And finally, well, next, the AI is hallucinating a lot. So that's a significant issue where models generate information that seems okay, but It's absolutely not. It's absolutely made up, right? And finally, maintaining the context over long conversations. So we went more from AI. Now we have models that have 1.5 million tokens, and this trend is growing, but they keep forgetting what we told. It's like we are talking with somebody and suddenly, hey, what did you tell at the beginning? I don't remember anything of it. So the same happens with AI. AI is different. So they have the tendency to remember what was told at the beginning and at the end, but in the middle, sometimes it forgets, right? So these are some of the limitations in here. But despite these limitations, AI continues to disrupt various fields with its potential. And it's really, really good at a couple, 3 or 4 things. One is NLP, natural language processing. This has revolutionized tasks like text summarization, translation, question answering. Sentiment analysis has also improved tremendously. So I would say now it's mostly perfect. And we have AI systems that can understand perfectly human emotions and intentions. This is known as theory of mind. And lately, very recently, it has been determined that it can also simulate and predict them. Not yet at the level of Harry Seldon psychohistory. If anybody gets and knows what I'm talking about, please raise the hand. That's very sneaky if you like science fiction like I do. And yeah, but those skills are already at human level, if not more. And finally, prompting techniques, including meta prompting, are enhancing AI responses, making interactions more relevant and precise. Next, I want to show you the Gartner AI Hype, which you may recognize. Yeah. So here, you can see that it provides a snapshot for various AI technologies and in terms of maturity and adoption on the different phases. I recommend you to search for Gartner AI Hub. I will not disclose or explain it in detail, but basically, you can see that composite AI and edge AI, these white ones here, are already in under 2 years, which is a plateau of productivity indicating their growing maturity in real world applicability, whatever their innovation trigger or peak of expectations, or it's this disillusionment, like more disappointment as well, but whatever. Composite AI is the combined application or fusion of different AI tactics to improve the AI solution, and it's at the center of GenAI as we know it at the moment. And also agent-based modeling is the next wave of composite AI, which is important. I will talk a bit about that. Multi-agent systems are on the 5 to, I think, should be to 10 years. So it's on these black, and it's quite okay. I cannot find it. I swear I saw it. Yeah. All right. So it's yeah. Multi-agent system is on the 5-10 year horizon. Even I cannot find it. Yeah, when we most need it. But it's important to see that it's 2 to 5 years. A lot of the AI technologies that you see here, it tells a lot that in 2 to 5 years, all the technologies that we know as AI will be measured. So that means that, yeah, we should get already there into learning if we are not learning them, and get our hands on it if we want to retain our skills as an architect or as a developer. As simple as that. As well, special mention to intelligent applications and knowledge graphs and cloud AI services. I'm curious as why AI engineering and Gen AI are at the top of the slope and about to go down the expectation hype here. As that's not my opinion, but that's Gartner, so we should trust Gartner. But yeah, to my to me personally, I would put some AI engineering on the plateau of productivity already, as partially, but I mentioned partially, take it with a grain of salt. To me, is business ready. That is the case for me in a very personal opinion with semantic kernel, but take it with a grain of salt. Not everything is ready there, but they are in a great direction. But what is in a great direction, and it's working, and it's out of experimental, it's working, and you can use it in business applications as of today. Here I put the Gartner AI hype link. I will share the links later in my Discord, and I will put, yeah, semantic kernel in this part, to my opinion, but that's completely my opinion already. Also, we can see here this is kind of a positioning of different large language models as of June 2024. This is taken from livearchitect.ai, and you can see even the last models of Opus and Sonnet, how good they score in GPQA. Yeah. This year, artificial intelligence is far smarter than humans across many metrics. I'm not saying smarter or more intelligent. I mean, they are scoring better. So they are doing better and playing smarter than we may think. This is a GPQA. This is Google Proof Q&A benchmark. Is one of the hardest benchmarks that determines according to the score, the IQ. So at the moment, if we look at the IQ, this should be at the level of 150, which is quite impressive. Opus and Llama are setting new benchmarks. There are more. I think a few days ago, we have the new Grok from Elon Musk, and it's about 56. So it's not yet updated, this graph. But basically, it's evolving, and this does not seem to stop this evolution of large language models. Multimodal AI models like GPT-4o are integrating text, image, audio, and even video data, opening up new possibilities for holistic and context-aware applications, including application in robotics, as we are seeing with OpenAI and other companies that are jumping in this robotic bandwagon. As AI becomes more pervasive, addressing security and ethical considerations as data protection and fairness is crucial. And finally, meta prompting is emerging as a valuable technique for guiding AI behavior and controlling it with guardrails. And this is kind of big overview of the current state of AI. So they are increasing their reasoning skills. They are increasing their multimodal skills. Yeah, and also there is this prompt engineering evolution towards meta prompting, which is nothing more than put a proper system prompt that kind of guides and protects the model, that it does not do something that you don't want to. Papers with code, dataset GPQA. See some more information on the GPQA. Is a very common framework benchmark. And let's say we have seen a bit the current trends. We are going to peek at the future trends and some of the current ones. A journey begins with the significant improvements in AI models that we just saw. As probably you will, this will remember a song, they are getting better, faster, stronger, and also multimodal. They are not only faster, they are also more efficient. So they are a lot cheaper than they were some years ago. Multimodal capabilities, they allow them to seamlessly integrate text, image, video, audio, and other kind of data, leading to more comprehensive outputs. In near future, I expect they will combine more abilities to generate code, 3D objects, or understand 3D vision, video, and more. And they will continue to evolve. That's not stopping. It's kind of a commercial race at the moment. Additionally, the advent of natural voice interfaces like the one I'm amazed, the GPT-4o voice, that everybody's eagerly waiting for it to be mainstream as an app and API, will make AI interactions incredibly human-like, enhancing user experience through various applications. And we come to one of my favorites, agents. What are agents? I mean, AI agents. I see them as an entity which brings together some reasoning abilities determined by the model, a persona, which is a personality that determines how it reacts or he or she reacts to situation or tries to perform a task, right? I told him, hey, you are Thor, and you're giving a tool, he will try a hammer, he will try to beat and break everything and solve everything with the hammer. I give it a banana, it will try to solve everything with a banana, right? Or I give it humor. I tell, hey, your personality is humorous. Try to solve everything with humor. You guess where I'm going? As well, these agents also have tools and the ability to decide which tool to use and how. The personality can range from being friendly and conversational to analytical and precise or pragmatic if you want an agent action driven. They can interact and respond to a user or to other agents, or interact and react to the environment as well. That's an agent. Yeah, this is a tool. This should be the personality, reasoning abilities. Yeah. Then we come to agentic AI, which is when we have more than one agent working together. This is a system when multiple intelligent agents collaborate to perform complex tasks, or one task, which is complex. These agents are usually designed with concrete capabilities. So it's focus, focus, focus. This enables them to do a single task, becoming experts on it. And that's highly important because models are kind of limited and they lose context very quickly and hallucinate. So the more focus you give them, the better they will perform. And on a conversational workflow, that usually is designed around them so they can interact in a very optimized way. Usually you have to streamline to resolve a task or set of tasks together as a human team would. Some advanced agents can perform self-critic and improve over time learning, which is the case for example, AutoGen, right? This collaborative approach opens up a lot of new possibilities for automation, efficiency, and scalability in various domains. And if you think about that, it's kind of very similar workflow that you do with your ChatGPT, just that instead of you having to type, you have an agent which will type for you, for example. So it saves a lot of time. Also, it's not just me. So the CEO of NVIDIA, yeah, AIs are going to be like employees in your companies. Also, Andrew and G, yeah, if anything to keep an eye on, it's AI agents. Also, Andy and G from Deep Learning, an incredible person. AI agentic workflows will drive massive AI progress this year, perhaps even more than the next generation of foundational models. And so on, and Accenture and McKinsey, and also Bill Gates is saying that. Oh, and I could fill 3 or 4 more pages which quotes from people that apparently know what they are talking about. Not like me, like I know 2 or 3 things. But I want to show you this picture. Agentic workflows are already providing huge benefits on some tasks. For example, this is it's a comparison between GPT 3.5 and GPT 4 doing zero shot and using agent workflows, doing this human evil. Human evil is coding benchmark. GPT 3.5 has 48% accuracy, zero shot. GPT-4, it has quite a lot more, 67%. But if we apply agentic AI, a simple critic workflow, it gets up to 96%. Of course, we do that with GPT-4, it gets a bit more, like 97, 98% more or less. So you can see the amount of improvement that this is bringing. It's pretty impressive. Sources and DNG, and I took this slide from him already. Other thing that I believe is current trend and it's started to appear, it was just launched, I think 1 or 2 weeks ago from LangGraph was launched, I think. It's graph-driven agents, so representing agent and agent workflows like a graph, a node and a vector that determines a direction. And this is the way architectonically to define properly agentic workflow, which involves 2 or more agents. Using graph structures with nodes and edges, the interactions between agents can be perfectly mapped and providing some benefits like cycles, controllability, and persistence, which enable loops, conditionals, and also keep a state after each step, which is good if we want to know what happened and why something happened, right? For business perspective, we would like to see why this failed and why did it succeed, so we can do backtracking and control how things are working, which is pretty cool. Also, we have graph RAG. To solve this hallucination process of retrieving the wrong chunks, a graph approach to do RAG, retrieval augmented generation, is an innovative way that combines the strength of graph structures, creating something called knowledge graphs. Basically, it has the previous implementation of vector RAG databases has limited contextual understanding, lacks scalability, and is very limited in real scenarios. Graph RAG does its magic by creating relations between the data chunks, creating a knowledge graph that interconnects them, indexes them, and organizes the data hierarchically in semantic clusters, and thus searchable and connecting basically everything. Of course, this is computationally very expensive, but also very successful, like day and night in RAG, and seems to be having a lot of success. Another one is distributed agentic AI. So taking AI agents and thinking how will they run at scale? How can we enable efficient collaboration across multiple locations, maybe in the cloud, maybe in local? And how can we achieve this desire of having fault tolerance and robustness? Sounds familiar, right? I'm talking like a distributed application in the web. So the same is for agentic AI. This setup allows for real-time collaboration as well, making ideal for applications that require continuous, distributed, and parallelized processing, such as smart grids and global monitoring systems. Just to put an example, the side attributes for this approach include being distributed, scalable, and both cloud and local ready. Even the first attributes mostly appear in the cloud. Key technologies that I see that will support this idea, and these are important, is actor pattern, kind of, for example, I would say Orleans. I mean, I know a lot about Azure, and I know it's widely used. It's one of the best actor patterns. So I would say this is one to properly consider, and then approach for graph and microservice architecture. But we have to see how this evolves and maybe explore a bit LangGraph. So scalable, efficient collaboration, cloud ready, resilient, actor pattern based, and kind of akin to microservices. That's what I would like. And of course, more important for a company, resilient. And that's it. We are going to kind of in almost last part, which is AI architecture. How can we, with all we have seen, the current AI components and the future ones, how can we map them into AI architecture? So first, I want to start by understanding the role of AI in modern architectures. My point of view is that just as databases and API systems were revolutionary in their time, AI is emerging as a crucial component in today's technological landscape. And these AI components, such as models as a service and AI orchestrators, are seamlessly integrating into existing architectures, enhancing functionality and enabling new possibilities, like literally connecting a brain that does a concrete thing to your application. It's something you can do since last year. I done that, so can you. I put here some links if you're curious. That's not it. So one of the key components in modern AI architecture is model as a service. And to my opinion, this allows AI model to be accessed as a service. When you connect to Azure AI service, you connect to Google, AWS, or directly to OpenAI, you are connecting to a service in the cloud, right? This approach, to me, is not only enhances scalability, makes it easier to update and manage in a way that they remain effective and relevant. And I see that in a C4 syntax, which I love, and I hope you're familiar with it, as another simple component, right? To me, this is nothing more than an external software system. If we are seeing here one system diagram. Then we have the component, I call it AI orchestrator. For me, that would be either LangChain, either semantic kernel, or anything that is managing an AI to get something done, right? And you put that as a component somewhere in your architecture. To me, that's an AI orchestrator. And this plays a crucial role in managing and coordinating the different AI components within an architecture. So to me, is if you see a component diagram, I kind of put it here in this case, component AI orchestrator. So that's kind of my approach when I do that in C4 syntax, which I particularly love. And they ensure that the different services work together efficiently, optimizing performance and integration, and act as the central nervous system of an AI-driven architecture, managing the workflows, delegating the work to, in this case, to the AI service, which can be in the cloud or can be deployed in a Kubernetes cluster or wherever you want it to be, depending on your data policies. Here, we can observe this internal component and also the component that we saw before. Very simple, right? And I don't think it takes more. And then there are two questions that I got from a good friend. How do you test a non-deterministic system such as AI? Well, to me, it's clear. Testing AI system is a critical aspect of ensuring the reliability. So if you do AI, you should test it, right? But how, given their non-deterministic nature? Traditional testing will fall short. It requires specialized testing frameworks. And these must account for the variability in the AI outputs. So ensuring that the systems perform consistently and accurately under different conditions. Essentially, simply said, you test AI with AI to assess this variability and understand the outcome, and if it matches expected one, within a range, of course. So nothing strange here. And then security, which is quite key. Security is paramount to AI system to ensure alignment and proper behavior. Techniques like meta prompting, which I mentioned, this is a prompt engineering technique to structure system prompts to help guide AI responses, reducing the risk of inappropriate or misleading outputs, and of course, avoiding potential manipulations, kind of a jailbreak, for example. Additionally, specialized security solutions are essential to protect against issues, kind of hallucinations and jailbreaks. I think a few months ago, airline went had to give an incredible offer that their chatbot proposed to a customer because the bot seemed to have legal commitment. So he said, "Yeah, I give you that for $5," and he got like kind of a incredible flight to somewhere, and they had to comply. So I would be careful because if somebody derives your chatbot into selling one of your cars, if you're selling cars for $10, maybe it's a good idea to put a meta prompt there, right? And secure that and put some guardrails and avoid some manipulations of evil customers, so customers that want to have fun. This another approach for meta prompting, aside from putting a strong meta prompt, which is a system prompt with additional layers, is to put a modifiable agents that do a supervision on the input and on the output. So these agents cannot be manipulated, cannot be modified, and only have to access this input and the output. So to ensure that they are safe. This input and output verification adds an extra layer of security and, of course, complexity and processing, but I think it's better that you're safer, right? I think I put an example here, and I think I put a link. No. But if you look for Microsoft Meta Prompt template, you will find it definitely already. And then to finish it a bit, let's take a look a bit at a couple of more things. I would like to share a bit my vision on AI agents in this case. We will soon be able to instantiate teams of AI agents to perform advanced tasks at the scale. Of course, technology has to evolve, so it's already doing so with LangGraph. Probably it will soon evolve in semantic kernel. So yesterday in the office hours, it's if you're curious, probably it's already available. The team announced a roadmap for agents, and it involves graphs as well. And also they are adopting the Creo AI way, which is task driven. I think it's not that nice, but very efficient for simple tasks. But if they manage to combine both of them, it will be good. But I think it's pretty interesting to check that out. But it's going in a nice direction, and there are a lot of changes. They are aiming for the Ignite, Microsoft Ignite timeline, which is amazing. But what I'm talking about is not 2 or 3 agents or 5 or 6 or 10, which we can have now, but having hundreds collaborating seamlessly. And this capability will revolutionize how we approach complex problems and will be a game changer, a disruptor for in many industries, if not all. And here is my call to action to embrace and implement AI. The call to you is to embrace this feature. Large language models will continue to improve significantly in collaboration with agentic AI, which you've seen what's the improvement over what a model can do, right? From 48 to 94% in accuracy in one of the hardest coding benchmarks, human evil that we saw at the beginning. However, this means that in collaboration with agentic AI, they will be able to achieve amazing things autonomously. So chances are that we will put a PBI and it will be done by itself, and it will require very small or not too much supervision. But however, someone will need to design and implement these agents along with the guardrails and quality controls and fine-tune them regularly. And to ensure they do what they are supposed to do, nothing evil, and do not deviate from that. This is where you, as a generative AI expert or developer or generative AI architect, may come in. We need to learn how to set up and manage those teams of AI agents and all the relevant components and skills. You need to learn generative AI, how to manage and orchestrate AI agents and teams of agents, and do so as a good team lead does. It's not just development, it's just you have to think as a manager when you do that. It's kind of it blows your mind, the things you have to have in at the same time, but it's also very exciting when you see that they do what they are expected. You have to become and think like a manager, plan as an architect, and understand each component in detail, and more fun, its personality as well. People management skills alone are not enough. You need cloud knowledge, AI component knowledge, architecture skills, prompt engineering, agentic AI, and coding knowledge if you fully want to understand what's going on. Maybe it's a bit overwhelming, but you just have to start and everything will come to you. Now is the moment. As fast as this field is evolving, if you haven't started already, it may already be too late. So think seriously about starting this journey as soon as possible. Chances are that in 2-3 years, somebody with the skills I just mentioned will be able to do what your complete team is doing, if not more. And that's kind of a disruptor, right? And that's it. I want to thank you for listening to me. I hope this presentation has resonated with you and sparked some new ideas. Thank you so much. If you find my thoughts and ideas interesting, you can follow me on Twitter, LinkedIn, or even check my LinkedIn courses, which I have this one on semantic kernel, one about to be published on Azure AI, and working on a new one on AutoGen. You can also meet me at the events I organize, such as .NET Zurich and Global AI Zurich, sometimes hybrid, in person and online. And again, it has been an absolute pleasure to be here with you. Thank you.
Whoa, that was great, Jose. The way you ended your presentation, I see one of the comments already coming in. That said, it was very motivating. Like, it is time to learn now. If you don't do it, you'll fall behind. You're also picking up this generative AI. When this came in. So yeah, Megha Gupta also says very informative session. So I really loved it, and personally, what I really love about your sessions is that all the images that you create, they're from AI, right? So one can really relate it that you're practicing what you're saying is what you're really practicing it. So that is lovely. So let us take. I'm gonna let this slide up there, right, so that people can actually read it. Let's take a couple of questions. The first question is from Anderson. He's asking, what do you think will be the impact of AI on communication interfaces in the future? Will it change the way we interact with applications?
Yeah, definitely. I mean, it has already done so. For
Hmm.
example, if you go to where Power Platform is going at the moment, you can
Yeah.
see that you have this copilot for your app, which you put the full data of your app, you put some questions, and it kind of gets automatically trained to make questions on the data that your app is managing. So it's quite impressive. If you look at Copilot for Power Apps in YouTube, probably you will find a couple of very interesting examples around there, but it's already doing that.
Yeah.
And this will just increase as they get more ability. So definitely.
That's right. That's right. We have about like a minute or two before the next session starts. So let's take the other question. That's why Rohit is asking some of the best practices developers should follow to ensure that AI systems are scalable and adaptable to future trends in AI architecture and technology. Don't just use
Hmm.
OpenAI APIs.
Yeah, well, I would use Azure at the moment,
Yeah.
right? But it's hard to say, right? At the moment, the scalability is in tokens. We don't have systems that can really fully parallelize agentic operations.
Hmm.
So it's kind that you have to manage that yourself in a way. And doing deployment on the go for this, it's not an option. So something needs to appear that that we can do that. So at the moment, if you want scalability, is GrowQ, not the Grow with K from Elon Musk, but the GrowQ. And these are at the moment the most fastest LLMs on Earth.
Yeah.
If you want a service which is already fast.
Yeah. I would say take care of data. I would add that take care of data, right? Things will come and go, new things will come in, but you take
Yes,
care of data. Data is very important.
exactly. I
Yeah.
would deploy that as an API. I mean,
Mm.
I'm a .NET developer, so I would deploy that as a .NET API in Azure, and I would simply configure that for scalability.
Yeah, use minimal APIs. I love it.
Hmm.
Okay, we have another question by Freya. This comment very interesting. Mega says very informative session. Ganesh says thank you. Let's take one final question. I know we're already
All right.
1 minute into the next session.
Hmm.
Vas is asking, how do AI orchestrator function within current AI architecture, and what advantages do they offer over traditional?
Well,
Again,
I would be interested. What do you mean about traditional orchestration? But AI orchestrators enable
Mhm.
you to manage AI elements and coordinate that they start and end and work properly. Some of them enable like a repeat mode, so ensure that one task is finished, right?
Mhm.
So I think they are better prone for that task. Some of them, at least the one I know, it's quite good,
Yep.
but they still need to improve a lot. And for example, the one is my favorite. Semantic kernel enables you clear integration with um, any observability platform with open telemetry, so it's OT ready and integrates perfectly with any ASP.NET application, like a simple API. And you deploy an API in Azure, and it's easily scalable by demand based on the metrics and memory. So I would do that for this.
Yeah, that's great. I hope, Bhaskar, you got your answer. I think the longer you stay, Jose, on the screen, the question will keep on coming. I see another few questions coming in, but we don't
Okay.
have time to take it. We'll have to move to the other session, Jose. Thank you so much for doing this. Any final thing you want to plug in? I know you ended your session on a very nice note on to keep learning, right? I love the motivation that you gave it to all the developers. Any final plug before we move to the next session?
No, thank you so much. It's been an absolute pleasure, Simon. Thank you for inviting me, and thanks everybody.
Yeah,
It's a pleasure.
thanks, Jose, for accepting the invitation. I know you're very busy with everything that's happening, right? Take care of yourself. Let's stay in touch, and I'll see you soon. See ya. Bye
Thank you.
bye. All right, that was our friend Jose joining all the way from Zurich, Switzerland, and we now move to our next session. That is by Amira. Amira, I remember she's also been a CSharpCorner MVP, and today she's going to talk about data engineering in Microsoft Fabrics. Microsoft Fabric is relatively new. I would still say it is new, but it's good to have sessions around that. Amira is a Microsoft Data Platform MVP. So without any further ado, let's bring Amira to the Software Architecture Conference 2024. Hi, Amira. Welcome to the Software Architecture Conference.
Hello, same place for the second year.
I feel so happy to host you once again. How have you been?
Good. Thanks for asking. Always running late.
No, I think you were on time today. I was watching, right? You were here right from the very beginning, right? So you were not on late. Kind of we are running late. All right, Amira, I know I'm only 2-3 minutes in your session. I'm gonna add your screen to the stream. I believe everyone is really excited for your session. So we're gonna do a lot of chit chat towards the end. Everybody can see your screen, and next 35 minutes is all yours.
Thank you. So thank you for the invitation for the second year. In this session, we will do like a deep dive into the data engineering part in our workload in Microsoft Fabric. So we will cover data engineering capabilities, including the Lakehouse, Spark, notebooks. So I'm glad that you are joining the session, also to learn about some updates about the product. So I'm a business intelligence engineer, so I have a newsletter which is mixing humor of things that challenges me during my daily routine. So and I try to help entities, not only entities, but anyone seeking for help to make better decision in different business processes, of course, based on data. That's the fuel. So my LinkedIn newsletter is called the BI Chronicle, and my AKA is the Data Witch. So let's start by we're going to meet Alex, starting with his life routine, who is a data engineer at Retail Hub. It's a growing e-commerce company which is facing, let's say, significant challenges with their data. So data is spread across various systems, POS, online transaction, inventories, customer services. So Alex's daily routine is involved like juggling, let's say, multiple tools and platforms, each with its own set of complexities. So we can cite like we can mention the manual integration of data from different sources, which is considered as time-consuming and prone to errors. So different departments at Retail Hub use their own systems. So we are talking about a scenario leading to data silos that make it difficult to get like a holistic view of the business. And as data volumes like grew, the existing infrastructure, from the point of view of Alex, struggled like to keep up. So he spent significant time troubleshooting performance issues, trying to optimize like slow running queries, and which at the end detracted from more strategic work. So during a technology conference, Alex attended a session on Microsoft Fabric. So it's an end-to-end analytic platform, promised to solve many of the challenges he faced. So Alex is you, is me, is everyone trying to understand what Microsoft Fabric about. So data engineering in Fabric enables users. So we are going to just, like you see, focus on the data engineering part. So enables users to design, build, and maintain infrastructures and systems that enable organization to collect, store, process, and analyze large volumes of data. So with MS Fabric, you can create and manage your data using Lakehouse, design pipelines to copy data in your Lakehouse, use Spark job definitions to submit, for example, batch streaming job to Spark clusters, and even use like notebooks to write code for data ingestion, preparation, and transformation. So the journey of Alex with data engineering part in MS Fabric, starting with building the Lakehouse architecture of the Retail Hub. How to maximize the data potential. In this case, with Data Lakehouse, that's the first part, and when entering into the engineering world within Microsoft Fabric. So Microsoft Fabric Lakehouse is a data architecture platform, of course, for storing, managing, and analyzing structured and unstructured data in a single location. So it's flexible, scalable, and allows organizations to handle large volumes of data using various frameworks to process or analyze that data. So, and it's possible to integrate it with other data management and analytic tools, of course, to provide, let's say, more comprehensive solution for data engineering and analytics. So as you can see in the screenshot, it's something you get used to maybe when working with Power BI online or Power BI desktop. Moving to the Lakehouse SQL analytic points. So the Lakehouse creates a serving layer by automatically generate a SQL analytics endpoint and a default semantic model during creation. This, in my opinion, like this new see-through functionality will allow users to work directly on top of the Delta tables in the Lakehouse and to provide like frictionless and performant experience all the way from data ingestion to reporting. It's important also to note that the SQL analytics endpoints is a read-only experience and doesn't support the full T-SQL surface area of transactional data warehouse. So if I explain better, only the tables in Delta format are available in the SQL analytics, endpoint. Parquet, CSV, and other formats can not be queried using the SQL analytic points. So if you don't see your table, you will need to convert it to Delta format. Of course, you can set object level security to access data using SQL Analytics endpoints. Security rules will apply for accessing data via the SQL Analytics points to ensure, of course, data is not accessible in other ways. It's recommended to use workspace roles and permissions. Another point related to SQL analytic endpoints is like the automatic discovery, table discovery and registration. This feature provides a fully managed file to table experience for data engineers, and not only engineers, data science also. You can drop just a file into the managed area of the lakehouse, and it registered into the metastore with the necessary metadata, such as, for example, column names, compression, formats, etc. Currently, the only supported format is Delta table. So let's hope in the future we have more features, an improvement for this component. As I was talking about the automatic table discovery, there is another Fabric Lakehouse can automatically discover all the data sets already present in your data lake and expose them as tables in the lakehouse and, of course, warehouses. There is always a single condition. As I always said, the tables must be stored in the Delta Lake format. About multitasking with Lakehouse, this experience provides a browser tab design that can allow you to open and switch between multiple items seamlessly, allowing you to manage, for example, your data lakehouse and or more efficiently than ever. So you don't need to juggle between different windows to make your data tasks. So that's the way that it is more efficient and user-friendly as possible. The smooth interaction. You can upload or run data load operation in one tab and check on another task in different tabs. So with enhanced multitask, the running operations are not cancelled when you navigate between tabs, so you can focus on your work without interruptions. Of course, selected objects, data tables, or files remain open and readily available when you switch between tabs. The context of your data lakehouse is always at your fingertips. There's also behind a non-blocking reload mechanism of your files and table lists, so you can keep working while the list refreshes in the background. So you have always the latest data while providing you with a smooth and uninterrupted experience. Moving to how to get data in the Lakehouse. So Lakehouse currently supports over than 100 data sources. You can connect to a wide range of data sources. This include, of course, traditional databases, cloud, storage solutions, SaaS applications, and more. Of course, this extensive connectivity makes sure that you can gather data from virtually any source your organization uses and provide you with a unified data platform. Also, we have the direct upload of files from the computer. So the process is very simple. How to get data from your file on your computer, and you can upload them directly to Fabric. It's useful for quickly ingesting CSVs, Excel spreadsheets, JSON, and other common data formats without needing to set up a complex data pipeline. So you can simply drag and drop the file into the platform, and that's it. Applying transformations using data flows. So once your data is there in the lakehouse, with Microsoft Fabric, you can have tools to transform and prepare your data, which is like the data flows. You define data transformation steps. It's something similar to people who worked already or have knowledge about Azure Data Factory. So you can do data transformation like filtering, joining, aggregating, or even further complex processing operations. And the data flows support both no code and low code options. So making it accessible for both technical and non-technical users. We have also the copy activity, especially when dealing with large-scale data. Microsoft Fabric supports the copying of entire data lakes up to, we can say, petabyte scale. So it's very important for organizations that need to replicate, move, or backup big amounts of data across different environments or cloud regions. So the copy activity is designed to be highly efficient and scalable, especially with very large data sets which need to be transferred without performance bottlenecks. For Spark lovers, of course, for more advanced data manipulation and processing, today Microsoft Fabric supports the use of Fabric code. These allow data engineers and scientists to write custom code in languages like Python or Scala. And through Spark, users can connect to various data sources, perform complex transformations, of course, and execute, let's say, distributed computation across large data sets. Another thing is the shortcuts. The shortcuts in Microsoft OneLake allow you to unify your data across domains, clouds, and accounts by just creating a single virtual data lake for your entire enterprise. So all Fabric, let's say, experiences and analytical engines can directly connect to your existing data source. For example, Azure, AWS, OneLake, through a unified namespace. So OneLake manages all permissions and credentials, and you don't need to separately configure each Fabric workload to connect to each data source. And you can use, of course, shortcuts to eliminate edge copies of data and reduce process latency associated with the data copies and staging. Of course, as I mentioned about the Delta Lake tables, today the Lakehouse provides this feature to load common files types to an optimized Delta table. So today the supported files are Parquet and CSV. The file extension case doesn't matter. Also, with the single file load, users can load a single file of their choice in one of the supported format by selecting directly load to data table in the context of the menu action. We have also the folder level load, so you can load all files under a folder and its subfolders also at once by selecting load to delta table. Just like this feature automatically traverses all the files and load them to a delta table. Just we need to make sure that only files of the same type can be loaded at the same time in a table. We can also choose to load files and folders to new tables or an existing table. So, and of course, for CSV file, users are allowed to specify if their source file, like for example, includes headers to be used as column names. So you can see that these details are somehow very similar to Power Query if you import, like for example, a CSV file to Power Desktop. So, and of course, tables are always loaded using the Delta Lakes table format with V-order optimization enabled. Delta Lake, so what is the V-order? And before that, what is the Delta Lake optimization? Let's start with defining the V-order. It's a write time optimization to the Parquet file format to enable lightning fast reads under the Microsoft Fabric compute engines, such as Power BI, SQL, Spark, and others. So Power BI and SQL engines make use of the Microsoft Vertiscan technology and the V-ordered Parquet files to achieve in-memory data access time. So this is for the case for Power BI and SQL engines. Spark and other, let's say, non-Vertiscan compute engines also benefit from the V-ordered files, let's say I think with an average of 10% faster read times, with some scenarios up to, I think, 50%. V-orders works by applying special sorting, row group distribution, dictionary encoding, and compression on Parquet files. This requires less network, disk, CPU resources, of course, in the compute engines. So to read, and of course, it provides cost efficiency and performance. V-order sorting has 15% impact on average write times, and it provides up to 15% more compression. So it's 100% open source Parquet format compliant. All Parquet engines can read it as a regular Parquet file, and that's what makes the delta tables more efficient than ever. So it's applied in the V-order is applied at the Parquet file level. Delta tables and its features, such as, for example, Z-order, compaction, vacuum, time travel, etc., let's say, are orthogonal to V-order, and they are compatible and can be used together for extra benefits. For the new features, as I do it each month, I try to check the new features. We have today it's the the lake schema feature, which introduces data pipeline support for reading the schema from the Lakehouse. We have also the support for Git integration and deployment pipeline. The Microsoft 365 connector now supports ingesting data in Lakehouse for the The second and the third, they are still in preview, so be careful, guys, and feel free to upscale any bugs on the platform. Going to Apache for Apache lovers in Microsoft Fabric. So if we are going to start with Apache, we need to talk about the Apache runtime within Microsoft Fabric, which is Azure integrated platform based on Apache Spark and enables the executions and the management of data engineering and also data science experiences. So it combines like the components from both internal and open source sources to provide a comprehensive solution. So the major component of Fabric runtime, we have the Apache Spark. It's open source distributed like computing library to enable large-scale data processing. We have the Delta Lake, which is also open source storage layer that brings ACID transactions and other data reliability features to Apache Spark. And we have the default level packages for Java, Scala, Python, and R. So these packages support diverse programming languages, and they are automatically installed and configured, allowing developers to apply their preferred programming languages. So this is by default all new workspaces use the latest runtime version, which is currently 1.2. And this runtime is built upon a robust open source operating system to ensure like the compatibility with various hardware configurations and of course system requirements. Moving to the next component, which is Apache Spark Compute. As I said, like this platform is designed to deliver unparalleled speed and efficiency. So with, let's say, starter pools, you can expect rapid Apache like Spark sessions to initialize. It's typically between 5 to 10 seconds. So you don't need any manual setup. You can also get the flexibility to customize the Apache Spark pools according to the specific requirements. So the platform somehow enables you to optimize the analytic experience. Moving to another component which is important in Spark and Apache Spark runtime is the Spark pool, which is like a way to tell Spark what kind of resource you need for your data analysis. So you can give it a name, choose how many and how large the nodes, when I say the nodes, like the machines that do the work are. So you can also tell Spark how to adjust the number of the nodes depending on how much work you have. Creating, of course, the Spark pool is free. You only pay when you run a Spark job on the pool, and the Spark sets up the nodes for you. So if you don't use Spark pool for 2 minutes after your session expires, your Spark pool will be deallocated. So this default session expiration time period is set up to 20 minutes, and you can, of course, change it if you want. If you are workspace admin, you can also create custom Spark pools for your workspace and make them the default option for the other users. So in this way, you can always save time and avoid setting up new Spark pools every time you run a notebook or a Spark job. One other detail to mention is like the custom Spark pools take always about 3 minutes to start, because Spark must get the nodes from Azure. Moving to the nodes, so as I said, an Apache Spark pool in an instance consists of one head node and worker nodes. So could start a minimum of one node in Spark instance. The head node always runs extra management services such as Livy, Yarn services, Yarn Resource Manager, Zookeeper, and Apache Spark driver. So all the nodes run services such as Node Agent, Yarn Node Manager, and all worker nodes run the Apache Spark Executor services. The node sizes, as you can see, can be defined, of course, the Spark pool can be defined with node sizes that range from a small compute with 4 vCore and 28 gigabyte of memory to double extra large compute nodes, as you can see. And they can be altered after pool creation, although the active session should be restarted. We can talk about also the auto scale, since the pools allow automatic auto scale, or this automatic scale up and down, of course, of compute resources based on the amount of the activity. So when you enable the auto scale, you set like the minimum and the maximum number of nodes to scale. And of course, there is the dynamic allocation principle, which allow the Apache Spark application to request more executors if the task exceeds, let's say, the load that current executors can bear. So, and when you enable the dynamic allocation option for every Spark application submitted, the system reserves executors during the job submission step on the minimum nodes. You can specify maximum nodes to support, of course, successful automatic scenarios. Moving to the Apache Spark job definition, which is a Microsoft Fabric code item that allows us to submit batch streaming jobs to Spark clusters. So by uploading the binary files from the compilation output, for example, jar files from Java, you can apply different transformation logic to the data hosted on the lakehouse. So you just, to run that job definition, you must have at least one lakehouse associated with it. There are a few ways you can get started with the creation process. You can go to the data engineering homepage directly, so you can easily create Spark definition through the Spark definition card under the new section, or you can you can create it through the create page under the data engineering on the left side, or of course you can of course through the workspace in data engineering, so you can always go back to the data engineering if you get lost. Another component in Apache Spark that you can find in Microsoft Fabric is the libraries, and we have like two types of libraries. So the built-in and the public, actually three types: built-in, public, and customs. The built-in libraries, each Fabric, like Spark runtime, provides a rich set of popular pre-installed libraries. You can find them all in the documentation. We have also the Fabric libraries, and they are sourced from repositories like Conda, which is currently supported. And we have custom libraries that refer to code that you or your organizations build. So just we need to make sure that they are in the format of jar, tar, gz, whl. So because Fabric supports .tar.gz only for the R language. For Python, for example, it uses like the .whl format. As best practices is always the default setup, default like libraries for the workspace. The admin, of course, is responsible of that, and by creating a new environment, installing all the required libraries, and attaching this environment to the workspace. Or the second scenario is like to persist the library specification. If you want that to persist, you need to install libraries in an environment and attach it in the code items. In my opinion, one benefit from this approach is that it saves effort of running the code that requires common libraries all the time. So you have the libraries, you can work in all Spark sessions if the environment is attached. And the third scenario is to align the installation. So if you're interested in the one-time use within an interactive, let's say a notebook of a library that isn't installed, so you may need to use the inline installation with the commands, the inline commands. You have like that they allow you, like the command, they allow you to have the library in the current notebook sessions, and they don't and the library doesn't persist across different sessions. As I already talked about environments previously, so Microsoft Fabric environments is a consolidated item for all your hardware and software. You can select an environment, different Spark runtimes. You can configure your compute resources, install libraries from public repositories. There are multiple entries of creating new environments, standard, or you can create during selection. So three major components in the environment, which are like the Spark compute, that includes like the runtime, the libraries, and the resource. Of course, the environment can be attached to your data engineering or data science workspaces, or your notebooks and Spark job definitions. The new features for last period at least, there is a runtime. I said that the 1.2 is the default, but the Fabric runtime 1.3 remains and still preview. So it includes the incorporation of Delta Lake 3.1 compatibility with Python 3.1. So other it also supports like start pools and integrating with environment and other library management capabilities. And of course, we have the native execution engine for Apache Spark is now on preview, but only for the Fabric runtime 1.2. Moving to the notebooks, for notebooks, of course, lovers, it's the same principle. It's a primary code item to develop your Spark or Apache Spark jobs. And with the Fabric notebook, you can get started with a zero setup effort. You can easily explore and process data with low code experience, analyze data across raw formats. So let's say CSV, text, JSON, etc., and even processed file formats like Parquet, Delta Lake. And of course, to be more and more productive with enhanced authoring capabilities and built-in data visualization. You can, of course, export notebook to other standard formats into the standard notebook file, which are used to Jupyter-like notebooks, even HTML that can be opened from a browser directly, a Python file, and even a LaTeX file.
Amira, a gentle reminder that it's time to maybe wrap. Yeah.
How much time do I have?
We've only passed 2 minutes over, but you can have another couple of minutes. Yeah.
Okay, thank you for your understanding. So, you can explore like the Lakehouse note data with an existing notebook, or you can create a new one. It's easy, and in the same workspace and the current Lakehouse, you can have all the notebooks. Of course, you can source control the notebooks, and using Git integration for source control with Azure DevOps. So when you just commit the notebook item to the Git repo, the notebook code is converted to a source code format instead of what we call standard IPYNB file. What's new for the notebooks are the deployment pipelines to deploy your notebook code across like different environments like test, dev, production. It's still on preview, but it will enable you to streamline your development process. It's like you can see it's similar to the Power BI deployment pipeline. We have also the APIs, the public APIs, to mainly for management, to automate like the pipelines and establish CI/CD. So those pipelines make your life easy to manage and manipulate the Fabric notebook items and integrate like notebooks with other tools and systems. We have also the schedule, public APIs to schedule, and it's more oriented to schedule the running items with the specific requirements. Going finally to the data pipelines in Microsoft, that's the last part of our data engineering journey. The data pipelines, you already heard about this. It's a series of steps to collect, transform data from its raw format. You can use it for analysis and decision making. So the first component is activities, where you can define actions to perform on your data. For example, you can use copy activity to copy data from SQL Server to Azure Blob. Then you can use a data flow activity or notebook activity if you want to process complex transformation. We have like 3 types of activities: data movement activities, data transformation activities, and control activities. That's it, the journey, our journey with the data engineering in Microsoft Fabric. That was the journey of Alex. Remember also that Alex is you and me and everyone, to interested with the Microsoft Fabric, and of course the engineering part, as I always define Microsoft Fabric, is the all-in-one. Thank you.
Right, Amira, that was absolutely great. Love on how you started your session with your story and then moved to all the technical concept and you explained it. We have actually, we have quite a few questions in the comments. We have Vanshika, Bhaskar, Mega, Prayer, Sophia asking questions. But unfortunately, right, we're running out of time and we won't be able to take these questions. But perhaps you can, maybe log in here and reply them. You can do it right through the StreamYard also. Maybe go to YouTube and maybe answer them, right? Some of them, if not all. But I really want to thank you, Mira, for all that you do for the community, Congratulations once again for being an MVP, right? Love all your newsletters. I also see it. You keep on sharing. And in fact, someone from the comments said that she follows you on LinkedIn. So definitely you're getting a lot of popularity. Microsoft Fabric, is a big time. Microsoft is betting on it. So thank you so much. Any final thing you want to plug in before we move to the next session?
Any?
Yeah, any final thing you want to add before we move to the next session?
I hope to. Yeah, actually, I'm still learning many things, just to make people comfortable that we are not. I always explain that I'm still learning every day. It's a new day, a new journey. I know sometimes people get overwhelmed with the updates for any product, but keep learning, focus on learning. Try to you can begin with small projects, and you can discover Microsoft Fabrics. We will be having online sessions for free to discover more this platform. So you are always welcome to ask the questions. I will get back to the chats. I will try to answer question by question.
Yeah, thank you so much, Amira. We'll see you in some other time. See ya. Bye bye. Have a
Thank
nice
you.
day.
Bye bye.
All right, that was Amira for you with her Microsoft Fabric session. I know we are already 10 minutes to the next session. I apologize for that. We're going to quickly go to the next session, and the next session is about retrieval augmented generation. It's by none other than Soham Das Gupta. He is actually a cloud solution architect. So, without any further ado, let's bring him to the Software Architecture Conference. Hi,
Thanks
Soham.
a lot.
Welcome to the Software Architecture Conference.
Thank you. Thank you.
Well, I didn't
Cool.
knew that you're based out of Netherlands. I thought you live in United States.
No. I live in Netherlands for almost 14 years now. Yeah.
Wow. Do you by any chance have worked with Hank in any of the events? Hank, Shauki, they're quite active
Shalka,
in.
yes. Shalka was my previous colleague. So I used to work in Capgemini, and Shalka was my earlier colleague. She organizes a Azure festival, so Azure Lowlands in Utrecht. So I spoke there a couple of months ago, actually, as well.
Oh, really? You
And
know
Hank
what? The
also.
world is a small place.
Yeah, it
I
is.
was invited to I was invited to speak at this Azure Lowland first edition, right? But for some
Yeah.
reason, I did not get the visa.
No. No, you
That
should come.
was
It's
so
a quite
sad.
nice, cozy conference. Yeah, I quite liked it.
Yeah, and it's actually Hank and Chunky, they all do it. So I know I'm really excited for your session, right? I'm not gonna take any more time of yours. I'm gonna add your screen to the stream. Everybody else can see it, and next all 35 minutes is your ours. No problem at all. The time, man. So it's your.
Thanks a lot. Okay, I have two screens, so I might be looking at this and this. So, yeah, maybe a bit confusing, but bear with me. Um, I do have a little bit of time crunch, I think, because the next speaker will also be there, but I will try to finish the story as much as possible. Well, Simon already did a introduction for me. But I am Soham. I work as a solution architect at Microsoft Netherlands, specifically on the app innovation and the AI side. And that's basically why this topic is pretty close to me. And this is our agenda today. So RAG, retrieval augmented generation, is a new kid in the block when we talk about software architecture in AI space. But as easy as that it sounds, there are a lot of nuances in this architecture pattern. And what I'm going to try to cover in the next half an hour or so is to go through all the nuances a little bit and put a resemblance with the movie Ratatouille. I hope some of you or most of you have seen the movie where the rat is basically has a knack of cooking, loves cooking, and helps um, another person to learn and do good in cooking. So I'm gonna use all sorts of references from the movie, from food, to explain what RAG is and how advanced you can go with RAGs and the different nuances to it, to be honest. So we talk about food without spices. We all know how that tastes like. How to do prep work, so chopping and assembling. I'm going to talk about how you follow a recipe. I'm going to talk about how you get Anton's approval. If you remember the movie, whoever has seen it, Anton was a food critic who used to be very, strict about writing reviews of a restaurant. Then I'm going to talk about how you master your masterpiece. So how you fine tune it, how you make sure your RAG works the way you want it to be. I'm going to talk about a few secret splice blends. So these are basically the advanced RAG patterns or the architecture patterns. And lastly, if we have time, we'll talk about a few use cases. There are a lot of content here. I'm not sure how much I'm going to cover it. Put your questions in the chat. If we have time later on, we'll answer it. If not, I'll go back to the YouTube page and try to answer your questions as much as possible. So food without proper spices. So let's see. We are in second or almost a third year of large language model hype or flow or wave, whatever you want to call it. And we all have seen how hallucination became a word in our daily life. So everybody who has used ChatGPT or any sort of other AI, hallucination is a part of the thing. So you need to write your commands or instruction in such a way that the LLM understands and gives you back a proper answer. So for example, Good Friday is a holiday or not? If you ask this question to any large language model, it will give you a very generic answer. And I know in India it's a holiday, but in Netherlands, it is not a holiday. But in Microsoft, if you work as a Microsoft employee, and some banks here in Netherlands have this day as a holiday. So rest of the Netherlands not, but some of us will have a holiday on Good Friday. But if you ask the generic question to any large language model, it will give you a very generic answer. But why is that happens? You know what the T stands in GPT is the transformers. So the transformer type of model will try to finish the next sentence or a next bunch of words what you put in as an input. So if you put in as an image, you put in a text or a video, it'll try to find the next possible thing. And why is that? Because the next possible thing is what it is trained on. And mostly it is trained on a lot of things, but it'll try to find the most relevant and the high scored next piece of information to the input that you've given to. So when you get back an answer that it can be a holiday in UK, example, blah, 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 it's basically trying to generalize that whole knowledge that it is trained on, to be honest. But here comes the power of RAG. So if you, along with the question to the LLM, provide some sort of information which is very specific to your question. For example, if I search for all the holidays that are there in 2024 from our HR information, because they release this information of your yearly holidays. Every company does, to be honest. And if you add that information along with your question and then send that question to any LLM, it will properly kind of reason and give you the answer that you are looking for. So the only thing you change, you push some sort of information that is very contextual for your case before asking the question to LLM, and it will give you a proper answer. So in very short, this is what RAG is, the retrieval augmented generation. But as I said in the beginning, it sounds quite simple and straightforward, but there are a lot of nuances there. But we'll go there as slowly. So technically, it has two different workflows. The top one talks about how you ingest documents, and normally these ingested documents go into a vector DB. But to be very honest, a RAG can also be based on structured data, or a non-vectorized data. It's textual information. It's all about putting the context before realizing the answer from LLM. So the top part talks about how you ingest data. So normally if there's a vector database involved, you have all the documents, you create document chunks. So you make smaller pieces of documents. Then you make vectorization of those documents using an embedding model from OpenAI or Llama or Meta. And then you store those embeddings in a vector database. And vector database is nothing but a normal relational database with columns and values and everything, but it has a special column specific for vector embeddings, and that's in float 16 or 32 bits. And the second part, which is the lower part, is basically the retrieval workflow. So if you post a question, if it is a vectorized data you are searching on, it will create the vectorized embedding of those questions, and it will do a search on the vector database. And once you have the relevant chunks retrieved from the database, you will pass on to the LLM to do the reasoning along with the question to generate an answer. So the part which retrieval is basically this, where you do a search. The augmentation is actually this, where you pass on the context along with the LLM, and generation is ultimately the generation of the answer from the LLM using all those contexts. Did I skip one slide? No, sorry. So now, chopping and assembling. What do you mean by chopping and assembling? We all know if you cannot put the whole cabbage while you're cooking any kind of dish, you need to chop it down. And every kind of cooking has a different way of chopping stuff. So if you're using this cabbage in a sandwich, maybe your slices will be bigger. If you're using it in a salad, maybe your slices will be a little bit smaller. If you're putting it in, I don't know, in some kind of a rice dish, maybe you want to chop it very thinly so that you can cook it pretty easily. So chunking is related to that. It depends on how is your search going to perform, how is your retrieval going to work out, and that's where you do need to chunk it. And there is another reason for chunking is as well. So if you have a lot of information and you want to send it to an LLM, I know Gemini has a higher context range, so you can send a whole encyclopedia, to be honest. But the amount of data you transfer over the network, the amount of money you also pay. And also it takes much time to get back the answer from LLM. So you cannot send a lot of information at the same time to a large language model. You need to make it as small as possible or as effective as possible as well to make sure the LLM performs properly. And that is loosely related to tokens. So I'm not sure how many of you know, but LLM reasons with tokens. So it accepts tokens and it generates tokens. And you can loosely say token is a word or a phrase or even a bunch of characters also. And this token has, every LLM has a limit of token that it can take it as an input and provide as an output. So this total token limit also comes into the picture when you basically try to chunk your documents to ingest. So remember, I'm still talking about your ingestion part. So the way you making your ingestion part smarter or efficient, the way your retrieval part will also be efficient. I also have an example here. Let me see if I can open this. So this is a free application where you can actually play around how your chunking looks like. So normally chunking can also be talked as a splitter, and there is a different kind of splitters available here. This is just a small list. There are multiple others. Just to give you an example, if I make my chunk size around 675, so this is my first chunk, this is green is in my second chunk, and the red, and so on and so forth. There's also something called an overlap, because when you're reasoning of distinctive data which were connected before, so for example, this was a whole paragraph, now I'm breaking it into different chunks, you also want to have some sort of overlap. What would the overlap gives you? The overlap gives you the piece of information that might want to flow to the next chunk of your information. And this helps when you want to have multiple search results back and you want to combine those chunks somehow to generate a reasonable information. Then it makes sense to have these kind of overlap. And this is like the old radios. I'm not sure whether you had that, but in my childhood, we used to find the FM channel on Sunday afternoon by tuning left and right and moving the antenna a little bit here and there. So this is like that. So the chunk size and the chunk overlap, there are no silver bullets for this. So you need to figure out, depending on your document, depending on your size of the document, depending on the information that you have on the document, what should be the proper chunk size, what should be the proper chunk overlap. And you need to tune this properly to have your retrieval process also better, to be honest. There are a lot of chunking libraries available, to be honest. So if you are using Llama Index or LangChain, they have a lot of libraries to help you do the chunking, so you don't have to worry about it. You just call the code and it chunks it for you. The most interesting one that I find right now is the semantic splitter. So you try to split and chunk your data depending on the semantic meaning of the data. So it is using an LLM to figure out what should be the chunk size I use. And when you hear this, you would think, okay, then that's the best chunker in the list we have. Why do we need any others? As I said before, it depends on what kind of data you're chunking. Maybe you're chunking some kind of code. Maybe you're chunking a structured HTML. You don't need semantic splitter for that. It only makes sense when you have same sort of information scattered through a lot of pages and all. I see already a question about RAG fusion and all of those things. I'll come to that. Maybe that's a good idea. So chunk is basically how you do overlapping. And this is a very naive retrieval strategy. So you have documents, you do a single chunk vector, then you do a search, you get top K, and you return. Now comes a different variation of chunking. So what you do is you create two vector databases. One has the index of the summary vector. So you summarize X number of pages from the documents and store it in a vector. And you also have the normal vector store, which does the chunking and overlapping properly. And you do a query on both of them. So once you have the first chunk retrieved from the summary vectors, you only retrieve the child vectors that are related to that summary. So you skip the search on the second vector store. And that gives you a little bit of edge, because then you are minimizing the search operation. So remember, the bigger your vector store is, the slower your search can be. Secondly, there is another thing called sentence window retrieval. So for example, this is a text from Kubernetes service automatic offer from Azure. So let's say you want to find out what are the things pre-configured in Azure Kubernetes. And you actually should get this answer back, because this is the by default configuration you get from Kubernetes. But to get a better reasoning, you can extend the context. So you can do a sentence window retrieval. So this is another way of sending the information to LLM. So not only the part that you retrieve, but also the part that is basically around it to make a better judgment call, better response. There's another strategy called parent-child. So you will have two different vector store. One vector store will have all the child leaves vectors, and another will have a parent. So think from this perspective, if your documents have different chapters, and every chapter have different pages, so every page will be considered as child and leaf, and your chapter will be chunked as a parent. And once you do a search on your leaf, and let's say you get top X results back, And then you need to judge which out of this X results, which have the most parent relevance. So you pick up that parent chapter and send it to LLM and ignore the rest. So that makes your answer or reasoning very much concentrated on the chapter where the child chunks are retrieved from. There's another thing as our fusion retrieval. So you will have two different vector index. One is a normal vector index, another is a sparse n-gram. So this is basically using a different sort of vectorizing algorithm to making your documents vectorized. And what you do is after retrieving both from both the vector databases, you do a reciprocal fusion. So you basically try to figure out which all documents should be on the top of the search and which all documents should be on the bottom of my search results. And then you get top X from the last results to respond to them. There are a lot more, to be honest. I've just picked up a few just to give you the feel of how complex it can get, to be honest. And there could be a lots of practical challenges doing this. First of all, the number of documents that you have to index. And since you are doing it on a float data type, you need a lot of space. So space is a major concern right now with all sorts of vector databases right now. So they have, if you have a 10 GB of data, normally it will come around a terabyte when you do a vectorization of those data. And depends also on which kind of vector embedding model you are using. Right now, OpenAI gives you 1536 dimensions of vector. Do you need them, that amount of dimensions for your documentation? Maybe a smaller dimension would also help. So a lot of nuances are there also in that factor when you are vectorizing your data. When we create a software architecture, I would always like to follow a recipe. Like if I have a recipe, then I know these are my steps. Of course, there will be things that I can add and change and update a bit, but following a recipe is always help. And in RAG also, there is always a workflow which could be always the same, depending on the implementation of the different boxes. It depends how you end up with your RAG application. So for example, you're always reading from a document storage, files and blob, and you will publish some sort of document update events. So for example, these update events will go to somewhere, a piece of code, which will load these updates, create embeddings or vectorization of these documents or not, and then it'll add it to the vector DB along with some metadata. I'll come to the metadata part in a bit, and then you upsert all those embedding and the metadata to somewhere. Then comes a very interesting part, which I think every RAG application should think about from the very beginning, is validation or testing, what you call it in normal software development. And I call it as Anton approval. So from this phase, you want to have a this phase expression back. And how do you do it? There are a lot of frameworks available which lets you validate your RAG workflow. The one that I want to recommend right now is the Ragas framework. It's from it's a quite used framework in doing validation within RAG applications. And what does it do? It tries to score your RAG application in 4 different variables. One is the context relevancy. So when you are retrieving data, how much extra unwanted information you're also retrieving from the database. So how much noise is there? Context recall. Do we have all the info needed that was required to answer this question retrieved? So your search result contains everything or not? Faithfulness. What is the accuracy of your generated answer? And answer relevancy is how relevant is the answer to the query. So basically, you're trying to minimize your hallucination and tuning your search results with 4 different parameters basically, and it scores between 0 to 1, so you know where do you lie in all these 4 aspects. And how does Ragas do this, or any kind of validation framework does it, is basically it asks an LLM on how the LLM is doing. Sounds like pretty funny stuff, but it's not. It creates a query and you provide a ground truth to this query, and then it uses your RAG workflow to create the answer and the context, and then it is sent to a large language model. It can be the same large language model which you are using to implement your RAG application, but it will do a scoring on all those aspects that I showed you last page, all those 4 aspects, and tells you what's the score between 0 and 1. So adding that evaluation or validation step at the end of the workflow is also what you need to have when you are implementing a RAG application. So yeah, at the end, you really want a face like this when anybody is using your RAG application. You cannot get something which is 100% perfect, but around 70 to 90 is quite good enough to achieve on a RAG application, provided you also have a feedback loop somehow implemented to it. How do you master your masterpiece is something which I call it adding metadata. So just like any other database, when you do a query, the bigger your where clause is, the faster your query would be. So for example, right now, there is a very sparse problem of adding rollback access to the vector databases. So what we can do is adding a role column along with other columns within the vector database. So when you're doing a query, not only doing a query on that, but also add the role which user is actually invoking the query. So in that case, you concentrate the query and your where clause gets tied, and you have a better performing query on a database rather than anything else. I will talk about 2 complex advanced RAG pattern. There are many more. Recently, Microsoft also released a graph RAG pattern, which is basically uses a graph SDK to create the embeddings on what it should query on. So check that out. I'll have links at the end of the thing. But the first one I want to talk about is a query transformation. What does it do? It's basically if you provide a question to the LLM or to the RAG application, it will create some sub queries from those from that main question. So for example, if I'm trying to find out how many schools are there in New York and Philadelphia, so it will create 2 different queries. For example, how many elementary schools are there in New York and how many elementary schools in Philadelphia, and it will do a search on both of the things and get results back and send both the results back to LLM to generate an answer. So the query transformation basically gives LLM a way to minimize the hallucination or make a retrieval much better. So you are doing an efficient query here and also an efficient reasoning here in LLM part. And now I saw a question somewhere about multi-agent application, the nuances. There are a lot of nuances there, but what is basically a multi-agent application? A multi-agent application is basically you divide your RAG application in smaller parts. So there will be a agent orchestrator, which has to be connected to an LLM somehow. And depending on the query coming in, it decides which all underlying RAG applications I should invoke. And those are called as an agent. And it can be multiple agents that can be invoked, or there can be a single agent invoked. And it is also quite optional that agent also has an LLM associated with it. And you can think on this agent, you will also have a query transformation running there, or you are doing a hybrid search there, or you're doing something more dedicated. And depending on what type of vector index you're querying, your answer would be different than that. Last but not least, there are many more examples, but I put 4 major industries, to be honest. Supply chain, for example, if you're doing compliance checks, or for example, validation for all incoming orders and purchase things that are going out, you can automate that using a RAG application. If you're doing reporting, validation, procurement, B2B sales, marketing, supply chain has a lot of use cases on that part as well. Customer support on the retail is a very well-known use case, to be honest. So you have a lot of documents, a new employee comes in, he or she doesn't need to go through everything to understand and provide a customer a proper support. This person can query on all the data that are there. You can use product recommender for a RAG, you can do feedback analysis with RAG, you can do marketing content with RAGs. In a finance and banking case, you can do claim processing, you can do portfolio management, transaction analytics, trend forecasting, document processing. Lots of applications of RAG if you are trying to achieve or implement it properly. But it's not that easy. There are nuances. I saw some questions in there. I didn't talk about all the nuances, but provided you basically the start architecture on how you can use it within your application. And it's an evolving topic, to be honest. In last 6-7 months, only the amount of progress we had in RAG is enormous. So keep an eye on this. Every day there's new thing coming up. Every day the vector databases are reinventing themselves. As I was saying, a vectorization of data takes a lot of space. So all major vector databases, so Quadrant, VV8, Azure AI Search, we are also trying to quantize this data. So binary quantization will make the floating point data to an integer data, and it will make the storage space smaller than previously. So it will also save you money when you're operating on a large scale RAG. There are a lot of things happening within RAG area, so keep an eye on it. And last but not least, since this is a kind of a .NET community, I wanted to talk about a little bit when you use semantic kernel to implement a RAG application and what would the flow look like. So when a question comes in, semantic kernel vectorize the question, do a query on the vector store, and then possibly can also invoke external APIs or use a database or some sort of other functions to gather more information. And then using all those contexts from vector databases and from the external APIs, it'll create an answer and send it back. And this is all possible with, this is the semantic kernel, but you can also do it with Llama Index. You can also do it with Llama Index and also with a LangChain, to be honest. And semantic kernel has a .NET SDK, which basically quite nice. Nobody else in the AI orchestration area has a .NET SDK. With that, I always prefer that not only what I have as a knowledge to share, but also sharing how you learn more. So there are a few articles which I quite liked when I talked about complex RAG. And there are a couple of examples from Azure side which talks about how you implement graph RAG or how you implement a normal OpenAI ChatGPT style RAG application using Azure resources. If you have questions, I would be happy to answer if I have time, and otherwise I can definitely see what all questions are there in YouTube and answer it there. Thanks a lot for joining. And yeah.
That was a lovely session, Soham, and I love the mouse that you had throughout your session. Uh, thanks for wrapping up so quickly, right? I have a lot of questions, but I won't ask that. Let's take a couple of questions, right? And thanks for wrapping up so soon. There's a question by Freya. She says, "Hi Soham, will you tell me how does RAG Fusion integrate vectorized document, images, audio, and video into a single model?"
Okay, I have questions on that question. But normally what we recommend, I cannot talk about other vectorized database, but what we recommend in AI search, the Azure specific vectorized database, that we do not combine image, audio, video, and text together. We create metadata to it. So for example, if you have images within a PDF file, for example, you have some text and then you have a description, then you have an image of that chapter, and then you have some more text. We recommend to generate metadata out of textual metadata out of those images and vectorize that along with the text. And if you have documents, if you have images which has those metadata, you create a link somewhere else. So you don't do a search on images, rather you search on text. I don't know how, I might have confused her totally, but
You're so honest. No, it makes
but
sense, you know.
you cannot do everything together. So the point is, when we do vectorization of we say vectorization of text is the way to go. If you have embedded images, audios, videos, you have to do it separately. So you have to transform or encode them somehow, create a metadata somehow.
Yeah. Yeah, I think what you say is 100% makes sense, because I'm not an expert, but I've used MongoDB vector databases, and there they clearly tell you that, hey, for text use this, for PDF use this. You have to do it separately for each one of them. So I think that definitely makes sense. Let's take another question that's from Atul, right? He says, hi, hello Soham, could you please explain the key architectural difference between standard RAG and RAG fusion? I'm interested in how these differences affect performance and use cases. Thank you.
Standard, I think naive rack. So you do there is no naive rack, to be honest. And I'm not sure what you mean by RAG fusion, but if you go a little bit advanced RAG patterns with any sorts of programming language or frameworks, it will affect your performance definitely, because either you're doing multi-step retrieval, or you are doing some sort of reasoning after your retrieval is done, or you're doing query transformation, or you are doing multiple searches in multiple databases. So it will definitely affect your performance. And when you are doing that, you will see it, because it also depends on how you chunk your data, what's the overlap, how much you're retrieving. So RAG is not at all easy, not even the standard, not even the fusion. The key is to figure out the first step, how do you chunk your data and what is your overlap. From that point onwards, if you have that figured out, the retrieval, you can play around a lot depending on your latency and throughput. So if you have a higher throughput and lower latency needed, then you do a simple search rather than all sorts of multi-transformation stuff. But the step is to get it right in your chunking and overlap. And that's actually the most difficult part to do.
Yeah, we have the thanks for asking that question. So, I have a question, but I don't know how quickly you can answer, right? Because we're already 5 minutes next to the session. So, your session was, I would say, 300, and some of the slides it was going like level 400, right? And we know that all these LLMs and this Chat GPT, RAG have come in about a year and a half, right? So, did you learn all this in just about a year and a half, or how
That's
did you
my
pick
part
it
of my
up?
job. That's my part of the job. To be honest, I work with Dutch
Wow.
B2B SaaS companies. So all startups, scale-ups, and also the established SaaS companies within Netherlands. And part of it is basically to give workshops, create workshops on app innovation and AI combined. So I have a background with Kubernetes for a long time, and also with natural language processing. So it came to me pretty easily. So it's all, as Amina said also, saying her name correctly, right? As Amira was saying as well, that you never stop learning. It just goes on and on and on.
Yeah, that's right. That's right. Thank you so much, Som, once again. I really loved hosting you, right? I'm so happy we have so many mutual connections, right? I keep coming to Europe, right? I'm coming again in the month of September for Experts Live Europe, right? I would love to meet you in some of the conferences there. Any final thing you want to plug in before we wrap up your session?
No. Thanks for the invite, and I enjoyed connecting with this community because
Yeah.
this was completely new to me. And yeah, good luck with your trip, and good luck with the rest of the conference. I'm
Yeah.
following it from the live feed in YouTube, and
Yeah.
cool.
Yeah.
We'll keep in touch.
Yeah. Thank you so much. So let's stay in touch and have a nice day. See ya. Bye bye.
Bye.
All right, that was so for you telling you everything about the RAG. I know, to be honest, now that he has one, I can tell you most of stuff went over my over my head. But I have to go back and rewatch it. It was a very good session. We now move to our next session. Our next speaker is already there behind the scenes. He's been very patient and he's waiting for us. He is Sri Varma. He's going to talk about simplifying multi-cloud observability. I always mess up with saying this last word. It's like a tongue twister to me. All right, ladies and gentlemen, let's welcome Sri Verma to Software Architecture Conference 2024. Hi, Sri Verma. Welcome to the conference.
Hello, Simon. How are you?
I'm doing absolutely great. First, how would you like me to address you? Sri Verma or Sri Verma?
Call me Siri. I'm completely all right with that.
Well, I have an iPhone next to me.
You have an iPhone, so be careful with that.
Yeah.
Always people run into issues with two Siris at the same time.
Yeah. So I know, Siri, we are already 8 minutes into your session, or actually 9 minutes into your session, but you get all entire 9 minutes, all 35 minutes. But before we get started, I was just going through LinkedIn profile and I realized, Siri, you were a Microsoft student partner, right? And I was a
Yes.
Microsoft student partner too, but
Wow.
you're like my super senior.
Yeah. I think this was during my college test in between
Yeah.
2011 to 15. I was a student partner for 2 years, and then I also traveled to Bhopal as part of my student partner
Oh, were you
journey.
there? I was there too. Right? They had a summit at the
Yes.
banquet hall.
Yeah.
I was there
So
too. Yeah.
I don't remember the college name. It is Gayatri College or something.
It was, yeah,
I
it was there are a few
Gyan
colleges.
Ganga. Gyan Ganga
Gyan
Institute of
Ganga, that's
Technology.
right.
Yeah.
That was a good
So
one.
it was pretty fun. And my
Yeah,
Microsoft
do you
journey
remember
started there.
Venkatesh, right? Vanky, right? He did all that event then.
Yes, I do.
Good old memories. All right,
Yep.
Siri, I won't take much of your time. Please feel free to go ahead and share your screen and then we can get started.
1 second. Okay. Let's see. Screen. Okay. I hope you're able to see my screen now.
I see your screen. You're inside the presentation. You're inside the slides. Yeah, I've added your screen to the stream. Maybe you would like to click on that hide button link so that it takes that away. Perfect. Everybody else can see your screen, and next 35 minutes series all yours.
Okay, awesome. Should I get started?
Oh yeah, 100%. You can get started.
Yep. Hello everyone. My name is Siri Varma Vegiraju. First of all, I would like to thank CSharpCorner for giving me this opportunity to present my talk on this topic, simplifying multi-cloud observability. In this session, we'll talk about multi-cloud observability, what are the complexities of observability in a multi-cloud architecture, and how to simplify it. Before we deep dive a little bit about myself, I am Siri Varma Vegiraju, a software engineer at Microsoft, previously at Oracle. In my free time, I love to contribute to open source, and I'm an avid hiker. Currently, I live in Seattle, and Seattle summers are the best, and a hike on a weekend is what makes it more amazing. I also love to review books, and this is my LinkedIn, email, and Twitter. Please feel free to reach out to me if you have any feedback, or if you want to talk anything about cloud, observability, software engineering, and distributed systems in general. I'm always open to talking to folks and learn from their experience. With that, let's get started with the talk. So looking at the agenda, first, we'll start with what is multi-cloud, why is it gaining a lot of popularity, and what are the motivations behind enterprises moving towards this architecture. Next, we'll look at observability. What is observability? How does observability help you track your service health? And what are the three main concepts in observability? Then we'll take a look at why the observability approach needs to change between a single and multi-cloud environment. What are the things that demand a change in approach when considering the multi-cloud architecture? Then we'll take a look at the complexities and how to simplify observability. And at the last, we'll conclude the talk. So what is multi-cloud and why is it gaining a lot of popularity? You see, when cloud was just a buzzword, people or companies hosted most of their services on-prem. When cloud adoption started, companies started hosting some of their workloads on cloud and on-prem. That is when they called it hybrid cloud. And then as the cloud adoption became stronger and as sophistications in how we build software grew, and building data centers is also not cheap. So companies started completely using cloud. And when I, as a company, use more than one cloud provider to serve my software, that is when I call it as a multi-cloud architecture. And a staggering 98%. This is part of a recent Oracle survey where what they have seen is 98% of enterprises, 98% of enterprise companies are either thinking about the multi-cloud strategy or are already on the multi-cloud strategy. And the key motivations for these companies to move towards this approach is first, data sovereignty. So consider I'm an enterprise company. I have my customers worldwide. I have them in different continents, geopolitical regions, and different countries. And each country has their own GDPR, has their own data privacy and protection laws. For example, United States has its own data privacy and data protection law. European Union has GDPR. Similarly, India, China, Japan, Australia, all these countries have their own laws. And if I, as an enterprise company, understand that my current cloud provider does not allow me to, or does not allow me to use some of these capabilities, that is when I would choose another cloud provider. Basically, where I get to is the cloud provider does not meet my needs. So I have to go looking out for another cloud provider. That is one reason. The second reason is vendor agnostic. If I, as a company, depend on a service that cloud provider offers, and if for some reason either the service is being deprecated or the cost is being increased by the provider, or the features drastically change, I, as a company, want to be agnostic of this. I don't want my business deadlines to be affected because of these changes by the provider. And that is one more reason why I would be vendor agnostic, and that is when I would choose a multi-cloud architecture. Third, cost optimizations. If I think about it, every cloud provider has their own strong points. Some offer free egress and ingress, some offer cheap storage, and some offer free VMs or cheap VMs. Now, if I, as a company, am in a place to use these features, then I can significantly reduce the cost it takes to run my services on cloud. And we all know that running services in cloud is pretty expensive. So keeping a vendor agnostic architecture will help me leverage these features and scale better. To conclude, the three main motivations being data sovereignty, cloud vendor agnostic, and cost optimizations. Of course, there are other things as well, but these are the three main contributions. Next, we'll take a look at observability. So what is observability? Simply put, the ability to measure the current state of my system. Is my system healthy? Is my system, the request latency is low? Am I meeting my service level SLIs, SLOs, and SLAs? All these answers I can get from observability. The better the observability story for your company or for your product, the better you're able to serve your customers. And there are three main concepts in observability: metrics, logs, and traces. Let's look at each of them. So coming to metrics, metrics are the numerical representations of your system performance. For example, let's say I am serving a request and I emit a 1 for a success and 0 for a failure. Now I'm able to plot a mean of this graph, which gives me your 5 nines or 4 nines of availability. And if I, as a company, promise above 3 nines or 4 nines of availability, these metrics help me understand if I'm able to meet that. And if not, I monitor, I write alerts so that I understand the system degradation and can mitigate the problem as soon as possible. And coming to metrics, there are four main things. One is your request, the total number of requests it is taking, edits or your availability metrics, duration metrics, which are your request latency metrics, how much time it is taking to serve a request, and your saturation metrics, which are your CPU utilization, your memory utilization, and disk utilization metrics. Next, logs. With logs, there are mainly two types: audit logs and your debug logs. With audit logs, they are for your mostly control plane and data plane operations. For example, let's say somebody creates a VM, deletes a VM, or updates a VM. I, as a company, would want to know what is happening. For example, let's say there's a threat actor that has entered my system and is randomly creating resources, increasing my cloud cost. So I would want to definitely monitor these, and that is where audit logs do definitely help us. Then we have the debug logs. Debug logs are things like your stack traces. For example, a request failed. How do you handle that? What is the reason the request failed? This is where stack traces come into picture. And also you can add additional metadata that help you further debug a request. Traces, on the other hand, in a cloud distributed system world where there are a ton of microservices, you would want to understand the lifetime of your request. For example, let's say a customer tells you that, hey, your request duration is high, sorry, your request latency is high, and your request travels to 6 or 7 different microservices. If I want to debug where it is taking a lot of time, I would want to understand where all the requests travel to and what is the latency at each microservice. Traces help you with that. It helps you identify bottlenecks and dependencies so that you get a holistic view of the system. So metrics, logs, and traces as a whole give you the entire observability story for your service. Now that we have fundamentals in place, let's look at why the approach to observability needs to change in a multi-cloud environment. Before that, some stats. On an average, a company using cloud to offer their services uses at least 15 different services. What I mean by that, for example, let's say I am a provider that offers logging product to customers, right? Where customers can come and ingest logs and search to them. What are the services I'll be leveraging if I'm using cloud? I might use an API gateway to route my request to different services. Then I have my load balancer, which we use to distribute requests across VMs. You have the VMs itself. Then you might use an Azure storage queue where you store all the logs. And then you have additional NoSQL databases to store your data, then storage, network. So if we just think about this, we have just listed down at least 13 or 14 different services. Next, a company uses at least 9 different observability or monitoring tools to manage their application infrastructure and user experience. By looking at the stats itself, we can quickly understand how complex it becomes as the number of moving parts grow. So this is the example of a code snippet I have where I'm just using the single cloud. So I am using the Azure Monitor SDK to emit metrics to the Azure Cloud dashboard, right? So in this case, I'm using a metrics client emitting a data point, and I can see that on the cloud provider dashboard. In this case, I'm just using one cloud provider. Everything is pretty smooth. I can set up monitors using one of the Azure services, and my service is healthy, right? Now let's take a look at how this changes in the multi-cloud world. So this is the code where I am using 4 different cloud providers, right? Of course, this might not be practical, but let's consider 2 of them, right? So let's say I'm using Azure Monitor and Google Cloud to emit my metrics and logs. So here in my code, I have 2 SDKs. And then on the right, what I see is 2 different dashboards to emit. 2 different dashboards I have to keep track of for emitting metrics and logs, right? From just the looks of it, we can quickly understand the complexities in cloud and operations. The complexities in cloud and operations the companies would have. So let's take a look at the complexities, right? First, because I'm having multiple SDKs, I have to maintain them. Either version updates or something regarding the SDK changes, have to maintain that. It is a continuous pain point. Second, I have to understand various cloud providers' implementations. Every cloud provider has their own schema, has their own way of representing dashboards, has their own SDKs, which makes it tricky when I'm on call. Imagine I being an on call and I have to go to 3 or 4 different runbooks to understand if each cloud provider's work, and then on parallelly I'm getting paged for different services for different problems, right? And then the schemas that each provider also offers is different. For example, let's say I have to search logs, and now what I end up is I have to go to each runbook, understand what the schema is in this cloud provider, and then search that. And when you're on call and when you are taking a lot of heat, this adds more trickiness to your day. So how do we solve this? How do we make operations, or how do we simplify operations? If I take a step back, what is the problem that I'm seeing here? because my tools are tied to a specific vendor, I'm not able to offer a unified experience to my employees or to my devs, right? So if I was generic enough, and if I design my architecture in a way that I'm agnostic to a cloud vendor, I can make operations smooth, right? So this is where cloud native comes into picture. So with the adoption of cloud growing at a rapid pace, a lot of open source tool came into picture. For example, you have your Kubernetes infrastructure, which started 10 years ago, and now Kubernetes has become a de facto for running services. Similarly, there are a bunch of other open source tools as well. So today, what we will talk about is one such open source tool called OpenTelemetry, right? So what is OpenTelemetry? Simply put, it is an open source standard and specification to emit your metrics, logs, and traces, right? So and also the major cloud providers like AWS, Azure, GCP, and Oracle already support this project. This is a cloud native computing foundation project, and many of the cloud providers do already support this. And the best part, it is vendor agnostic. You are not tied up to any specific cloud vendor, which is very critical when you think about a cloud, when you think about a multi-cloud architecture. So let's get deep into the OpenTelemetry world. What does OpenTelemetry have? So first, it has a specification. Specification talks about what I need to do when I want to implement OpenTelemetry in a specific language. We as developers don't deal with this regularly. This comes into picture when you want to implement OpenTelemetry in a specific language, right? And by the way, OpenTelemetry already supports a bunch of different languages: Go, C#, Java, Ruby, all these languages. Next, semantics. You remember the problem we discussed about not having a common schema? With semantics, we can define common schemas that get propagated to different cloud providers, which will help you querying your metrics, logs, or traces easy. And then we have the SDK itself. This is what we will use to emit the metrics, logs, to emit your observability metrics and logs. Fine. And next, there is an exporter. This is a fundamental piece in this whole architecture. Once we emit metrics, logs, and traces using the SDK, each cloud provider has their own exporter. Azure Monitor has their own exporter, AWS, Google Cloud, Datadog, Zipkin, all these have own exporters. These exporters query the OpenTelemetry SDK and then export those things into their own backends. And that is where we talk about the final piece, where backend is every cloud provider's own implementation. For example, CloudWatch can be AWS backend, Azure Monitor can be Azure's backend, and Google Cloud has similarly its own backend. To summarize, there are 5 different components in the architecture here. One is your specification, mostly comes into picture when you implement a specific language. Semantics, that help you define a common schema. The SDK itself, which you use to emit metrics, logs, and traces. Exporter, which the cloud providers already provide, and they are open sourced. You use these exporters to send the metrics, logs, and traces to the backends and the backends itself. Now, let's take a look at the architecture. We'll take a look at how in the world before OpenTelemetry, the architecture is. and currently with OpenTelemetry, how you can change this. So on the left, you see that you have a VM. The VM has your service, and the service is using the Azure Monitor SDK to emit metrics to Azure, right? Now, from whatever fundamentals and whatever discussion we had till now, what we understand is tying up the service to the SDK in a multi-cloud world causes a trickiness. Here, what we are doing is replacing the SDK with the OpenTelemetry SDK, right? The VM is same, the service is same, but the SDK itself changes. And then we have the cloud-specific exporter. To clarify, this is not any sidecar, or the exporter is not a sidecar. It is just another package in your C# or a Maven dependency in your ops, right? As part of your service, you emit metrics, you emit the observability pieces using the OpenTelemetry SDK, and the exporters extract those pieces, do any necessary processing they need on them, and then send it to the corresponding packets. In this case, Azure. Right. So this is the code snippet from when I'm using OpenTelemetry. So what I have here is a meter and a counter, right? These are the namespaces that belong to OpenTelemetry. And then I am adding exporters, something like this. So the exporter we discussed previously, we are adding it like this, like a Prometheus exporter and a console exporter. Similarly, I can add Azure exporter, Google Cloud exporter, right? And the amazing part is, if I see here, the way how I emit metrics does not change. So if I compare my slide to the previous one where we had 4 different SDKs, see the simplification that this infrastructure helps us. And tomorrow, if I want to extend it to a different cloud provider, I just need to add the exporter and an endpoint, right? That's it I have to do. I don't have to change any schema, any namespace, or anything of that sort. And this also helps you abstract these pieces out into a library so that you don't have to touch these pieces every time, improving your maintainability in the code. So this addresses our SDK concerns, right? Now, this is how the scenario would play out when you're using more than one cloud, right? In all the 3 cases here, what I have is the VM service and the SDK. None of these change. The only things that change is a package, which is your exporter, right? These are the only things that change. And then, of course, the backends, if wherever you want to export. Another thing that we discussed is not having a seamless experience for your dashboards, right? This is where Grafana comes into picture. What you can basically do is, with Grafana, configure data sources that belong to each cloud. For example, AWS has its own data source, Azure has its own data source, GCP has its own data source. And what Grafana will do is it export all those things into its own dashboard and provide one seamless experience. So where did we start? We started with not having a unified experience, having multiple SDKs and multiple dashboards, right? To now where we are is one seamless experience, just different exporters, which are already provided to us by the cloud providers, and then one single dashboard. see how we have streamlined the pipeline to make the experience much better for our devs. Now they are very much happy, right? So this is how you can provide one seamless experience and decrease the pain that operations have to go through. Next, so this is a good to know. Not, you don't have to, we as developers don't deal with this regularly. This is how cloud providers implement OpenTelemetry, right? So on the left, what you see is everything of this sort remains the same. But instead of talking to the Azure backend itself, the cloud provider talks to an agent, and the agent is the one that exports metric to the Azure backend, right? So this is normally what ends up happening is if I want to send any of the observability stats from my VM to a machine, agents are the one that used to do the job, right? Now I also want to provide backward supportability and also support the new ways of doing this things. So this is a good way to, this is a good segue where I'm also supporting the current infrastructure and the OpenTelemetry infrastructure as a cloud provider. On the second architecture diagram, what you see is an collector, right? So collector is nothing but a combination of multiple processors and multiple exporters, right? What I can do is, so this, because this collector is an executable, it might end up taking a lot of space on your VM or a lot of memory on your VM. Let's say I want to limit that. That is when I can have a processor to limit the usage of memory for this collector. Similarly, let's say when I'm a cloud provider, with the telemetry the customers are providing me, I also want to add some additional metadata. I want to do some massaging on the data. That is when I would also add additional processors. So if I think about it like a big data pipeline, I have the source, I have multiple processors, and then I have multiple exporters. And each exporter can send data to one of the backends, right? So this is one more architecture. To conclude, what I would say is if companies want to adopt multi-cloud strategy and if they want to grow in that space, being vendor agnostic will help them definitely scale. If it is single cloud, then it does not matter much, but being vendor agnostic will help them scale and help them offer their customers better experience and ship features faster. Then you have your, apart from these open source toolings, there are some other open source toolings as well. For example, with Prometheus, you can set up or emit metrics. Loki is also similar to Prometheus, but for logs. This is a plugin by Grafana. And then you have Zupkin, which is responsible for your traces. So all these have corresponding exporters, and you can just send the data to the backends, right? With that, I would like to conclude my talk. Thank you everyone for taking the time to listen to me. If you have any additional feedback, please feel free to reach out to me. Thank you.
That was a lovely session, Siri. I loved sitting back and listening to you. It was, your sound was like music to my ears, right? I couldn't have missed it for even a single moment. I really loved it. I loved your pace. Oops, I think he was closing his presentation. He ended up closing the browser, but I think he'll get back. Yeah, I know that happens, Siri.
Yeah, I thought of stopping presenting, but I pressed the leave studio button.
Yeah. So yeah, that happens a lot with this tool. There are a few
Mm-hmm.
questions. Let us take a moment to go ahead and
Yeah.
answer, right?
Mm-hmm.
Sophia is asking from the comments is how does OpenTelemetry standardize metrics and logs across multiple cloud providers?
Yeah. So normally what ends up happening is when you use, for example, the first piece that comes into the SDK, right?
Mm-hmm.
So each SDK, each cloud provider has their own standard way of defining things. But with OpenTelemetry SDK, they say, hey, this is what every cloud provider has to adhere to if they want to support the space, right? So what OpenTelemetry does is provides semantics and specifications that say this is what you all have to adhere to. And because this is open source, all of them meet that definition. And that is how they standardize things. So once you have an open source specification and you have defined contracts, and once people start adhering to those contracts, that is when things start becoming a standard. So that is how OpenTelemetry helps in being vendor agnostic and providing those standards. That is how they make it agnostic.
That's good to know. That's nice. Thanks for asking the question, Sophia. Let's look at the next one. There's another question by Priya, if I said that right. Can you explain how to optimize performance scalability in multi-cloud observability? I always mess this
Mhm.
up.
Yeah. I know it's a mouthful of word, right?
Yeah.
Yeah. So to optimize performance and scalability, actually, we don't have to do anything more than what we are doing today, right? That is the good
Wow.
part. So because this export, so when you deploy a service onto VM, right? You have this exporter that is sitting on every VM, not on every VM, with every instance, maybe every instance of your service that is actually doing the exporting of all the data points to the service itself, right? And in another case where we were discussing about how cloud providers deploy agents to export the data, they are already doing the heavy lifting, right? We just use the SDK and use an exporter, that's it. And rest of the scalability and performance are already handled by these exporters through the architecture of what OpenTelemetry supports and the cloud providers. That is all abstracted away.
Wow, looks like it's a very powerful tool.
Yeah,
Okay, I love tools where I love products that are built in public. So
yeah,
definitely, as you say,
definitely,
right? It's open
definitely.
source, so yeah, a lot of contribution
Hmm.
happening there. There's another
Yeah.
question which again coming from Priya, and I like it. Is can we integrate open telemetry with other observability tools like Grafana, Prometheus, or Jagger?
Yeah. So even Prometheus, Jaeger has exporters that you can use. So at the end of the day, what OpenTelemetry does is
Mm-hmm.
it divides things into two components, emitters and exporters, right? So Prometheus and Jaeger have their own exporters using which you can export to the backends. So think of it like this. Prometheus is a backend that you can use to monitor on, put alerts on, and emit metrics. Jaeger is also simply a backend, right? So each of them provide their own exporters, and you can just use that exporter to send the data to the backends. So
Mm-hmm.
yeah, that is how you can integrate OpenTelemetry with these things.
That's lovely, lovely. I don't see any more questions here, but definitely a very nice session that I think. I think so. Even if you don't, someone doesn't work with, a multi-cloud. I think this tool is people should go and check it
Yeah,
out, right?
definitely,
I really like
definitely.
this. I've seen people tweeting out like software engineers, right, saying that hey, this is what they've been using it. I know some of the startups
Hmm.
they also used it, but I never really spent some time. But I'm after your session, right? I'm really gonna go to that website, look at the documentation, and try to spend some time and learn this because I think everyone who works on cloud they should know about this tool.
Yeah, definitely. Even when I was exposed to it for the very first time,
Yeah.
I was just simply amazed by the power it brings to the cloud
Hmm.
adoption, right?
Wow.
The power this brings and how the open source helps us standardize things is simply amazing.
So if I may, Siri, right, what were the first few things that you did? I mean, was it a part of your job that you did, or when you went to this, started using this tool, what were the few early things that you did?
So I was initially looking at what are the so Microsoft as a whole is also moving towards open telemetry, right?
Mhm.
So there I went to some of these sessions and then understood what open telemetry is, how it definitely helps. That is where my journey started.
I
And
see.
then I started doing some proof of concepts on how we can adopt this in our team, in our org. And then I worked on building libraries so that the work I did can scale to other teams. And then initially started presenting talks on how this definitely helps our customers and us. So this is how the journey started, from a presentation which I attended to implementation. Yeah.
Wow, it's a lovely
Thank
journey.
you.
You know, see, I'm so happy to have hosted you today. We would love to host you in other events that we do. If
Yeah.
you ever come to India around maybe October, November here in Delhi, we do one of the largest. CSharpCorner does one of the largest
Yeah.
developer conference, right? We would also love to host you there too. We'll have to move to the next session, but before we do that, is there any final thing you want to say?
I love CSharpCorner, definitely. I love the talks here. It has been simply amazing. And then I will continue to listen to these talks. And then please explore open source tools. They are pretty
Yeah,
amazing, and if possible, do contribute to them.
yeah,
So,
yeah. I
and thanks for
100%.
hosting this, Simon.
No.
There were some great talks and I enjoyed them.
Yeah, thank you so much, Siri, for your time. I really appreciate it. I know it's a work day, so I'll let you go. Let's stay in touch and hope to see you soon. Have a nice day,
Yeah,
guys.
hope to see you
Yeah,
soon. Bye bye. Take care.
bye bye. All right, ladies and gentlemen, that was a very crisp and clear session by Siri about open telemetry and multi-cloud. We've had a lot of sessions around multi-cloud in one of the cloud conferences that we do, but this was definitely great. Now we move to our next session. I know we are running a little. We're actually on time. I shouldn't say we're running late, right? But let's see. Yeah, we're almost on time. So the next session is by Prakash. I know there was a session by Bruno, but Bruno got COVID, so we're sending him regards. And Bruno, we wish that you get well very soon. We'll now move to a recorded session by Prakash. Prakash is actually going to talk about effective system design using cap theorem. So without any further ado, this is a recorded session, so we may not be able to take question answers after this session. But yeah, after this session, we also have keynote, so stick tight.
So hello everyone, thanks for joining. Today I'm going to talk about cap theorems in system design. Basically, you can also call it cap principles. So they are the fundamentals or essential, I would say, concept underlying any distributed system design. As we know, in the today's times, systems are typically distributed because they're expected to be accessed and used across the globe. So, and hence it become even more important that we understand the underlying principle behind the system, like this cap theorem and how this works. So let's get started. So this is the agenda we're going to cover today. As you can see, we are going to discuss these topics in detail to understand, to make sense of out of these terms, and how to deal with it, how to kind of make sense out of it, and how to apply when we think about designing large systems. So with that, let's pick the first, I would say, topic, that is consistency. So consistency is kind of we might have read or gone through this in our curriculum as well, right? The ACID property of database, but it is I would say ACID is, I would say, naive in one way, because when the ACID principle says it doesn't necessarily consider different copies and all, that is in a very essential or common in today's world, right? Because system has to be distributed. So this consistency in CAP is, I would say, goes extra mile and talks about even copies sitting in different instances of that database. So what it means is that And of course, we talk about data nodes nowadays because one system alone can't, cater to the needs of the number of users and their load. So system has to have multiple nodes, data nodes, and copies across different nodes. So what consistency tells us in CAP theorem tells us that all nodes should have identical copies, right? So let's say user is kind of accessing or hitting. The user, if there are, let's say, hundreds of users and they got to get some data, so irrespective of which node are they hitting through load balancer, they should be getting similar data. So there shouldn't be any change with respect to that which node is getting, I would say, picked up by the load balancer. So it's really important in distributed system that this this consistency becomes super critical because nowadays we talk a lot about availability that will go next, but there are still I would say some systems, like especially the finance system, where the data accuracy matters a lot, and how it is I would say shown to the to the users, irrespective of which device they use it, which location they are using, and many other factors comes in picture. So consistency as kind of hence plays a role where the data accuracy across different nodes, across different servers needs to be, I would say, having super importance. So, so that is, I would say, consistency, how we define in this. So all the nodes should have an identical copy. A few other things that we can consider here is that, it is it's a strong form, the consistency we're talking about here, right? There are some loose form called eventual consistency that we'll learn later in this session. But we are saying that when in CAP theorem we talk about consistency, it's a strong form, means all the copies in different data nodes should have the same data, and wherever user access across the globe, and whoever accesses that, they should all get the same data. So that's a consistency part in CAP. So in CAP, C was the consistency. Now you can relate that what CAP means. So consistency, of course. Next is availability. So again, availability is again very important. And I would say nowadays most systems are built by prioritizing availability over consistency, and there is reason for it. So we'll talk about those reasons later, but let's talk about what availability exactly means. So availability, as you can understand, that systems should be available to take additional requests. That's what we are saying, that any read happening, any write happening, system should be able to respond that yes, it is able to take up the request, right? And if there is any failure, it should come back with a reasonable time. So it's not that okay, it is not available for longer time. Maybe a few seconds here and there, it may still be considered okay, but it's not like that it is kind of down for longer time or hours or days, right? So the availability is very important. I think you folks might remember that there was a down of, I guess, Google services for some time, and I think the recent example about the cloud force or something happened, that the antivirus system, and then for entire day the system across, I would say, globe, the users who were using Windows 10, they were impacted. People were stuck in the flights, even different, I would say, stock market, and a whole lot of problem came because system was not available actually. So you can imagine the problem can come if the system is not, I would say, designed for availability, right? So there's availability bit of CAP. The last is partition tolerance. So when we talk about distributed system, partition tolerance is going to become essential because we are talking about different network partitions. So basically, partition tolerance here refers to the network partitions, that their systems are connected with the network across the globe. So what we are saying is that when we say partition tolerance, so basically they should be able to establish the connections so that they can communicate to the different nodes of servers can communicate to each other. So that's basically we're talking about here. Now, what CAP does? So now we understood that what partition tolerance means, what observability means, what basically consistency means. So these were the three essential components of CAP. Now here is the interesting part. What CAP theorem says it? What it says is that in a distribution system, you can't have all three at the same time. You can have max 2, right? Out of CAP, you can have up to 2. You can't have all 3. So, for example, if there is a network connections failure, so basically it's no more partition tolerance. So you can't have availability and consistency both, because if it is available, it can't be consistent. If it is consistent, it can't be available in case of this the network failure. So what is saying that you can have up to 2. So you can have either mix of consistency availability, you can have mix of availability and partition tolerance, and you can have consistency and partition tolerance as well. So you need to prioritize that, whether your application is read heavy, write heavy, designed for consistency, designed for availability. What matters to you more? For example, I gave a few examples. Systems like financial systems, like any bank applications or any of that kind. For them, consistency matters a lot. If you're having some transactions, you can't afford to get updated balance maybe after few minutes or a few hours, right? You got to have a quick, I would say, change, and it should be reflect in all the places, all the copies. So that you check the balance from ATM, you check the balance from app or website, you shouldn't be getting different, I would say, data. So that's so in such financial, just example, right? There are many other example can be other, we can put it, but the simplest could be that. So you can't. So you got to prioritize consistency over anything else. So that is a consistency bit there, right? For example, availability. So let's take the example of X or Twitter, right? So there, if you post something, if you add something, it's okay if it is not coming quickly, right? You can manage it okay if you do it like now. Maybe it is coming after it is showing into your feed after, let's say, a few minutes. That's okay. It's not a big deal because basically it's not. I would say you're not having a lot of financial, I would say, loss over there. But in the financial systems, if the data is not consistent, so you can end up having some financial loss as well. So based on the use case, based on what kind of application you are building, you got to prioritize whether you care more for consistency or care more for availability. So this is essentially a CAP theorem. As you can read through that. So basically, example like so there's like CA consistency availability if you're looking for. So RDBMS can be the good example. If you're looking for availability and partition tolerance, so app systems like Cassandra, all those DynamoDB, they are built for AP kind of setup. If you're looking for CP, then of course MongoDB is a good example there. So these systems are configured, I would say, by default for some of these, either of these, I would say, variant. And there are some configuration that you can maybe tailor it, but this is the default one. And based on that, you can take a call that which one you would like to go with or which one you would like to prioritize. Now let's go a little deeper on these CA, AP, and CP system to understand more on those. So as you said, AP is availability and partition tolerance. So you're saying that you're okay to let go consistency a bit, but you would like to have more focus on availability of the system and partition tolerance. So what exactly we're trying to say? You're trying to say the same thing as I said. You're okay to okay to respond little bit stale data because you're prioritizing availability and partition tolerance a bit. They give the example of social media feeds, right? It's not a very big deal that your feeds are coming maybe a few minutes later. So you want to make it available more. Let's say your users are trying to reach your profile. If it is not available, they will be more annoyed versus your feeds are coming a little bit slower, right? So availability is more important in this case, in the social media, as I give example, right? Than the consistency. So that could be kind of called as a maybe AP systems, right? Where availability and partition tolerance are more important. Again, we are saying about partition tolerance. So we are saying distributed system across nodes are, the reliability part of it, right? That they are able to, you have designed the system which are partition tolerance or network partition tolerance to be specific, that in case of any network failure, you have some backup or some different system designed so that you can get, I would say, response. It's not totally kind of down as such. So you have taken care of the replicas or different things that you need to take care for network partition tolerance. Example, we gave that DynamoDB, Google Cloud Spanner, things like that. So these are like the typical AP systems. Now let's say what is a CA system? Okay, consistency and availability. So here it's okay that so what we do here, we prioritize availability over consistency for sure, and also basically we prioritize availability, and we are saying that we are okay to have this partition tolerance, and systems like Cassandra, video more with the example. What is CP here? Consistency and partition tolerance. We are saying that we'll prioritize consistency over, of course, we don't have availability, so we are excusing availability, but we want that consistency should be important, and of course, partition tolerance is also important, right? So, for example, MongoDB and all that could be example of that. So basically, these were the, I would say, 3 different version or variant of, I would say, that you can imagine out of CAP, that you can pick and choose that what your system is kind of closer to which one of that group, and accordingly you can take a call or you can design that. Now, I think we discussed a bit that nowadays applications are designed for typically AP, availability and partition tolerance. They're okay to let go consistency for most part, barring few exceptions like financial and few other critical, I would say, domain where consistency is more important. There is a loss if we are not consistent. So for that, there is a concept called eventual consistency. So although we are saying that we are not consistent in the same spirit as CAP theorem says for AP systems, but we are eventually consistent. What it means is that we will be eventually catch up with the consistency. So let's say there are some periods of time when we may not be consistent, means all the, let's take a technical example. So in data nodes, all the replicas, not all of them will have the same data for a period of time, let's say 15 minutes, 30 minutes, depending on the schedule of syncing and things like that. But we are saying that eventually we'll have, right, that the duration can be configured, right, based on many other factors. So that is the eventual consistency, that it's not like forever we are going to be inconsistent, right? So we are saying that eventually we'll be consistent. So that's the eventual consistency bit in AP systems. So that way AP systems are, I would say, preferred nowadays, that they provide availability and partition tolerance. At the same time, they also have I would say, if not strong consistency, means point in time consistency, but they have eventual consistency. So over a period of time, they catch up, right? So that's, for most part, or for most scenario, this is okay. This scenario can be accepted. So that way, nowadays most systems are kind of, I would say, taking this AP, I would say, availability and partition tolerance out of the two other variants that we just looked at. So hope now it is clear about, I would say, eventual consistency, what it means. Now there is a there's an extension to that. So you know, in cap theorem, what you say is we talk about either AP, you got about either CA, right? So or you can talk about AC as well. So there are three difference, but so there is an extension came in called PACELC. So what it means is that it's basically partition availability consistency else. The full form is little interesting. So partition availability consistency else latency consistency. So CAP theorem is not talking about latency as such. So this PACELC theorem has extended that what it is essentially saying that if there is a network partition, right, means you're not able to connect to other nodes, your network is broken, then either basically you can have availability, you can have either availability or consistency. You can't have both for sure. So that is one that is similar to, I would say, the CAP, but the difference is that if it is not, then what you can say, you can live with latency and consistency. So we are saying that instead of availability, you can have latency. So the data can be it can be little slow because it may take time to update, or it may take time to come back. Let's say there are some downtime. So you can if there is no partition, so you can have consistency and you can have latency. Means it won't be that faster, but yeah, eventually it will catch up. So you can pick between these two. So that's a PACELC theorem talks about. It's an extension of I would say CAP theorem. Now take a now this was the, I would say, essential of CAP and PACELC. Now let's take an example, so that way you will be more clearer on what exactly, how to visualize this CAP theorem in day-to-day, I would say, reality, right? So let's take an example. Let's say again I refer this example from one of the, I would say, I was going through some articles. So thanks to the people who gave I was come with a nice example. So it's very easy to relate with the CAP theorem principle, right? So let's say me and my friend are running a startup, okay, and the startup is all about noting down. Let's say this is a reminder service. So let's say I have some task tomorrow to do some important tasks. So instead of me noting down those tasks, I'm kind of running a startup where I'm calling to the number, and they are reminding me on certain time that, hey, you have a flight that day, you have an important meeting that day. So I'm getting a reminder from the service, right? Service provider. So I'm running that service provider where I'm taking I'm kind of taking a call from people to note down their appointments, and I'm reminding them on before, maybe let's say 5 minutes before on the actual appointment. So that's let's say I'm running a startup. So me and my friend are running a startup. So in this setup, let's say visualize how we can visualize the example of consistency, example of availability and network, this partition tolerance. So let's say somebody, one of the customer called me that, hey, I have appointment tomorrow at 9 o'clock, and of course I provide service to remind, so I'm noting down. Let's say it's a system that I am taking a note of in OneNote, or some system I have, or even I'm putting into some system that I maintain, and my friend also has something. So I noted down that, okay, this person has appointment at 9 o'clock, and due to some reason I'm not able to I would say my friend is also kind of my friend also maintains the list of the customers who have called, but due to some reason maybe I could not share the same data to him, right? It could be any reason. It could be I could not meet him, or maybe the syncing did not happen from the system that I'm kind of entering, and my friend is also having system. So there was some issue that the data that I have that Mr. X has an appointment at 9 o'clock tomorrow, my friend doesn't have. So let's say the customer called that basically to store the appointment. So what happens that since my friend doesn't have the data about that Mr. X has appointment at 9 o'clock tomorrow, and if my if my friend get a call, he will not have the data. So basically, the data that he has and I have is not consistent, basically. So it's like consistency problem that two system, in this case, two person are maintaining the data, and they are not having the same data. Ideally, they should have. So it's a consistency problem, right? So that is easy to imagine that how to visualize this. Now let's talk about availability problem. So in this case, to solve this the consistency, what let's say I have done is that I'm making sure that until I'm sharing all the data with my friend to solve the consistency problem, until I share all the all the data to my friend, I'm not going to take an additional, I would say, reminders call, so that there is no confusion, right? So let's say in this example, I have, let's say, 5 customer call for the reminders, and until I make sure that I have shared all the 5 customer detail to my friend, I'm not going to take a call. So let's say second example could be my friend got sick and he's not able to take care about, I would say, he's not working. So in this case, basically either I don't accept the call, so that is like I want to consistent, but so in this case, since my friend is not available and I want to maintain consistency, because otherwise he will have the stale data, it's availability problem. So my friend is not available, so basically I can't take additional call because I want to also maintain consistency, right? So in this case, you can imagine as availability, so the other node is not available at all, right, to take. Now let's say visualize this. Now to address its even availability, what I told is that okay, fine, so let's have it maybe whatever calls basically are having, you don't respond because you're sick, you close your phone so that all call comes to me. So basically I'm addressing the availability problem so that I'm available at least, and I'm also, since I'm only responding, so I'm also consistent because I have the data, and my friend is not at all taking, so he will not respond. So that way we are addressing the, I would say, consistency as well as availability problem, right? Now network like of tolerance, partition tolerance, right? So in this case, how to make sure that also be a partition tolerance. So in this case, let's say my friend is sick, how I deal with this partition tolerance. So to address that, let's say I'm hiring one additional person, support staff, who is making sure that whatever data I get when I take the reminders, from my customers, the person is making sure that the data is also updated into my friend's, I would say, diary or whatever note he or she is taking. So that way, we're trying to achieve this eventual consistency. So it may not be immediate, but at least I'm making sure that it is happening after some time. So it is not like forever. There is a gap between two systems. So this was a quick example to let you imagine that how to visualize consistency, availability, and partition tolerance in distributed systems, and how to make best use of that, and how to prioritize one over other depending on what kind of system you are operating and what kind of industry or domain you are operating. That's important. Okay, so this was pretty much about me, and you can imagine that I kind of professionally I'm working as a CNGM manager, and also out of my passion I do kind of speaking, blogging, and also I was XMP for Microsoft CSharpCorner. So of my interest, so I also started making some such computer science, I would say, data structure, algorithm, and also cloud and other stuff in my YouTube channel. So if you're interested, you can kind of go through that, and I do blogging as well. So these were, I would say, these were some of the references that I taken.
Hello everyone, join us for Beaker, one of India's largest Web3 and AI conference, which is taking place in Delhi on the 17th to 18th October 2024. This conference is designed by developers for developers. But why India? We chose India for its vibrant tech scene and its path to becoming a global economic leader by 2027. Bgrip offer a unique platform for professionals to connect, learn, and grow in the field of Web3 and AI. Be a part of this landmark event and seize the opportunity to contribute to India's tech journey. Hoping to see you all in this conference. Visit bgrip.live for more.
All right, everyone, welcome back to Software Architecture Conference once again. I'm your host, Simon, and we are almost halfway down to day two of Software Architecture Conference. We've had, I think, already 6, 7 sessions, and we now move to an exciting session of the day, and that is the keynote session. I'm really excited. You all know we're gonna welcome our very good friend Rodrigo. He'll be joining us from all the way from Mexico. He was here in India last year. We had a great time. I just can't wait. I think I'm gonna talk to him after all that time. So let's welcome the man, the myth, and the legend, Rodrigo.
Hey,
Welcome to the
Simon.
conference.
That's a wonderful presentation. Thank you very much for having me.
Oh,
I was looking
thanks.
at those pictures and I didn't have gray hair. It's amazing, right? Look at this.
Yeah,
I look
you,
like
you,
Gandalf the Grey.
oh, you still look very young and charming, Rodrigo. How have you
I
been
am
all this
charming.
time?
How are you, my friend? I'm super, super excited to be here today.
Yeah, we're really excited to have you too. I'm not going to take a lot of time. We're going to do a lot of chit chat towards the end of your session, right? I see you've already shared your screen. I've added it to the stream.
I
Everybody else
know
can
how to
see
do
it.
this. Yeah.
We have done it a while, right?
At
All
least
right.
I know. Okay.
Yeah, all right.
Cool.
Stage is all yours.
Awesome. Hello, friends, and welcome to the third edition of the Software Architecture Conference. And today is day 2. I hope you're enjoying the event since there are so many fantastic sessions and technologies that are being shown in this conference. And I'm Rodrigo Díaz Concha, as the presentation that Simon showed said. And I'm a Microsoft Regional Director. I'm also a Microsoft MVP since 16 years ago, currently in both the Microsoft Azure and development technologies categories. So we're truly living in exciting times, right? AI development has become more accessible, especially with the rise of generative AI, which is a type of artificial intelligence that generates text and also images and videos and audio and so many other outputs in response to prompts, right? For example, here's a video that was shared the other day in X. Amazingly, this person doesn't exist, and it's becoming, as you can see here, it's becoming very difficult to identify what's real and what's not. This video was created with the Runway platform and one of its latest models. You can go ahead and navigate to runwayml.com to see how you can create this fantastic kind of media assets. So inspired by that video, I opened up the browser, navigated to the Runway webpage, and realized that you can also use a photo to create a video from it, right? And here's the result. You can see that I uploaded my picture and the video was created, and it's kind of creepy, right? It's kind of disturbing. And you can also use
Welcome
the lip
to
sync.
my keynote, AI and GenAI for the busy software architect.
I hope you listen to that audio. You can also use the lip sync feature to input the text you want your photo to say. So you can see that this is more disturbing, right? Because now the photo is speaking. This is amazing, and you get the idea.
Okay, let's try this again. Welcome to my keynote, AI and GenAI for the busy software architect.
So yeah, I hope you're listening to the audio. I'm not sure if the audio is being transmitted from my computer to your speakers. And this is because I realized that I hadn't changed the voice that I selected beforehand, and then I re-rendered the video with this other voice, which is kind of...
Okay, let's try this again. Welcome to my keynote. AI
this
and
is
GenAI
this
for
is
the busy
fantastic. This
software
is
architect.
fascinating, and this is frightening, right? In all seriousness, we are truly living in exciting times, right? And of course, media creation is just one example of the capabilities of generative AI. According to Goldman Sachs, generative AI could increase global GDP by as much as 7%, or roughly $7 trillion over the next 10 years, which is fascinating, right? While many other predictions align with this, there are some that they don't agree with this, and that's fine. The important takeaway is that generative AI is not going anywhere, and it's rapidly becoming a crucial part of everyone's lives, okay? And this is why software architecture is more important than ever, especially if you're building software solutions and you're planning to incorporate or adopt generative AI functionalities or features in your own applications. So I think there are two primary ways to leverage generative AI: enhancing and improving your own tasks. In other words, how you can perform better your tasks, your daily tasks as a software architect, and how you can improve your end users' tasks. So let's see the first way. As a software architect, you don't work alone in an ivory tower, right? You don't work in isolation. I hope you don't do that. So you're working alongside business professionals, you're working alongside marketing team members, software engineers, testers, product managers, and so on. So those kind of processes and tasks and workflows, when you want to communicate to those people, you can improve those, right? So for instance, with generative AI, you can create documentation. You can open up your favorite model and type your requirements or your code, and then create the documentation for that particular project. You can also create diagrams. For instance, you can create, just one example is creating database diagrams, relationships between tables and so on. You can create those with generative AI technologies. You can also use generative AI for requirements analysis. In other words, you can input your requirements and let the model to give you some suggestions about the requirements and about the software architecture that you're trying to create, right? Trade-off analysis. This is another big one for us software architects, because you can input all the requirements and all the context and different scenarios, and you can also grab a lot of different data sources like emails and I don't know, maybe documents in paper, and you can scan those and grab the text and let the generative AI technology to give you an analysis of the trade-offs about that particular project. And it can also give you suggestions, as I said, and you can also automate processes, right? For instance, maybe you are reporting to your team daily or each Friday or so on. You can automate those processes by saying to the Gen AI technology, hey, you know what? I want this report or this email to be sent out to my team daily or each Friday, and so on, right? And it can also improve communication between team members. As a software architect, you're writing a lot of emails, you're writing a lot of reports, you are communicating to those people that I mentioned before, such as business professionals, product managers, marketing members,
and whatnot. And you can use generative AI to create a template for those emails or those kind of communication mechanisms, and let the Gen AI technology to create the content, and of course, send it out to your team members. So software architecture tasks and workflow is just one example. You can also use Gen AI for software development and software engineering practices, such as code explanation. This is a big one. You can use today technologies such as Copilot and let Copilot to explain this particular code snippet that you maybe don't understand because you didn't create it. Or maybe you did and time has passed and you don't remember what was the reasoning behind the code, right? That happens a lot. And you can use Copilot to explain the code. And this is important for legacy code bases, right? Us software developers and software architects were struggling frequently with code bases that were created, I don't know, maybe 10 years ago or 9 years ago with ancient technologies such as, I don't know, maybe .NET Framework, right? Or Visual Basic, or an older version of Java, and so on. So with this code explanation feature, you can understand what's going on behind the reasoning of that particular code. Code generation. Of course, you can create code and you can input the requirements. This is, you can use Copilot, but of course you can use ChatGPT or Claude or any other chat-based Gen AI platform. You can input your requirements and let the Gen AI technology to output the code. For example, you can say, hey, create code that communicates to this server by using TCP sockets, and the address is this one and the port is this one, and I want to use this class. You can input those requirements and let the technology to output the code. And you can also say, hey, I want this code in Python. I want this code to be created in JavaScript or C# and whatnot, right? And code documentation. You can grab your code, your existing code, and let the technology to create the documentation, because nobody does documentation nowadays, right? So we have these technologies. Documentation is perfectly fine, it's quite needed, and it's helpful. The thing about documentation is that it becomes super outdated very rapidly, right? So with this kind of technologies, you can have your documentation to be in sync with your code. And another example is creating synthetic data. This is a big one when you are trying to create some kind of data set that you want to use for, say, unit testing or for training your own models. That's something that I truly don't recommend. But if you're doing that, maybe you need some kind of data set, and you can create that data set by using synthetic data created by a large language model. So I've used this in the past for unit testing. This is perfectly acceptable, mainly when you want to, I don't know, test some kind of function or behavior that needs different variations of data, and you don't have enough imagination to create, and time, of course, to create that data. Okay, so synthetic data creation is another example that we can say about Gen AI, and for product management as well. So you can pitch your idea to this model and let the model give you suggestions or give you comments about your product idea, about this application that you want to create, right? For instance, you can say, hey, I want to create this application that, I don't know, tracks the activities and behavior of my kids in kindergarten, and I want to try this scenario, and I want to create this mobile application, and I want to do this and do that, and let the technology give you back suggestions and comments about that idea. You can also create roadmaps. You can create your product roadmap or application roadmap. Let the technology give you suggestions about that. Visual assets, this is a big one. You can see that I'm using some nicely done images that were created by using Bing image creation. In the backend, this is DALL-E. This is the technology that was created by OpenAI. But you can see that you can create visual assets, and you can also create text, as I mentioned before, and wireframes for your user interface. That's another big one when you are trying to create something rapidly and you want to take advantage of GenAI for your products, right? So there are many other different scenarios where you can use GenAI when you are trying to improve or you're trying to make more agile your daily tasks, right? So what about this application that you're trying to create? You're planning this solution and you want to implement GenAI features and logic and behavior in your application. What about that? So here, there are like thousands and thousands of options that we can use nowadays. And most of the time, those GenAI solutions will be based on chatbots, will be based on agents. The difference between chatbots and agents is that a chatbot, you give a prompt or ask a question, and it responds back with the response, right? With the answer that you're trying to find. And agents are some kind of applications that are running all the time. And agents, instead of just responding back, they do things. Okay, they perform tasks. This is important. Agents are paramount, and I believe agents are one of the most important and will be one of the most important features of GenAI in the following months and years. In other words, you can create applications that do the work for you. I was saying this example, this scenario where you send this report to your team members daily or each day, or I don't know, each Friday. So of course, that application needs access to your email, needs access to the other people's email addresses. And I don't know, maybe it needs access to this particular database or documents, since you want to, create content based on that. So agents, my friends, are what GenAI is going to be, where GenAI is going to be huge in the following months and years. And of course, you have to take advantage of multimodal models. In other words, models, you can input text, you can input images, you can input videos, and also audio. For example, you can see the OpenAI ChatGPT application in your mobile and speak with the model, right? You're not sending text. You're just speaking with this virtual thing that is responding back. And with of course, it comprehends natural language, and you can speak as if you were speaking with other person. And this application, this technology, this intelligence is responding back, and through audio, and of course, video and images as well. You can also create connecting the dots kind of solutions. And this is where you want, as I mentioned before, you want to use data from your databases. You want to use data from your emails, right? From your users' inboxes. Or maybe you want to scan a lot of documents that you have in paper and extract some text from those documents, and then let the intelligence connect the dots for you, right? For example, hey, I want to know what was the most important product that we have sold in the past 3 years or something, right? And let the intelligence connect the dots for you. And of course, media and content creation, like the videos that I showed before, right? And speaking about those videos that I showed, I hope you can sleep at night today after watching those videos. Okay, so as a software architect, you have to be aware of some quality attributes, right? Software architecture is all about trade-offs. It's always about trade-offs. So it's impossible to have all the quality attributes in the world in a single application, right? So you have to identify what are the most important quality attributes for your solution. And when you're using GenAI and you want to adopt and implement some kind of GenAI features in your solutions, security is paramount, okay? Security, usability, availability, right? Because nobody wants this application, this solution to be available, I don't know, maybe just a couple of minutes each day, right? You have to have this availability for all your users. And of course, observability is a huge one as well, since large language models and GenAI technologies are stochastic. In other words, you don't know if the next response will be the same as the previous one. Of course, you can manage some parameters such as temperature and so on. However, the nature of GenAI is to be non-deterministic, right? So you have to be aware of that. That's why observability is one of the most important quality attributes for your software solutions when you're implementing this kind of solutions, okay? So security, before I go to this other slide, security is paramount as well, because jailbreaks, those are quite common nowadays when you're using large language models. You don't want to do that, and you don't want your users to jailbreak your GenAI solutions, okay? So pattern and styles. So patterns and styles, speaking of software architecture, of course, you can use actually any kind of style or pattern that you're using nowadays. You have to consider your model as any other module, any other component in your overall architecture. So I believe it's not different than having this, I don't know, this service, this endpoint, this component, this, I don't know. You can use monolithic architectural style. You can use microservices. You can use serverless. And you can also use and take advantage of edge computing. And this is going to be huge in the following months and years, since small language models are becoming more capable than ever. So not large language models, but small language models that can be run in small mobile phones, or I don't know, devices or laptops and tablets and so on. Okay, so how you can transform your career path as an AI architect? Let's talk about this. First, skills. You need to have problem solving and creativity. Okay, you have to be creative. You have to know how to talk to the model. You have to know how to speak with this intelligence, right? I'm talking about prompt designing and prompting techniques, okay? And this is critical. Focus on the real market needs, okay? You have to understand who the real customer is. So there's no reason why you want to use AI and GenAI just because you want to use it, right? Don't fall into FOMO, right? Fear of missing out. You don't need AI if you don't identify the market and the real need for your GenAI feature, okay? And of course, you have to understand and apply responsible AI principles and ethical implications of AI, such as you have to understand your users. You have to understand the data that you are sending out to people, okay? So here's this phrase from Robert Greene, the author of the 48 Laws of Power, which is a fascinating book. The best way to protect yourself is to be as fluid and formless as water. Never bet on stability or lasting order. Everything changes, okay? So you have to adapt because this is a moving target, friends. AI is a moving target. Each day, you can see in the news, in LinkedIn and social media, there are like thousands and thousands of different applications and frameworks and options and models related to Gen AI. So this is a moving target. Technologies and techniques. Speaking of those, you have to understand models. You have to understand the basics of and essential traits of models. And of course, frameworks that you want to use in your applications for building this kind of solutions. RAG, vector databases, and glossary. So let's talk about models. I'm talking about large language models and also small language models. I'm always confused about that L. Small language models. So, for instance, if you want to implement this Gen AI feature in your application, you have to identify if this super huge model is going to be enough, or maybe this other smaller model is better, right? And you can also identify, and you need to identify closed source and open source models. For example, OpenAI's models are closed source, right? Such as GPT-3 and GPT-4. Those are closed source. And you can also use open source models such as Llama or Mistral or some others that are, as I said, open source. And you also need to identify if a general purpose or a specialized model is enough for you, okay? There are some models that are general purpose, and there are some others that are specialized in a particular industry, such as healthcare or marketing and so on. So you have to identify that. And finally, you have to specify if you want to use a software as a service solution, such as OpenAI's endpoints or Azure or AWS and so on. Or maybe you want to host your own models in your own infrastructure or private cloud, right? So I think that's better when you are trying to lower costs and you want to keep your data with you, right? And not let the data go out to this other external third-party company. So just be aware that models come and go. Each day we're watching the news and social media, and models are everywhere, right? Thousands and thousands of models. And here's an interesting chart that I found the other day in LinkedIn. And on average, 60 days down to 20 days in the last 6 months are the average that a model is in the top in the charts, right? So, for instance, Gemini 1.5 Pro, blah blah blah, it was just 3 days at number 1, just 3 days in the charts. So we're not talking about the music charts. We're not talking about the Billboard, where some albums stay in the charts for years and years. No, this is quite different, right? Just take a look at this one. Number of days at number one, just one. And of course, this is because this is a new one, ChatGPT 4.0. This is another one that has stayed for a long time in the charts. You get the idea. Just be aware of models. They come and go. You have to identify and you have to test those models just to see if they could work for your solutions. Talking about frameworks. So there are many, many dozens of different frameworks out there, okay? So I'm just including 4 here. Semantic Kernel, which is a fantastic framework for creating LLM-based solutions by using .NET and Python. You can also use Haystack or Llama Index or LangChain for building those solutions. What's cool about Semantic Kernel is that if you are a C# developer, Semantic Kernel is first-class citizen in the .NET world. And Llama Index, LangChain, and Haystack, you can use Python, and you can also use other programming languages. RAG, Retrieval Augmented Generation. This is a very famous pattern and technique for using your own data to give context to the intelligence so it can respond back with grounded data. In other words, it can respond back with the data and information that you want, your private data and documents. So this is another pattern, and this is another thing that you have to be on the lookout because there are many different options and different techniques for doing this. And of course, vector databases. Vector databases allow you to store embeddings, which is a mathematical representation of words, and the explanation is more detailed than that, but it actually, a vector database allows you to store a vector, which is, in the Cartesian chart, you can store those big numbers, and you can retrieve those data and information from the vector databases in many different ways, such as you can use Azure AI Search, Chroma, Pinecone, many different options that we have nowadays. And finally, you have to be careful and you have to be aware of hundreds of different words and terms and little phrases about GenAI, such as fine-tuning, zero-shot, few-shot, and so on. So I totally recommend to you understand the basic, right? You understand the essential glossary of GenAI if you want to create this kind of solutions. You don't have to be an expert in the transformer architecture. And actually, I truly believe you don't have to be an expert in deep learning, and you don't have to be an expert in machine learning as well. But actually, there's a nice example. This is a web page that you can navigate to understand how transformers work. And transformer is an architecture that is used by the GPT kind of models and other models as well. So this is a pretty cool web page that you can use to understand the math behind a transformer. Okay. So use cases, the top 4 use cases that McKinsey and Company detected some months ago are software engineering, customer operations, product research and development, and marketing. So those 4 are the top use cases where you can use GenAI. So you can see there are, of course, other use cases, but those 4 are the most important ones. Challenges. So don't trust the models blindly, okay? They hallucinate. they're trying to be gentle, they're trying to be helpful. So there are times where they just make up things, right? They hallucinate. That's the term. So that's a challenge. Culture. You have to have the culture. You have to have the team topology to create this kind of solutions. Maybe you have to change the way you work nowadays if you want to adopt and you want to implement GenAI in your software solutions. So you have to have the buy-in from the company itself and the stakeholders, and maybe the culture will need to be changed. And finally, don't let analysis paralysis to stop you from creating something, right? Begin now, start now. There are many technologies and platforms and models and frameworks out there that you can use today, okay? Don't let analysis paralysis to stop you. And it was so great to be here with you, friends, and enjoy the rest of the conference.
Thank you so much, Rodrigo. And it's always so nice to hear you. Your voice is like music to our ears. We have missed you so much in those all the live shows that we
Oh my
did.
God! Thank you so much for your words, my friend.
All right. So there's a question, and we have about a minute before we go. There's a question from Freya. She's asking, right? And if you could just please answer, right? She's saying, how can AI be integrated into existing software architecture to enhance efficiency and intelligence other than using OpenAI API?
Right. Yeah. I hear you. Yes. So AI by itself, you can use large language models. If you want to use GenAI, right, you need some kind of model that was trained beforehand, so it responds back it responds back to your prompt. But of course, you can also use pre-trained and pre-existing services such as Azure Cognitive Services.
Yeah.
That's one example of an AI that is already available for you, and you can invoke its functionalities and increase the behavior and improve the behavior of your applications without using OpenAI. So speaking of OpenAI, you can also host your own models locally.
Yeah.
You can use say Llama or Mistral or Gemini or Phi, which is a model from Microsoft. You can download those models locally and run them without going out to the internet. So that's another way you can use for implementing GenAI in your own applications. That's actually what I do in a project nowadays by using semantic kernel and Llama all locally without going to OpenAI's endpoints.
Wow. That's pretty cool.
Yeah, that's pretty cool. Yeah, because OpenAI, I think it's a fantastic technology, company, and it has fantastic technologies. But the thing is that you are paying for your requests. You're paying by the token. Yeah. So it's a software as a service solution, right? So you are paying for your requests and responses. So if you want to do more locally without going to this other third-party platform, I think it's the scenario that I explained is a good example of how to do that.
Yeah, I think that's very well answered, Rodrigo. Thank you so much. I think it's time to wrap, and we have moved to the next session. Right. Thank you so much, Rodrigo.
Thank you for having me.
Yeah, let's stay in touch. Have a nice day ahead. See ya. Bye-bye. Thank you once again.
Bye-bye.
All right, ladies and gentlemen, that was Rodrigo for you doing the keynote session for day 2 of Software Architecture Conference. If you have just in case missed any of his pearls of wisdom, you can always go back and rewatch this session. And just in case you want us to remind you about these session recordings, go to the Software Architecture Conference website, which you can find it in the description where you're watching, or maybe just Google, Bing, or Chat GPT, or whatever you want to do it. We are the only one doing the Software Architecture Conference, so big. So you'll find the registration link, just register it, and we'll send you all the recording links direct in your inbox. With that said, it's now time to move to our next session. Our next session is by Lukas. He's going to talk about hacking MySQL for big data. I'm really excited. So without any further ado, let's bring Lukas to the Software Architecture Conference. Lukas, welcome to the Software Architecture Conference.
Yes, glad to have you here. And I hope you will learn something from my talk. And the talks before me have been very insightful as well.
Yeah, Lukas,
thanks. Talk will be just as insightful as well.
Thanks, Lukas, for accepting this session. We have not had an ethical hacker on this conference yet, so we are really excited and looking forward to your session. Please feel free to go ahead and share your screen. On the bottom of your screen, you can find the present button. You click on it, share screen, and then you can do it.
Can you hear me okay? Is my microphone working? Yeah, okay.
You're loud and clear. Your voice is very crisp. No problem at all. And you're joining from Lithuania?
No, I actually live in Spain right now. So
we gotta update that video then.
Okay. You're right. So you should be able to see my slides right now, yes?
I see it. Yes, you are inside these slides. You're not in the presentation mode, right? Yeah. Perhaps you want to click on that slideshow just to make sure it picks up the right screen. Are you going to go on the slideshow mode, or that's how you're going to continue?
I think this is how I'm going to present, if it's okay.
Okay, absolutely okay. I just thought you wanted to do it. All right, so Lukas, next 35 minutes is all yours.
Okay, so thank you, Simon, and welcome to my session, Hacking MySQL for Big Data. This session will be related to database management systems. As you can tell probably by the title, it will be mostly related to MySQL, but I hope that other people working with other database management systems can learn something from this as well. So this speech will be focused on MySQL running bigger data sets, hence the name, Hacking MySQL for Big Data, right? So before we begin, I would like to kind of introduce you to the table of contents, to the things that we are going to be speaking about right now. So I am going to begin with a preface, with an introduction. I'm going to introduce myself, introduce the talk. I have been already introduced, so that's good. So I have only to introduce the talk right now. We're going to talk about how do we understand big data, because everyone might understand big data a little bit differently. We're going to talk about why you should choose, why would you choose MySQL when working with big data? What's the role of MySQL in bigger data sets? How to work with MySQL for bigger data sets, and also cover some things, interesting things you should know that you are probably not knowing right now. So stay tuned till the end of the talk. Right, so initial preface, a little bit about me. I'm a security and database guy. I run a database search engine, what was already been mentioned. I wrote a book about MySQL, which is also titled Hacking MySQL, which is coming out early next year or in a month or two. Forward has been written by Louis Davidson, who has been in the SQL world for over 30 plus years, and he has the title of Dr. SQL, which I'm really proud of. So Louis, if you're watching this, big up to you. I'm also a speaker at conferences. I spoke at Build Stuff, Percona Live, MariaDB conference, Big Data conference, and majority of other bigger conferences. You will see me speaking about security, if not about security, about databases, just as I'm doing right now. I also run a blog. I blog in multiple places, in DB Visualizer, in Redgate, and my own blog in Database Dive, on Breach Directory, and on other places, and I run YouTube channels as well. So if you go to the website Database Dive, you'll most likely be redirected to a YouTube channel called Database Dive, where I share YouTube video content about databases as well. So great. So how do we understand big data, right? So we understand big data as something that ordinary systems can have trouble dealing with, right? So if you ask 5 developers what is big data and how do we understand big data, you're probably gonna get similar but a little bit different answers. So big data sets for our use case will be anything with around or more than 100 million rows. When you're working with bigger data sets, of course, data format matters, which if you're working with non-relational databases, your data format will most likely be JSON-based. If you're working with relational databases such as MySQL, MariaDB, or Percona Server, your data format will be mostly fit for relational databases. I'm going to get into that in a moment. And you also need to consider your use case as well. So if you're building a data breach search engine, which was my primary use case, and it can be found at breachdirectory.com, I built it on MySQL primarily. You are going to need to deal with your database in a little bit different fashion than usual, most likely. Right. So why you should consider using MySQL in the first place? The first thing you should remember is that MySQL is not only MySQL. MySQL is it has 3 different flavors. We have MySQL Server, which is obviously MySQL that you know. The recent version, I think it's already MySQL 9, if I'm not mistaken. There's Percona Server, which is a fork of MySQL, and there's also MariaDB Server, which is also a fork of MySQL, and they also work a little bit differently depending on what database management system you use. And depending on what flavor of MySQL you use, you will have multiple choices of storage engines to choose from, and so on and so on. MySQL, it's generally proficient and very well known in support for ACID technology, which is basically 4 different parameters that denote data consistency, right? So A is atomicity, C is consistency, isolation, and durability. And those parameters, they make sure that your data doesn't get corrupt when your electricity goes out, when your internet goes out, and you're importing data, right? So that's important. But also, you should consider using MySQL depending on your use case, right? If your majority of your use case is, for example, reading operations, MySQL will be very good fit. If majority of your use case is writing operations, then, and if your majority of your use case you have non-structured data, maybe you should look otherwhere, right? So the role of MySQL, it depends on multiple parameters as well. So MySQL doesn't come alone. It has a bunch of different...
Excuse me, Lucas. I'm
Yes.
really sorry to interrupt. I think your slides are not changing.
Really?
Oh, yeah.
What slide are you seeing?
The first one.
The first one? Oh, really? I changed it a couple of times already. Wait 1 second. Is it changing now?
You're on the first slide at this
No,
instance.
it's still not changing. Okay, let me share the slides through Google Slides then.
No problem at all.
1 second. Right, I have the Google Slides right here. And then present. Now you can see, right?
Hold on. Yeah, I see your slides definitely.
First slides.
And,
the second
now
slide.
you go to the second slide. Yeah.
Right. Okay. Now we. Right. So if it's okay, I'll make it. All right, so I can share it like this if it's okay.
No problem. Yeah, great.
Right, so we'll have to start from the beginning because my slides didn't change apparently. So for those of you who have been here previously, we are talking about hacking MySQL for big data and how to use your database to basically work with bigger data sets. Right, so what we already covered in the beginning was what is big data and why you should choose MySQL when working with big data. What we will also cover is why would you choose MySQL for big data and things you should know. Right, so as I said, I'm a security and database guy. I run a data breach search engine at databasedive.com. I run a YouTube channel, and I also wrote a book for A-Press titled Hacking MySQL. I'm also a speaker at multiple conferences, including this one. Right, so we already covered a little bit of big data, but as I said, each developer understands big data differently, right? So for some, big data is 100 million rows, for some it is 1 billion rows and above. But for our use case, where, as I said, we're talking about anything with more or equal to 100 million rows, and you should also consider your use case, as I said above, as I said earlier. Now, why MySQL? I started talking about this, and then I had to change to Google Drive, so I'll repeat it again. MySQL is not only MySQL. MySQL has three flavors. Primarily, it's MySQL Server, Percona Server, and also MariaDB. Each of those database management systems have their own unique sets and capabilities, including storage engines. For example, XtraDB will also only be available on Percona Server generally. InnoDB will be available on all three, and TokuDB will be available on Percona Server and MariaDB most likely. MySQL, as I said, also supports ACID, which means that basically if your electricity goes out, your data doesn't get corrupt. And basically usage of MySQL or no usage of MySQL, it depends on your use case. Right, so here's where we got stuck. So in essence, MySQL has a couple of parts. It consists of the file system, storage engines. It consists of a parser, the optimizer, and the SQL interface. It has hashes and buffers, which can either be global or engine specific. And it also has a connection pool, and it also has connectors, which means the ways you connect to your database. You can connect through C, through Python, through PHP, or through other measures. The reason why it is so important is because the structure of the database is often the first thing that you will get stuck with when dealing with bigger data sets. The thing you have to understand is that, for example, MySQL's primary storage engine, that is InnoDB, it stores all of its data in one file, that is IBData1. IBData1 stores data, indexes, and all of the other metadata. Newer versions of MySQL, mind you, split the files that are in your database and the data that is in the file, the IBData1 file, because in older versions of MySQL, it wasn't possible to basically deduct the if you would drop your table in your database, your data would still reside in the IBData1 file, and the only way for you to get rid of the IBData1 file would be to delete it. But if you deleted it, all of your data would be gone. So newer versions of MySQL overcome this problem. But anyway, there's a couple of more things that you should understand when dealing with bigger data sets. And the primary thing is your use case. What I show here, for those who are not really aware of this, it's my data breach search engine available at breachdirectory.com. And I'm using MariaDB to facilitate searches through data using the search engine. And if you input your email, username, IP address, or a domain, you can basically get a message whether your data is at risk or not, or whether you should change your passwords or not, basically. Basically, it tells you whether have you been hacked or not. So I highly recommend you using this. I have a lot of well-known people, universities, companies, and so on using this. So it is a reputable service, and I'm very glad I made it. Right. So when dealing with bigger data sets, most likely you will need to run a couple of queries through your database, right? So the fact that you need to run queries through bigger data sets most likely comes through a need to loop through something and then run some kinds of queries and then return results to a user, right? So what you see now is essentially a loop that loops through all of the tables in the database, puts the table name into a variable name, and then basically uses a prepared statement to loop through all of the available tables where a specific search type is equal to a search query provided by the user. The important thing here is that the search query and the rest of the query are separated, so there's no SQL injection, which is a primary objective of prepared statements. And then we grab it and put everything into a results query, as you can see here, if it's visible. And then we do whatever else we want to do. The most likely scenario will be something like this. But for this scenario to be true, you would have to have the first thing, data. Your data will be of some class. So if you're dealing with data breaches, it will be most likely more sensitive data. If you're dealing with I don't know, banana factory, most likely you're storing types of bananas or something there, right? Regardless of the data class, you will have some sort of data and you will have a lot of the data, right? Next thing you're going to have is a database management system. And another thing is a VPS that you store the data in. And you're most likely going to upgrade to a dedicated server when the time comes, because your data will be bigger than usual, most likely, and VPS won't be able to deal with it anymore. That works when you have more than 5-6 billion records, like something around that range. If you're dealing with such big data sets, you're inevitably gonna need a backup plan as well. So a backup plan to backup big data sets is also a very important option, and we're going to talk about it in a second. And you're going to also need luck, depending on what kind of services you run. You are going to meet some people that are probably not having your best interests in mind, or just having issues with the hosting provider that you need to know how to fix and stuff like that. So here we come to your server. The slides right here are a little bit off since it's a Google slide, but it's okay. Here we come to your server, right? So for your server, you would need to optimize a couple of parameters to optimize MariaDB, MySQL, or Percona server. These parameters would most likely be InnoDB buffer pool size, InnoDB log file size, flushing log at transaction commit, and a couple of other parameters if necessary. These can be found at the documentation. What these parameters do is the buffer pool size found here, it makes your insert queries faster when you insert a lot of big data, right? Because it makes MySQL be able to use more operating memory when inserting data, which in turn makes your insert queries faster. Now you don't need to have 64 gigabytes of RAM on a server to make your database and application work, but it's recommended that you set this parameter to at least 60% of available memory on your server. Next, we have the log files. The log files are necessary to restore your database from a crash. When restoring a database from a crash, the database reads through log files, and basically the bigger they are, the faster your database will get restored from a crash. So it's essentially recommended to put a quarter of the buffer pool value that you put here into the log file size value. The flush log at transaction commit variable controls the balance between ACID and faster query insert speeds, right? ACID, it means that basically your database remains integral. Your data remains integral despite any errors, power outages, or whatever, but this can be turned off. it can be turned off by setting the value of this variable by 0 or 2 instead of the default value 1, which makes your database ACID compliant. These 3 parameters are most likely everything you will need to optimize when working with InnoDB. These are the most important ones. Some of the other parameters exist, but these can be found in the documentation because there are so many, I will not be able to cover all of them. Aside from parameters, you will also need to deal with indexes in your database, right? Indexes are a very important thing in databases because indexes make select queries faster, which means that if the primary use case of your application is a read use case, which means that if the primary use case is a search engine or something like that, you will probably gonna need to make use of indexing or partitioning or both. We're gonna cover this in a second. Right, so how do you decide when and what to index? This is the most important question probably that all of you are gonna have. And the answers to this are very, very simple. You basically index select operations on bigger data sets. You index columns that you run select operations on, because columns are the things that are going to be used by a query. And that answers the second question as well. You need to index necessary columns by the time you are running select operations on bigger data sets. Bigger data sets with indexes will make select queries faster at the expense of making updates, deletes, and inserts slower, because data has to be inserted, updated, or deleted together with the index as well. And this is why the index takes up space on the disk, because it's a separate data structure as well. Right, so Google Slides doesn't show the structure of the indexes here, but what this slide is supposed to depict is basically here you'd have your SQL query, and here your database would essentially consider your index, what kind of the index it has to use, and whether it is a covering index or not. Covering index means that your database can read data straight from the index instead of reading the data from the disk, instead of accessing the disk. And here basically it denotes a couple of steps your database takes that makes it decide what index to use, what index is best to use, because if your query is selecting 2 columns or all columns after the where clause, your database has to make a couple of decisions which are depicted here to choose a proper index. Now, Google Slides unfortunately doesn't show everything that is supposed to be depicted here, but think of this as your database deciding what kind of index it should use. The kind of index your database should use can be accessed by running an explain query in front of any of your database queries. So if you run select queries, you just put explain in front of the select query, and your database will explain all of those steps that it takes to reach to choose the perfect index it should use. If it does not choose the index that you want to use, you would have to modify the query. The rules here are very simple. Your database will choose the index based on what clauses, what columns are selected after the where clause. So if your query is select ID from users where email equals something, the index that will be considered for use will be on the email column. So this is how you should think about that. Indexes actually deserve a book of their own, so I'm not going to get too much in depth about them, but this is how they are. Next thing that you should keep in mind is your backups and your backup internals. The way you probably backup data by now is by taking logical backups like this. What this depicts is probably, letters are very small, but what this depicts is creation of table, which with the structure of table as it is, and then inserting the data into the table using insert statements, as you can probably a little bit see right here. So what this does is basically, this is called a logical backup. And why is this called a logical backup? Is because your database backs up logical SQL statements, that is SQL statements that recreate the data, which is what is being done here. But if you have a lot of data, you would probably think or see that these types of queries are a little bit slow. And these types of queries are a little bit slow because each insert query that you see here, this is one insert query because it's in bulk, but it still be rather slow because you have a lot of data to insert. As you can see, you have multiple rows. And each of those rows that are inserted, each insert statement comes with a little bit of overhead. So this is what each insert statement does. So it has to start, it has to check for permissions, it has to open tables, initialize, update data, end the query, close tables, free items, and clean up. And you can understand if you have data with, let's say, 1 billion rows, that means that these steps that you see here, these steps that take milliseconds right now to insert one row, it will be multiplied by 1 billion. And this is why people wait weeks for queries to complete, because each query takes this duration right here of time to complete. And if you have 1 million or 100 million or 1 billion rows to add, it naturally, your database naturally multiplies this duration by the rows you need to add. This is a very simple explanation. How do you overcome this? People overcome this essentially by importing or using the backups without overhead. And backups without overhead, it means that essentially they back up raw data. So instead of, as you can see, backing up statements that recreate data, as you can see, create table, insert into, blah, 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 they just back up raw data sets, which means that they have data from one column, second column, third column, fourth column, and whatever. And it's usually separated by some kind of character, as you can see here. Sometimes it's a dot, sometimes it's a comma, sometimes it's a different character, as you can see here, and all kinds of data can be separated like this. The reason why you back up data like this is because importing raw data, it usually comes with thousands of times less overhead than importing logical backups like these. Now, how do you come up with data like this, and how do you import data like this? So this is where it comes for you to, I need to take backups like this. So essentially, you would have a loop that runs queries like this one that you see on the screen. It means select the data you need from some table into an out file called something file name, and then a bunch of options. What this does, basically, it tells the database that it should select all data from some table, where basically you specify whatever clauses you need into a file called the file that you specify here. And the fields terminated by something makes it so your fields are terminated by some character, as you can see here. Like this character, this right now. So there's a bunch of other options that you can use. You can ignore lines, you can specify lines starting by something, or you can basically only select specific columns. These kinds of backups can be restored like this by specifying load data in file and then your file location, basically, into table, that your table name. And this is basically everything you need to do. These kinds of queries, these two queries that you saw right here, one of them will actually select data from your table into a file, and the second one will actually load the data inside of a file into a database without any overhead, because they will not come with logical statements that the database has to repeat. It will only come with raw data like this. Not logical statements like these, but raw data like this. And this means by the time your database completes, inserts like 1,000 queries, 1,000 rows with queries like this, you would insert, let's say, 10 million queries like this. And you can obviously see by the time your about to use such queries, load the data in file, it will be sometimes even thousands of times faster than usual insert statements, because again, it doesn't have any overhead. I suggest you to refer to the documentation if you're going to use this, because it probably seems a little bit scary by the way it's written here, but these are the pretty much all of the available options that you can use. And aside from backups, you also need to adhere to some sort of bugs in the future, right? It's likely that you will come across bug or two because MySQL is such a database management system where in some areas something is broken. So for example, here you can see two queries. The text is a little bit broken because it's Google Slides, but you can see the main idea anyway. So the first query is like this: select all from table where match column against demo, where demo is the user's input. And the second query is select all from table where match column against something that has an eta sign in Boolean mode. And in this case, the eta sign would crash the database if your database is running MySQL 5.7. The reason why this happens is because your query decides to take a different path when executing. Why this happens, why does it take a different path, no one can explain. This is a bug within MySQL. This is actually a real bug that I've uncovered with the assistance of Charles Bell, which has led the MySQL's replication team in the past. But this is how it works. You are likely to encounter such bugs if you work with bigger data sets or if you dig deeper into MySQL. So this is kind of everything I needed to share. I hope that this talk has been insightful, even though I had to repeat myself and kind of redo my talk a little bit. But I hope that you have enjoyed, and I'm now available to answer all of the questions that you may have. You can feel free to email me, contact me, or use any of my websites, Database Dive or Breach Directory, if you want to see if you're exposed in a data breach now or in the future. So thank you very much, and I hope you enjoyed, and I hope I'm on time as well because I had to repeat myself. So that's it.
I'm so sorry, Lucas. You had to repeat yourself. I should have noticed that your slides are not changing. For some reason, I thought that's how you wanted to present, right?
Yeah.
I'm
no
so
problem.
sorry for that. But you're on time. So we have still about 4 minutes to take a couple of questions. There's one coming from Rhea, right? If you could
Can I
answer
stop
that.
sharing my screen so you can see me instead?
Oh yeah, I mean we already see you anyway, so you can stop sharing it.
I'm available to answer any questions that anyone has. Okay.
All right.
I can see there's 3 comments right here.
Yeah.
Can
so there's
you
a comment that
elaborate on common bugs on MySQL related to big data and how to address them? This is a very good question, actually. Common bugs on MySQL related to big data, there are not that many, at least not that many that I can think of. The only kind of bug that I can think of would be like this that I shared. And there's just a couple of other bugs because there's not many use cases using MySQL on big data. So perhaps that's why. If you come across any bugs, you can feel free to contact the MySQL team at bugs@mysql.com, I think, or bugs.mysql.com, and they will actually help you. They respond very, very quickly. And the second question is, what techniques can optimize MySQL performance for handling billions of rows? Actually, the techniques that you can optimize performance, they don't differ between ordinary techniques and just techniques that can optimize performance on billions of rows. They're the same. So if you saw in the beginning of my talk, I shared a couple of parameters that I can repeat myself a little bit. So there is, if I can find right here. So parameters would be InnoDB buffer pool size, InnoDB log file size, and InnoDB flush log at transaction commit. These parameters are essentially applicable only to InnoDB, which is the primary storage engine within MySQL. But you will most likely not need to use other storage engines because this storage engine, as time went by, implemented a lot of things that have been available in other storage engines during earlier times. So to sum up, to handle billions of rows, you would need a dedicated server, and to optimize basically 3-4 parameters that I have shown you. That's buffer pool size, log file size, and flush log at transaction commit. In essence,
Perfect.
that's it.
Yeah, well answered. You're not stopping at all. You're going one question after the other. So I'll give you the final one that we have. That's
Yeah,
by
Sophia
Sophia.
asks, how does MySQL handle partitioning, and what are the best practices for its use with massive data sets? This is also a very good question, and I'm very glad someone asks this. So MySQL handles partitioning depending on what storage engine, first of all, you'll find yourself using. There's a couple of partitioning methods, let's so say like that you can use. You can partition by list, you can partition by columns, you can partition by range, and there's another partitioning method that I probably forgot, but there's partitioning by hash. So in essence, partitioning by hash, it splits all partitioning methods, they split your table into a couple of, let's say, invisible tables that are visible to the database, but not to you. And this is why your queries on these partitions, on tables running the partitions, are faster. But in essence, each partition comes also with a file that occupies data on the disk. So you would need to, the first thing you need to do is you realize what kind of method of partitioning you need to use. In my use case, I use partitioning by range because for data breach search engines, that works out very nicely. Because partitioning by range, it takes a couple of partitioning parameters that are automatically increasing. So you can put, for example, from A to Z that you have 27 or 28 partitions with data split evenly across those partitions or almost evenly. So even if you have 1 billion rows on a table, it will be most likely split into 20, 25 different parts, and these parts will be significantly smaller. And so for an SQL query to run on the table, it will still complete faster because it will actually scan through those partitions. So in essence, I would recommend you to, for me not to take up too much time, I would recommend you to refer to the documentation and to the MySQL documentation and to the types of partitioning if you want to use partitioning as well. If you want to see partitioning in use, I would recommend you to use my data breach search engine. You can actually kill two birds with one stone like that. You can see partitions in use and you can protect yourself from data breaches on the web. So it's available on breachdirectory.com. And so that's that. I hope you enjoyed.
Yeah, I think Lucas, the more you stay, the questions will keep on pouring. But few comments like Deepak says, awesome, right? Freya says, thanks for answering you and your session, Rod. I think she missed the important word there. Well, thanks, Freya, for adding that asterisk. Then Sophia says, okay, thanks, Luke. So Lucas, that was great, Lucas. We are on time. It's time to move to the next session. And I'm asking one question to every speaker, and I'll ask you that, is that other than all this big data, MySQL, what are some of your hobbies? What do you do when you're not doing all this technical stuff?
I think it's very important to also work out, because when you work out in general, your mood actually lifts up and you can refresh your mind a little bit, aside from working on software, on databases and stuff. So I would recommend everyone on software that does a job on a computer from for a long periods of time to at least go some jogging or work out or something. I find that it helps me a lot and it helps my mood a lot as well. So I do that.
Right. That's a great thing to do. I work out too, so I can relate to that. So thank you so much, Lucas, for accepting the invitation. Lovely hosting you. Great session, right? Great comments coming from the audience too. I'll let you carry on with your evening. Go and grab some beer. I know it's weekday, but anyway, no problem. And let's stay connected and see you soon.
Thank you. Great speaking here.
Bye-bye.
Bye.
All right, ladies and gentlemen, that was Lucas for you, telling you all about Big Data MySQL. And now we move to our third final session of the day. I cannot believe this is day 2 and we're almost ending it. We're almost there. We're streaming from last 6 hours and 20 minutes, and I cannot wait to bring the next speaker on the stage, right? I don't know his session. Should I skip the first word of his session, or should I skip the last word of the session? But So I'm going to end up saying the next session is by Nick. He's going to talk about KISS, not the one that you've been thinking. It's about keep it simple, stupid. So ladies and gentlemen, without any further ado, let's bring Nick to the Software Architecture Conference 2024. Hi, Nick, and welcome to the Software Architecture Conference.
Hello, how are you?
I'm doing great today. How are you?
Doing wonderful.
Yeah, I saw some of your very old pictures, and my teammate picked up, right, some of your fancy pictures from the conference. Looks so cool.
Yeah.
All right, Nick, right, we're going to do a lot of chit-chat towards the end of the session, so I won't take much of your time now. Please feel free to go ahead and share screen, and then you can get started.
Sure.
And everyone's watching, you can use the comments section to ask Nick any questions. At the end of the session, we'll take some of the questions. And we have 5 minutes after every session to take that. I see your screen.
I'm in slide share mode. Can you see it full screen or no?
I see what I will prove today. Right.
Okay. Yep.
All right.
So,
next
35 all right, now I'm on keep it simple. Are we on first slide then?
Yeah, your first slides, and next 35 minutes is all yours.
Great. All right. So my talk is keep it simple, stupid. This is really meta when it comes to development, because this is really the process around how you develop, how you start a project from point zero and get it to the end. And it's really about designing code for maintainability and collaboration. Very rarely are we the only developer who ever works on something. And especially if you work for a large organization, a lot of times the code you're working on was not necessarily written by you and will be maintained and written by people beyond. So all of these things, go into all of that. So what I'm going to prove today is that you're paid to solve problems and not write code. I feel like this is common wisdom if you've been around for a while. But it really bears repeating. And I think there's some things that once we start getting coding, we kind of miss on that. Another one is for every 1 hour spent planning, you save 10 hours of execution. Now that sounds crazy, but as I'll talk about a little bit later and show in examples, you cannot overplan, and you truly can cut development times almost in half by just spending more time planning. And the last one is less is more. So a bit about myself. I've been in software development for over 25 years. I have programmed in almost every language professionally. I've touched a whole bunch of languages just for fun. I've spent 5 years plus on the W3C digital publishing group, so I have experience in standards. I've worked for startups, mid-sized companies, and large-sized companies, and through the years have been part of and designed and developed over 10 applications from the idea phase to reality. So not just coming in and maintaining projects. I've been part of 4 major large-scale rewrites. I, through much of my career, have been a project firefighter, which basically is whenever a project is failing, I get thrown into it to try and fix it. So I have come into a lot of messes, and through that, I've learned kind of how to clean up and how to prevent those messes. So that's really what I'm trying to get out to you. And I am a hands-on development manager, a coach, and a speaker. Now, a little bit more about me. I am not a 10x programmer. My code is simple. My code is elegant, and it works. But I have met a few people that we call those 10x programmers. That's not me. I'm just kind of some regular average guy who's just spent a lot of time doing this sort of stuff. I've over-engineered at least 50% of my projects, so I've made enough mistakes that I can now talk about them and hopefully help other people prevent them. I've accidentally dropped a table in prod, so if you've done that, then you are in good company. I've written poor commit messages. I have edited code directly in prod, and I've spent hours trying to optimize something that wasn't even a performance issue. So, I've seen the highs and I've seen the lows. So this should be very familiar to people. This is kind of that 1 year project. You can squeeze it if you want to make it a 6 year, but when you're working for a mid to large size company, you'll see this. And usually it starts with the business giving you a set of requirements. We need an application that does X, Y, Z, A, B, C, whatever. And they hand it to the development team. And at that point, the development team has about 1 month for planning. And then they have to start showing something. So it's off to the races. You develop for 10 months, and then you've got 1 month for QA and user acceptance testing, and then you launch. And this is just generally accepted. Oh, it's going to take 12 months. What I have found is that if you plan, then you can make it an 8-month project. So what would have been 12 months is now 8 months. And that 8 months can often even start earlier. And really, because planning happens as part of requirements, and it's really about a meshing of the business and the technology side at the same time. So what goes into the planning phase? The first is understanding the requirements. Too many times the requirements are just kind of handed over. And like, I mean, for anyone who's old enough to remember the waterfall model and getting, their BRD documents and just these massive 50-page things, as much as it was great to get specifications, a lot of times developers, the ones writing the code, didn't understand what problem they were trying to solve. So you would get people who would spend time developing something that needed to be reworked. So really, day one is just being part of the business, talking with the business to understand the requirements. The second one, and this is important, evaluate many code framework options. Oftentimes, what people say, well, I've laid code, I've started writing code, I'm just going to go. So you pick React as a front-end framework and you run with it. You pick, Tailwind, you pick whatever. And at the end of the day, every framework has positives and every framework has negatives. And you need to understand what framework will suit your full needs best. And the only way to do that is to evaluate more than one. So if you're spinning up a React project, you should also be spinning up a Next project, maybe spin up a Vue project. Your developers, during the time where requirements are being gathered, should be playing with different frameworks, trying to understand in a bigger picture what's the right solution and what's the right framework. Having dialogue with your stakeholders. So the technology team needs to be a stakeholder. They need to have investment in the success of the application, but they also need to be available early on and part of that discussion. Now, this is what's called this is also known as the expert trap. So how many times have we been asked a question and the first option we come up with all of a sudden becomes the best option and the only solution, and we run with that? It's like, hey, we need a database. MySQL. Let's just go with MySQL. So, all of a sudden now we're using MySQL, but we didn't stop and say, do we need a SQL database? Do we actually need a vector database? Do we need something that's more NoSQL? Do we need... So just because we have an option that sounds good, don't stop and actually spend more time determining if that answer is the right answer or the best answer, because there's multiple right answers. And the last thing that happens should be planning should be out-of-the-box solutions. As coders, we like to solve problems with code. There's a phrase I use often: when all you have is a hammer, everything looks like a nail. And if you try and nail a screw into a piece of wood, it doesn't work very well. It works. You can get the screw in there. Trust me. As a failed carpenter, I can tell you can do it. But so much development time can be saved by buying software. And I know sometimes like the business, like I'll be in a situation where I'll say, there's a piece of software that'll cost us $1,000. And they'll go, whoa, that's crazy. And I'm like, our developers cost more than $1,000 a week. So what I'm saying here is you can spend a whole month developing something, or we can buy it for $1,000. And all of a sudden it's like, well, yeah, okay, that's a whole lot cheaper. So out of the box solutions, if they work, are a huge way to save time and money. And then understanding roughly what you're expecting now, tomorrow, and what requirements are your wish list items. All right, you are not paid to code. You are paid to solve problems. So I'm going to repeat that. If the technology group, if you're expected to solve a content management system, you are not paid to write thousands of lines of code. You're paid to solve the content management system. So if WordPress solves your needs, you are of more value choosing WordPress and maintaining that than you are writing your own content management system, assuming that works. All right, 90% of apps are over-engineered. If you ever work on an app that you feel like, you know what, this is right-sized, it's perfect, there's nothing in here that's unnecessary, I'd be surprised. It shocks me that, I mean, any front-end application that uses React uses a bunch of different node modules, and then you add it all up and it's 600 megabytes for a 2-page application. It's over-engineered. When you over-engineer code, you frustrate yourself. You distract future you from solving new problems. You increase the difficulty of new development for future you. And you're embarrassing future you when you have to explain why you have to rewrite code that you wrote in the past. So love yourself, current you, and future you. All right, so what are the phases of development? So when I think of projects, I mean, they really break down into three main parts of a life cycle. The first is the proof of concept. So if you work in a startup, pretty much everything you're doing is proof of concept. And a proof of concept is a great way to show that something works. So a lot of people are building proof of concepts on top of things like OpenAI. It's like, all right, I have something, it throws a prompt in there, gets the response, and displays it. And it's a great proof of concept, but it doesn't scale. It often, can't go beyond what ChatGPT can do. And you really, there's limitations. So proof of concept is usually small, limited in scope. It does one thing, it does it really well, and it's just meant to see, is this worth developing more? Where I see a lot of businesses make bad decisions is then they go into phase 2, which is boil the ocean. And that's when you take a proof of concept and you try and blow it up. So it's like, okay, great, this does A, but we want B, C, D, and E. And while we're at it, it's got to do F and G. It's got to handle 1 million concurrent users. It's got to have this and this and this. And this is, ChatGPT is new, so it's got to integrate ChatGPT. And it also has to have its own chatbot, but then it's got to, and your requirements get out of control, and all of that happens. And oftentimes, especially if your proof of concept is good, that actually gets approved. And you have this crazy idea, and then the reality sets in of how much work it's going to be once you've got a few launches, behind you. And then you wait, we have a code base that's unattainable. It's just a mess. It's spaghetti. So we have to do it all over again. And then you go into phase 3, which is actually what your customer wants. And in most cases, that's a limited feature set, limited requirements, and hopefully a simple enough architecture that you can keep going. So by planning, the idea is to skip phase 2 altogether and go right from proof of concept into what your customer wants. All right, so some stories. So a startup that I worked at several years ago, 15-ish years ago. So we started with a proof of concept. We took a pre-built software. It was, I think, roughly $500 template, and it was a DVD rental service. So we were going to be a book rental service. So we were kind of like Netflix, but for books. And the DVD rental, it worked reasonably well. We were able to, make it work with ISBNs as opposed to, the EANs on a DVD. We were able to get it with work with book data. So ultimately, we saved a whole bunch of time because we used something that existed. It took one developer and 2 interns about 3 months to customize this and launch this. So for a proof of concept, that was really solid. But we had performance issues. We couldn't grow. We couldn't extend it. There was some security concerns. So at the end of the day, as a proof of concept, it was great, but we had to rewrite it. So when we rewrote it, there was a fancy new PHP framework that had just come out. So we decided to apply that because the lead designer at the time, wanted to do the bleeding edge of everything. We also tried to do warehouse management, inventory management, purchasing system. We tried to do everything. So really, we entered boil the ocean. The project was good, but it got over-engineered. And we very quickly found that PHP framework ended up biting us in the butt. It was not new enough, or it was not out long enough for it to kind of get through its issues. It was going to take too long to report every bug. It wasn't right. And about a year in, 9 months in, we had to rewrite it from scratch. And this time we just wrote it in straight PHP. We wrote a very small, lightweight framework on top of it that we wrote in-house that is super simple. An intern could learn it in a day or two. And it made our development simple. And we did manage to get warehouse and inventory management in, and we got a few other things, but we did it on a much smaller scale because we weren't Netflix. And it took a little longer to develop, but we had a much more robust system that the reality was it actually ran itself. It handled customer service almost completely automatically. It handled purchasing almost completely automatically. So we were able to take 12 workers and bring it down to 7. So it, just really was all about planning in that stage. So I talked about what we learned. So the frameworks were just not there. You have to really design for what you need. Oftentimes we get so excited, we want to do everything, we want to boil the ocean, and you really gotta slim that down. We cut a lot of corners in the beginning, and every corner we cut bit us. And I'm just going to keep reiterating: plan, plan, plan. All right, so to answer hopefully a question that might be in your mind, where do developers and requirements sit? When you work for a startup and you've got 8 people in the company, you're all talking to each other. You all know what's going on. You're probably kind of already part of that. If you're a one-person team, you're everything. This isn't for you. When you work for a mid or large size company, there can be a business side and a tech side that don't talk to each other very well. The business side sends requirements, tech side writes the software. So what I have found works really well is you have to break those silos down. You have to bring the tech side over to the business, and you have to make sure they understand the KPIs. KPI is a key performance indicator. So let's say you're an e-commerce website. Your conversion rate, your add to cart rate is going to be a key performance indicator. Your checkout completion rate, so from add to cart to checkout. So there's going to be certain items that are going to be really important. And knowing what those are will help you as a developer, because if you know you need to make something easier, then when you're developing, you're going to think, does this make it easier? Because sometimes requirements get confusing. You have to know who your personas are. You have to know who is using your site. What is their motivations? What do they want out of your site? And are you delivering that? You may not be a design expert and know if a green button or a blue button or a red button is going to be more successful. But if you know that your target audience is over the age of 60 and you're using 8-point font, you should know that that is not going to work. And as I was saying, developers must be key stakeholders. The developers need to be part of the requirements process, even if it's just to talk through what possible solutions are. And I think what's critical there is oftentimes the business will want, let's say, 3 features. So let's say a search engine. So we want a search engine, and let's say, so I work in the book world. We want a search engine. We want to be able to search on title. We want to be able to search on author, and we want to be able to search on themes. So you talk through this and you're like, well, title's super easy because we have the data, it exists. Authors, super easy. We have that data, we can do it. Themes, I don't know what you mean by a theme. And so now you can have a discussion and you can talk to the business about what data does exist, what data doesn't exist, how much time it will take. Because if you're there early in the process, you have a chance to say, well, title author is easy. It'll take us less than a week. Theme is going to be hard. It's going to take us a month. And the business can say, you know what? You're right. Theme is not worth 1 month of effort. So you've cut an entire month off of your dev timeline because you had a single conversation. Or the conversation could go, here's the data we do have. So instead of theme, can we change it to keywords? And they're like, yeah, keywords is great. So you're having that discussion up front, as opposed to once the business has committed and like, here's our timeline, here's what we want. And then you come back and say, well, it's going to take a month and 2 weeks, and it's just, so you're extending your timeline when it may not be necessary. All right, so another project that I've went on that had a similar type process was phase A was proof of concept. It was a single developer. This was a startup that I had, and every day was a new requirement. So every day was just heaping on more and more and more code. We got through 2 years of development. It got us through our 2 rounds of funding. It got us to acquisition. But I'm proud of what the code did, but I'm not proud of the code. The code was a mess. I like to say it was held together with duct tape and safety pins. It was not scalable, but it did what it was supposed to do. So once we got acquired, they had a really tight deadline to try and get us to a certain revenue number. So instead of saying, well, now you have this proof of concept that we need to throw away and rewrite, they said, you have to just keep adding on to it. And you have to get all of the legal requirements, all of everything else that we had neglected. So we just kept building and it became a behemoth. So the boil the ocean stage was just slapping on code after code after code. And it became unmaintainable. And we were hitting lots of performance issues because scalability wasn't in mind. It hit that point where we had to rewrite everything. Now, there was a lot of decisions made in that rewrite that I bring this up because I think it's a great learning lesson. So we decided to go and try and be leaders and go into a microservices architecture. So the design here and where we failed to plan enough was we said, we're going to take this one service and we're going to break it into 15 smaller services so that anyone else in the company, this is a large company of over $1 billion a year in revenue. So everyone can use every little piece. So if anyone wants book data, they've got it. If anyone wants this, they've got it. If anyone wants this. So we designed with that in mind. And the reality was no one in the company used any of the microservices. And it was because the corporate culture was not that anyone would use a microservice. Like we weren't Amazon back in the early 2000s saying everything's a microservice. You have to do this. It was us in a little project thinking too big, and again, trying to boil the ocean. And when you talk about maintainability, each service had its own repository. So we now had 19 total repositories. It was confusing. Now the code itself is kind of nice, but we tried to do too much, and it cost us. We could have saved 2 to 3 months had we just not done that. So I talked about this. Microservices is a large-scale organization decision. If you're told to do something in microservices, just ask, like, why? Like, does this need to be a microservice? Microservices are great. And if someone's going to use them as such, awesome. But otherwise, decoupling all your code, so you have to have projects that reference, you have to have maybe a NuGet package with all your object models. And it's just, it's excessive if you don't need it. We did test-driven development. That worked really well. I wish we had tested it out a little bit more in the front. The other thing that was great to learn, because I've been doing this for 25 years, is high-quality code is almost infinitely scalable. So I come from the days where you can have a script that, like, a single server can only run a few hundred copies of it at a time. So you need to have replication, and so every CPU cycle mattered. In today's world of cloud computing, it almost doesn't matter. Like, we set up this microservices to be able to scale up to 50 instances, and we would have 2 was our maximum we ever hit, and we were supporting 200,000 to 300,000 users a day. So it was like performance was never an issue. Also, if you work for a large or medium-sized company, security and compliance needs to be part of your requirements and planning. The amount of time we spent getting 3/4 of the way through something and legal would come in and tell us it had to work differently. Again, plan. All right, for every 1 hour spent planning, you save 10 hours of development. I started out as a developer, and I'm going to speak for myself, but I know I'm not alone. I love to kind of dive in and code. I love to see success early. I love to see things move. And planning is hard for me. Like, I have to tell myself, stop and plan. But that said, and I spend more time planning. When you think you're done planning, plan some more. And organizationally, it can be hard because it's like, you've spent 2 weeks. What have you done? And it's like, I wrote 2 pages in a planning document. It doesn't sound like a lot. But if it's like, I've evaluated 4 different frameworks, I've thought about our data model and tweaked it 1,700 times because I found this one thing, and those things are going to save you months of effort. So plan. I have one more project that I kind of want to talk a little bit about, but I think I'll come back to that if I have time. 90% of apps are over-engineered. So I'm going to say this, again, this is not a duplicate, showing again for effort. I have not seen enough planning, and especially the planning where the business and the tech side are really engaging early on. You'll save so much time down the road by planning and not over-engineering. All right. And again, you are paid to solve problems, not to write code. If you are asked to build an e-commerce website because you want to sell handmade crafts, if you're not using Shopify or Etsy, you're making a bad financial decision. With a little asterisk there, yes, if you have some crazy new technique or something else going on, fine. The cost that Etsy or Shopify is going to take from your transaction is not anywhere close to the cost of developing, maintaining, and dealing with all the other hassles. So as a technologist, as a technology manager, it's your job to understand what's the problem you're trying to solve and how can you solve it? Not necessarily how can you solve it with code. All right, so design is for tomorrow and not 10 years from now, especially with how fast AI is moving, with how fast cloud computing is moving. If you're designing a solution that's going to work for 10 years, it's probably not. And one of the previous presentations showed a wonderful quote about being fluid. And the reality is technology is changing a lot, and the best thing you can be is nimble and small and fluid so that you can adapt to whatever is coming up. So the build versus buy, if you have to buy a new piece of software every year, it's probably still cheaper than hiring a developer to maintain and update a piece of software. The middle point has been called out to me is really important. Developers are expensive, infrastructure is cheap. So what that kind of means is that so this goes back to build versus buy. If there's a solution out there that costs $250, that's, in many cases, less than a developer's day's worth of effort. Chances are a $250 piece of software is going to take a lot more than a day to manage or maintain. So, where possible, buy things that are pre-made. Also with infrastructure, optimizing a database so that you only need one instance of a database versus two, because you don't want replication or things like that. You can replicate a database for $250, $500 a month in the cloud. A developer costs a lot more than that. So spending a month trying to optimize code is usually not worth it when you can just throw hardware at it. Also, easy to read code over performance, because a senior developer who writes code that only a senior developer can edit is going to cost you time when that senior developer is gone and you have a mid or a junior spending a month trying to figure out what that code did. So that's where the simplification process comes in. That's where planning comes in, because the amount of times I've seen a project where they chose some esoteric package or esoteric framework that some senior developer who probably contributed to that framework did and chose, and it may be elegant, it may be quick, it may be super performant, but you can't get other developers to work in that environment. So it's short-term decisions that hurt the long term. The last point here is momentum is hard to break. If you get a developer, group of developers who start working in React, they're not going to want to change. They're not going to want to go to Angular. So once you kind of commit to something, it's very hard to get people to want to redo the same work they've done in something else. So that's where in that planning and requirements, it's really important to give your developers like a set deadline. Hey, you've got 1 week. Install Vue, install React, install Angular, and then you tell me which one you think is best. And then you evaluate and make your decision, things like that. Bad decisions are made with good intentions. No one on the business side wants to hurt developers. So when they make a request, they're not doing it thinking, oh, this is going to be hard for the developers, or this is going to make someone's life difficult. They're just thinking, this is what we want. And oftentimes, again, choosing like a front-end framework, you'll decide, well, let's go with React because I have 2 React developers right now. If you need SEO, you need to go with Next, which, yes, is sort of React, but you need to make sure that you're making the decisions correctly. Even though you might have good intentions, you still might make bad decisions. All right, so let's go back to the planning phase, because this is really where I think, this is what I think is the meat and potatoes. So understand the requirements. Obviously, the earlier you can be part of that process, the better. But really what it comes down to is making sure that every developer who's writing code understands why they're doing what they're doing and what the requirements really mean. Evaluate many code framework options if you even need a framework. Don't stop at the first one. And the first good answer is not always the best answer. Have dialogue with your stakeholders, constantly be talking. If you have a big development team, let's say you have 15 developers, 1 or 2 dev managers, and then a director, make sure that the director understands everything. And the director then communicates to the manager, make sure the managers understand things, and the managers can make sure the developers understand things. But everyone has to understand that. Again, the best option is not always the first one. Good option is good, best option is best. And research out-of-the-box solutions. Again, you are not paid to write code, you are paid to solve problems. Understand the current, future, and wish list. I will also differentiate here where I didn't before. So the current requirements is what you need today. So if you were developing PayPal, it's like the current requirements is people need to be able to transfer money to other people. Great. Future requirement might be we need to support contactless payment. So we need to do all the taps. A wish list requirement might be we want biometric protections. So understanding that it's like, okay, that's a big one. We need to keep an eye out and we need to be aware of it, but it's not something we need to design a whole system to be able to work with it because it might be too big, it might be out of scope. We might not have the technology available today to be able to do it in a reasonable way. All right, so the key takeaways, repeat, repeat, repeat. You are paid to solve problems, not to write code. For every 1 hour you spend planning, you save 10 hours of execution, and less is more. So unless you have the weird job where you're paid per line of code, writing less code that solves the problem still is going to be more valuable to yourself and the other people on your team. And you should work towards that. All right, so thank you. I think we have some time for questions. If not, I will go back to my other story.
That was lovely, Nick. We've had many sessions around, when people share about their experience and, what they have planned. But your presentation was very different. No code comparison. This is what the code I wrote, and this is what it got better. But all the learnings that you have had from so many projects, and I like that you kept it very basic. Didn't bring any fancy, project or something like that. Great. I really loved it, and I think from every single slide. There's so much to learn. I personally loved it, and I'm sure everyone in the audience loved it too. We have few minutes. We can take maybe a couple of questions.
Mm-hmm.
Let's take one coming from Freya. I think in one of the slides you did say that the high quality code, it goes right long way. So she's asking, how do you measure that the code is of the high quality?
Okay. So I don't think you can measure that, but the way I call high quality code is, can it be read? So if you can look at a piece of code and know what it does without comments, then it's high quality code. There are some situations where you need to write code that is not readable. So a good example of that is regular expressions.
Yeah.
It is almost impossible to write a regular expression that someone can just look at and read. And in those cases, you need a comment, and the comment should explain, this is validating an email address, which should be clear by the function name, but then it'll say, we're looking for any character that is not a this and that, and just explaining it so that at least if there is a bug, you know what the intentions were, and you can say the code didn't do that. But if you're just kind of scanning the code, you can say, this is what I expect that next line to do. So like tertiary statements or trinary statements, I try to avoid them as much as possible, unless they're really well formatted. because it saves you a line or two of code, but they're, especially if it's a single line, you're like, this condition, then we have this. And when you nest them, oh my gosh, there's nothing in a code review. If you nest ternary statements, I'm like, no, this is just, because this is not readable. You can't debug it. The next person coming in is not going to touch it. It might be small, but it's not quality code.
Yeah, but for some reason people really love it, I don't know why. I don't
It's
like
an
it at all, to
efficiency
be
thing.
honest. Yeah.
It looks nice. Like when you see
make them look
6
cool.
lines of codes versus 16, it looks nice.
Yeah, that I think that's very well answered. Let's take another one from Sophia. She's asking, how do you balance simplicity with the need of robust feature and functionality in a software design?
I don't think they conflict. I actually, you can get a huge amount of functionality with simplicity. So recently I've changed my tune on EF core. So in the past, entity framework has been something I've avoided, mainly because it was kind of early on in development. It was kind of buggy. I prefer more direct, close access to the database. So something along the lines like a Dapper, where you're writing your SQL, you have more control over it. That was more valuable to me. But in one of the current applications I'm working on, we went completely to EF core. I think we're on 8 now, but it has allowed for a lot of simplicity. Now there is a little bit of trust that when you have crazy complex queries, that it's just going to do what you want it to do. That I don't necessarily love on a simplicity sake, but with Link and EF core, we have very readable code. We have a lot of simplicity, and we can still get a lot of robust features with just a little bit of extra code.
Yeah.
So I don't think those are at odds. I think simplicity doesn't mean you're not doing complex work. It just means you're doing it in a way that is step 1, step 2, step 3, not the black box of ChatGPT, where it's like I send a prompt, it gives me something out, and I'm parsing it for functions. Like, that's not simplicity.
Yeah, that's good. That's good. I think the questions will keep on coming after, but I know we are already 3 minutes in the other sessions. We're gonna take one more question and then we'll move on. Aftab is asking, how is the benchmark for skill quality benchmarks changing with time?
So I think one of the difficulties I'm seeing when it comes to skill quality is people are living at a higher level in the framework. So you'll find someone who can only work in React. So they came out of a boot camp, they can copy and paste a hook, they can do the HTML portion of it, but they don't understand how HTML works. They don't understand how CSS works in a completely blank canvas. And JavaScript itself, they don't know the difference between what is core JavaScript, what is React, and the only solutions they tend to know at first is include a node package and then use that package and pass the parameters. And it's a great place to start. But I think as we develop more frameworks and more complexity, I think people are losing those core basics. And, I think JavaScript, even C#, you should just know what is core C#. What is really added by adding ASP.NET? What is added by .NET Core? Because when you get to that first issue that is complex and you can't figure it out, you don't even know where to start debugging because you're not sure where to even begin. So I would say the benchmarks are shifting because we're getting higher and higher level coding that makes things easier to get started, but it makes it harder to do simple things.
Wow, I think it's a very good answer, and I can relate to it. The people come for internship, they know how to work on React, but when it's time for debugging, as you said, they don't know vanilla JavaScript. They don't know, so they just do not know how to fix it. So that's a very good answer. I think people should work on their basics and just with C sharp instead of getting onto this, MVC framework or whatever, Blazor and all. People get into Blazor just straight away, like, oh, we'll work on Blazor, but they don't know C sharp. They know nothing, right? So that's a very good answer. Thank you, Nick. I really enjoyed it, and I'm sure everyone loved it. I'm repeating myself because it was a great session, very different. I already see someone saying this session was much needed. So thank you so much for doing it. Any final thing you want to plug before we move to the next session?
Thank you, Simon. If you want to learn more about what I do, you can just go to my website, nickruffalo.com. It's my name.com. Additionally, learn the basics. It's key, and it will always help.
All right. Thank you so much, Nick. Thank you so much for your time. Let's stay in touch. I know it's a work day, so I'll let you go and have a nice day ahead.
All right.
Thank you. Bye-bye. All right, ladies and gentlemen, that was Nick for you. A great session that talked all about his experience. We now move to the second final session of the day. I know I'm already a few minutes into his session, so I hope Abhay is very kind to me. Abhay is our next speaker. He's going to talk about scaling oil field production operations workflow using cloud computing. Ooh, like a real-time project coming in. Very excited. So without any further ado, let's bring our second final speaker of the day, Abhay. Hi, Abhi. How are you doing today?
I'm good. Hope you can hear me well.
Yeah, I can hear you well, and I can see the bright sunny day that you're having. Where are you joining us today from?
I'm joining you from Houston, US.
Oh, Texas. Yeah, howdy, man.
Oh, yeah. Howdy. Thanks for a very nice introduction. All that music and all. I really love it.
Yeah, thank you so much for accepting the invitation, Abhi. I know I'm only almost 7-8 minutes in your session, so please feel free to go ahead and share your screen, and then we can get started.
Yeah. So if you think it's too much bright, I can close my blind.
Yeah. Some shades, if you could bring it down, that would be nice. I mean, then people can look at you.
Is it better?
It's much better. Oh, yeah, it's far better.
Okay. All right.
Well, now we can see you.
Thank you. Thanks, everyone, for joining this session. Let me share my screen.
Yeah, and while you share it, I'll tell you that we have more than 482 people watching now.
Awesome. Thank you. Thank you, everyone, for giving your time and joining my session. I hope I am sharing something important. Let's see. Okay. Window. Let me share.
And everyone who's watching, please feel free to go ahead and drop your question in the comments as Abhay delivers. Abhay, I can see your slide. I've added it to the stream. Everybody else can see it. And next 35 minutes is all yours.
Okay. Thank you. Okay. All right. So I will start with my brief introduction first. So my name is Abhay Dattaroha. I'm working as a software team leader with Schlumberger. Short name is SLB. And today's topic is scaling oil field production operation using cloud computing. So I completely agree with the last presenter, and he focuses on the requirement and keep it simple. So yeah, that is also I follow in day-to-day life. I mean, I usually build solutions incrementally, not everything on single day. I mean, I start with something small, then keep iterating over it. So yeah, I completely agree with whatever he presented. Okay, so before going into the main topic, I would like to give a brief introduction about oil and gas business. So for the folks who don't know, so Schlumberger is world's number one company in upstream oil and gas services. So around the globe, there are mainly two kind of companies dealing with oil and gas business. The first part of company are basically oil and gas company who basically owns the oil well, and these oil well could be anywhere on earth or in offshore in middle of the sea. And second of the company which are basically operating in these oil and gas wells. So I'm from the second part. I'm working for the service provider. So Schlumberger is world's number one service provider. And what we do, we basically deals with upstream. So if you want to know what is upstream, so I'm showing on the screen. So the left-hand side that call upstream, the middle says midstream, and the right one says downstream. So what we do basically, so we basically involved in everything, whatever involves in drilling the oil well and extracting the oil from under the earth. And this oil well, as I said, it could be a middle of the sea, it could be on some desert or some remote area. So everything involved, including some tools and technologies and hardware and software, everything. So we provide all kind of technologies. And when I'm saying skill set, you will find petroleum engineers or geophysicists or petrophysicists, geologists, and software engineers, data scientists, machine learning engineers. So everyone working as a team. And our single goal is to optimize the oil production. So we want to apply all technologies together so that we can optimize the oil production. And as you can see on left hand side, I'm showing two pictures. One is the onshore pump jack. You will mostly see that rod is basically going up and down. It is basically drilling the oil well. And the other picture says, okay, someone using some helicopter and landing on that a pad location where there is some instruments are installed in middle of the sea, and they are basically producing the oil. And there are midstream companies. These companies are basically responsible for processing and storage. I mean, once the oil is produced, then someone should be there to transfer it. So these companies are mostly build the pipelines and transport and trucks. And the third kind of companies are downstream companies. So once this oil is already reached to the distribution center, so these companies are basically refining the oil, and after that they also deal with the sales and marketing. So today's topic is mostly on upstream and about a cloud-based solution what we built, and it basically helped to optimize oil production. So I would like to start with some terms like what is a digital oil field. So digital oil field is just a fancy name what we use. I mean, it's nothing new. It's there in the industry since last more than 25 years. But since last more than 10 years, everyone started talking about a cloud, and now we have ChatGPT and machine learning and data scientists. So digital term, I mean, people started correlating it with the cloud and machine learning and everything. But for us, the digital oil field is anything related to computer. So digital oil field, I mean, even before the cloud computing, it was there. But now we are using it more proactively, and it is related to using any digital technologies. It could be software or hardware or data analytics. And the end goal is to enhance the exploration, production, and management of these oil gas field. And the general operation involved, I mean, if we are collecting a lot of data from the sensors installed in this oil field, so basically artificial intelligence is involved and Internet of Things are also involved. So as you can see, the right-hand picture I generated from AI. So this picture is basically showing a typical oil field where several people are working, and you can also see some hardwares are installed, some computer screens are installed. They connect it to some satellites so that they can get the internet connection and everything. And they're always sending some data to the remote oil field operation. So today's topic is about the similar application which is installed and which is basically optimizing this digital oil field operation. So I would like to start with the challenges, the requirement, what we learned in the last session as well. So the challenges and requirement for production operation means because this operation is highly complex. It basically involves many people from different business roles and from different geographies, and different workflows are always applied. So these problems are typically solved using a diverse or disconnected set of software application and tools. And before introducing the cloud computing part, we were still doing this operation, but at less scale. And so the main challenge with the application, the existing application was, the collection of data was not easy. And to make this data available for running a scalable workflow, that was not straightforward, because our data was scattered and there was so many on-prem desktop-based application was running and collecting, so it was not very much scalable. Second thing was in oil field, the data frequency could be very different. Few data could be second best data or maybe less than second best data. Few data could be monthly, yearly, weekly, or daily. And there are several conventions followed by different oil companies around the globe. So whenever we have some existing desktop based applications, then each application talks their own data standard. So whenever we are transferring data from one app to other, we always need to build some kind of connectors or adapters, so that one application understand what the other application is talking about. And it was very hard to maintain. It was not very much easily accessible and poor scalability, and it was leading to non-productive time and data quality issue as well. And at the end, it was giving some inconsistencies as well, because in this on-prem app, if there's a data became inconsistent, then I need to import that data again and connect it to the several application a couple of times. So that was not a good way to run these workflows. And other common complaint from customer was they always see a missing data or incomplete data. So they were missing a complete and consistent view of data always. So these are the challenge. So, okay, I talked enough about data, about frequencies and all, but I would like to give some context. How does that data look like? So on very high level, I would like to split the data into two kind of data. One is the time series data, other one is the structured data. When I'm saying time series data, so whenever we are drilling the oil well and we are putting a lot many tools inside the earth, so with that drilling pipeline, there are a lot many sensors installed, and these sensors are basically capturing a lot of data points from beneath the earth. These data points could be, in simple terms, a pressure or temperature or the gas flow rate or oil flow rate or water flow rate. And typically, this time series data looks like what I'm showing on the right hand side. The first one is, say, okay, there is an acquisition time which is associated with every data point. Let's say I'm showing that some value, let's say some oil production volume coming. So I'm showing 2.3. I'm assigning the unit of measurement as well, and I'm also assigning the kind of data. Is it double or string, so that my storage system or my workflows also understand it. I'm also assigning the source acquisition time. Source acquisition time means when I really see that data on my cloud. So agent acquisition time means the acquisition time when the on-prem tool, which is basically streaming that data point, and the source acquisition when I start seeing that data point on cloud. So there are typical key characteristics for this time series data, which is important for our workflows. So for example, let's say if I want to see a forecast of the oil production, so I'm basically interested in the trends and pattern, because I want to apply the time series analysis, which is basically a typical machine learning workflow. So it is only possible if your data is stored as in a time series manner. So time series means it always has some temporality associated with it. It's chronological order maintained. Then this data could be a periodic or sporadic. Periodic means when we have some defined frequency like daily, hourly, or minute based, or there are possible that there are some sporadic operation. For example, if there is some downtime activity in certain well, so this downtime activity is like a sporadic event. There is no fixed interval associated with it. The downtime started may now, it may finish maybe in an hour, or it may go for more than an hour also. Third type is why we want to see the time series data, because it has some pattern associated with it, and our workflows want to analyze these pattern. And there is always a seasonality associated with time series data, which involves pattern that repeat at the known interval. It could be daily, weekly, or yearly. So second type of data is basically structural data. So to explain this data, I would like to give you one example. Let's say if some oil and gas company has some oil well, let's say in Texas. In Texas, there is one city, Cameron. So you can think of it's like, okay, maybe in North America, that oil and gas company may have different oil wells in different geographical location. So they always start with the top route, that is basically a country. Then they will go to the state, or they may create a zone area as well. I mean, they can combine multiple geography. They can start calling it as a zone, and after that, they are basically reaching towards the geography where oil well is actually located. So they always identify it using latitude and longitude of oil well. So on the right hand side, I'm basically showing this kind of data, which is structural data. As you can see, this is a graph based structure. So on the center, you see a well is located, and there are three kind of branches coming out from that well. One is in orange color, one is in red color, yellow, and green. So these different branches are basically showing hierarchies where this well is attached. So well is obviously attached to some field where we are basically doing the drilling operation. That field is exist in some state. So that's why that one line shows, okay, this oil well exists in this state. Then there is another hierarchy, which is basically for petroleum engineers. If they want to know the reservoir and zone and completion. So completion is another concept. It is basically an area under the oil well from where oil actually produced. So that area is basically called completion. Then I'm showing other hierarchy as well. For example, if there are tools installed, so whenever oil is coming on the earth surface, then there are multiple tools installed. We call it pump and flow lines and separators. So that hierarchy basically shows, okay, this oil well tools are basically connected to these subsurface components on the earth. Then there are other hierarchy like events. As I said, if there's a downtime event or something else, they have their own hierarchy. So, and this structure is basically a graph based structure. So you can see what we want to store. Okay, the node ID itself, and the edges, and the started and ended. So all these entities in this system are connected by several hierarchies. And as I said, okay, the same entity could be attached to the multiple hierarchy as well. So the main challenge is, now we talked about the data, the time series data, and the structural data. So time series data could be very huge. It could be petabytes of data for more than 10 years or so. And for a structural, it is basically a graphical data. So our challenge is to create a scalable cloud storage so that we can store this massive data and this graph structural data. So how did we solve this? So our first problem was the data ingestion problem. So in the production operation, as I said, there are several sensors installed and there are several tools installed, and we have different kind of data sources as well. So there are typical data source, like if there is an on-prem or relational database that is called a production data management solution. There could be edge-based or IoT-based devices streaming data. There are mobile phone as well. I mean, someone is just capturing some data and preparing some report. There could be a physics-based model. If you guys don't know about the physics-based model, so for example, in any oil field, they install multi-phase flow meter. So the job of this multi-phase flow meter is like to check the liquid characteristic and the heat exchange rate, and what is the characteristic of the oil, gas, and water proportion whenever that raw oil coming from the earth. So we want to capture a different kind of data from the different kind of sources. So we definitely need a scalable data ingestion system. And data is really important because 80% of the time, any production engineer or petroleum engineer, they always keep looking at data because their workflows are basically data intensive. So to solve this problem, what we did, we created autonomous agents. So autonomous agent is a very famous term these days. We use it for creating machine learning models and LLM model also. But yeah, autonomous agent means any software process which is running continuously and acting on the events it receives. So for us, we always want some process to run closer to the data source and keep listening for the events, like if some new data point arrived, or if you want to fetch the data for more than 20 years, because there are few wells who are producing oil since last more than 100 years as well. So we want to fetch all this 100 years of data, and you can just imagine the scale. If some well producing a second base frequency data for 100 years, there could be billions of data points. So we want to push all these data points to our cloud storage. So we produce this agent. These agents, in simple term, you can think of it's like a Windows service running continuously. And whenever it receives some event from the on-prem data source, it is pushing those data points securely to the cloud storage. So each agent is basically associated with a unique agent ID, what we handle on cloud. And for security, if you want to secure the communication channel between the on-prem and cloud, so we use a cloud-based service account, so that whenever someone is installing those agents, that person is always using the encryption key coming from the cloud-based service account. Then that installer is basically decrypt that key, and after that we don't have any idea about that key because we are not storing anything. And whenever I'm communicating from on-prem to cloud using some messaging queue, that channel is also encrypted using same key. So it makes sure that we are not spoofing anything, and each agent is basically talking to the same messaging topic associated with its cloud service account. So this is for handling the data ingestion. So in this slide, I'm basically showing the typical life cycle of any agent. And right-hand side, I'm also showing one picture. So this picture is basically from the patent I filed. So this patent is already approved. So this is for showing the life cycle of the agent. So this basically shows any agent can send the time series and structural data, what I showed earlier. We are using the protobuf, the Google protobuf format for serializing and deserializing. We can always send the incremental data on daily basis or hourly basis or second base or historical. And this agent can also request some configuration at the startup on periodically or demand from cloud. And it always use some messaging or communication mechanism so that it can scale really well. It can also receive some commands from cloud. Okay, let's say someone wants to fetch the last 80 years of data. Then that person can basically use some APIs hosted on cloud, and it can start those jobs manually. And other challenge what we solve, okay, we need something to monitor. So we are using the same messaging pub-sub communication mechanism to send the logging and monitoring status as well. Those we call heartbeat. And we are monitoring those heartbeats on cloud. So we basically created some dashboard so that we always see, okay, our agent is up or not. Now, moving over to the agent lifecycle, the typical agent lifecycle start if someone register that agent on cloud using some set of API. So when agent is registered on cloud, then we basically associate it with some cloud service account. So we maintain the authentication and authorization part. And that cloud service account is also associated with some cloud pub-sub mechanism. So when I'm saying cloud pub-sub mechanism, so in Google Cloud, it's a cloud pub-sub, or in Azure, it is Azure Service Bus, and for AWS, it is SNS or SQS. And agent installation, like after registering the agent, I want to install it on the on-prem machine so that it is always attached to that particular data source. So I use the same cloud service account key, and after completing the installation, if it is a Windows server, it basically encrypts it using the Window Data Protection API. So as soon as agent start, it basically starts streaming data on cloud. Then the ingestion part, it is basically sending the oil production data from this oil field, and data is pushed using the same messaging, any types of mechanism. And yeah, we also can send commands from cloud to on-prem for if we want to fetch any historical data. So one important point was, let's say if there is some disaster happens on cloud, okay, so what is the best way to reduce the downtime, because I don't want our customer to wait. So in disaster scenario, the strategy we followed, we created a global cloud resource which is available in multi-zone. So whenever and also because we were using the cloud PubSub, so by default cloud PubSub has the message storage for more than 7 days. So even if some service is not available, some disaster happen on cloud side, so that message is still present in that queue for at least 7 days. And by creating a global resource, that project is global, so it is available in the multiple cloud zone. So we can easily recover that disaster scenarios, and we can replay all those messages which are in the queue for last 7 days. So it basically helps us to achieve the disaster mechanism for solving the ingestion problem. Now I want to store, okay, now data is arrived. I want to store that data on cloud. So the main challenge in any oil production operation is, okay, everyone start using their own terminology, own data model. So someone wants to call something like area, field, station, or well. Other person wants to call it some other tank and compressor. So there are several domain concepts like field, asset, surface, subsurface, equipment, well, boreholes, and completion. Our goal is to present every single thing by using these three terms only. One is called entities, second is called properties, and third one is called the relationships. So entity is like anything. It could be well or completion or any tool or compressor. Our properties could be any data coming from that particular entity. It could be pressure, temperature, or oil flow rate. And relationships is like how these hierarchies are attached to each other. So we basically created a canonical domain model so that we can represent every single thing by using a common terms. And it will solve the problem what we faced earlier when every single application was using their own data model. And we are always solving this problem again and again. So another use case, just to explain you why we need a canonical data model. Let's say in there some field, there are two sensors installed. One is streaming, and both are streaming frequency. One is coming from the IoT source. The second one is coming from some database. Let's say one person calling is IoT source like ESP.frequency in hertz, and second person is calling just like ESP underscore frequency in hertz. But for our production domain model, it is just ESP frequency. We don't care about how the main data source want to name it or tag it. Whenever data is coming to our data storage, we want to apply our own domain model concept. So it basically helps us to resolve the different terminology and data standard, because now we understand, okay, we are talking a same language and we are not confused about what other people are giving some other tag or name. So other challenge was, okay, we wanted to store this huge amounts of time series data and structural data, and our main requirement was we always want to keep the history of data, because let's say if I'm running a forecasting operation or I'm running some other recommendation engine workflow, I wanted to see the history of data always. I don't want to delete anything. I always want to append everything. So we solve this problem using bitemporal storage. So bitemporality is a concept when we assign at least two timestamp, One is like a valid time. Second one is called the transaction time. So valid time is like the actual time when that physical measurement happened at the source, like when we measure the pressure at source. And transaction time is when I'm basically storing that data into our cloud storage. So it basically helped us by storing these two timestamps. It helped us to run the temporal queries. It is very useful for running any kind of historical analysis. It also help us to achieve the temporal trends and running the long running immutable calculation. And we can always run the different data points between different data versions, so that we can see the complete history of the data. And it was really important for our historical workflows. So on right hand side, as you can see, I'm just showing you the examples. On the top, it is showing the time series storage, where I'm assigning two timestamp. One is on the row level, other one is at column level. And below, I'm showing the structural data, where the two timestamp is basically stored. So on the first timestamp, I'm showing that, okay, well 2 was not attached to battery 1, but after some time on 13th October, after one day, the well 2 is attached to the battery 1. So I always wanted to store the history of data. And how we achieved this, we basically built bitemporal storage. And just to give you one example, okay, so we are basically we started with a cloud native version of it, but slowly we moved towards a cloud agnostic one. So our first version was created using Bigtable as a storage. So on the top, you are basically seeing the actual Bigtable schema. And bottom, for the structural storage, we use another database that's called Datomic. So Datomic is basically by default provides a feature to run a temporal queries, because it basically stores the version time and the transaction time. So consumption workflows. Okay, now our data is stored. We have everything. Now we want to run a robust model so that we can create our consumption. So our consumption workflows are basically interested in looking for the entities and associated properties, what I explained earlier, using the same canonical model. I want to traverse that bitemporal graph so that I can know, okay, if even I need to go multiple level down and find, okay, my pressure is coming from some flow point location under certain well. So I can do that traversing as well. I'm also interested in doing the lot of calculation on the time series data, which is basically aggregation, consuming, and write back. I want to apply the data quality attribute, and all this data is basically feed into some calculation engine, so that this calculation engine is basically running in the background and giving some recommendation and insight to production engineer, okay, and helping them to understand why their oil production is low, or why their forecasting is not matching. So all this data is basically helping to run this consumption and workflow. I would like to give some example, like I'm showing here some advanced calculation like validity and source selection. So validity means now we stored all data, all time series data. I want to see if there is a gap in my data. So how much tolerance of this data gap I can have in my workflows. So this calculation is basically, let's say, when I'm feeding this data to that calculation engine, and that calculation engine sees some gap, so it basically a backfill to some status code, so that petroleum engineer understand, okay, I have some bad status code or some unavailable status code. So I mean, it sounds simple, but it's a difficult problem to solve, because just imagine someone is seeing last 8 years of second base frequency data. So I always need to find the last known good data point, so that I know, okay, until that point I need to backfill. So this data point could be maybe 1 month ago, or it could be 25 years ago as well. Also, I want to know, okay, I want to merge the different data streams from different data source. For example, any single oil field, if there is some edge device installed, and someone is also streaming data from mobile by capturing some image or anything. So, but it is possible that both are sending the same kind of a stream. So I need some way to know, okay, these are same kind of data. So I need to deduplicate it and I want to merge it to the single stream. Other calculations are like, okay, uh, there could be a Monte Carlo simulation, there could be a joining of time series, it could be more than time series. So overall, we created around 1500 time series calculation, what we are feeding it to generate these insights. And yeah, I would like to give some interesting numbers. So this application is basically deployed around the globe, mostly for the oil and gas company in South America, in Southeast Asia, and Middle East. It is managing more than 20,000 oil wells. We have 1500 plus time series calculation. So I would like to give you some numbers from one client. That client has 7,500 oil well. The typical hierarchy was starting from company, some levels, then field, then well. And number of entities around 30,000. Total relationship we served 60,000, and properties are 1.5 billion. This client has the data streaming for 25 years. So the typical calculation shows we ingested around 14 billion data points. And yeah, these are other numbers like the achievements. I mean, we able to achieve the 98% time saving, 88% cost saving, 80% reduction of the data preparation time. We able to achieve the well uptime as well. And the typical tech stack, I would like to talk, okay, this is purely a microservice based architecture. We have 40 plus microservices. We are running over 2 Kubernetes cluster, and 90% services are written in Scala. Few services are written in Go and Python. And we are using Akka a lot. Akka is an actor-based framework. And yeah, everything is because we started with the cloud native, but still our future goal was cloud agnostic. So we by default started using Kubernetes. So we are using Kubernetes since 2015. I mean, it's very early days. And for storage, we are using Redis, Postgres, Datomic, and Bigtable. So yeah, I think so. That's all I have, and I'm open for any question.
Wow, we didn't expect to learn more about petroleum and all that in the session. So that was very unexpected.
Thank you.
All right. So I know we're only 3 minutes in the other session, but I'll take a few questions that is coming. That's first by Freya. She's asking, what techniques are employed to ensure the scalability of data ingestion process in a cloud environment?
Yeah, sure. So okay, so when we started with our first client, so basically we were running with a manual scalability. For example, one piece was running on prem, the other piece, the cloudization part, was running on cloud. So we started with manual scaling of these Kubernetes deployments. So we started with some fixed number, but that was not solving our goal. So second thing, we tried, okay, if we can use Kubernetes and we can scale automatically, auto scalability, what we call. So that time Kubernetes used to provide the default, still provide those things like CPU based auto scalability or memory based, but that was not very cost efficient to us, because even if there is no data point streaming in, we are still running some deployment. So we tried the third approach. So I'm explaining you, we always go step by step. So the third approach was we created some custom metric. So custom metric, okay, because our custom metric was I want to only run my workload if there's some data point waiting in my queue. So I put that custom metric in place, but still the problem was for that custom metric. This third solution was still I need to run at least one workload. Our end goal was I only want to run at least one workload if there's some data point waiting in my queue. So finally we solved it using KEDA. So KEDA is another cloud native open source technology. Kubernetes event-driven auto scaling. It basically allows us to not run anything. So as soon as your one data point come, it automatically start at least first workload, and we can start streaming it. So this is like a journey. We applied different things over past 3 years, and now we are able to achieve it.
Wow, wow. That's very well answered. Let's quickly answer the second question, and then we'll wrap up the session. We'll go to the
Yeah.
next one, and it's going to be very tough for you to answer. But it's about what are the challenges you faced when moving from on-premises to the cloud, and how did you address it? I know this is going to be a very long answer, but
Yeah, I would like to summarize in short. So I think
yeah.
our main challenge was because there was no visibility of this on-prem workload earlier. So when we deployed our first data ingestion agent, and within a month we got first complaint and data was not streaming. So the main part missing was we don't have any visibility of what is going on the on-prem. So we use the same messaging queue what we use for streaming data for monitoring our agent as well. What I explained, like we started sending those logs what we used to collect on-prem machine. We started sending those log as well, and those heartbeat messages as well on cloud, so that we built our own. We also followed those SRE practices, site reliability engineering thing. We created our own SLIs and SLA, and we have those monitoring in place so that we can monitor those on-prem machine as well.
Building your own SLAs, I've heard it for the very first time, to be honest. But that's pretty cool. So Ganesh says it's very fast to main petroleum, oil and gas. Very well presented in 30 minutes. Thank you. So
you.
he likes it. Freya says thanks for the answering. Rohit says wow, thank you for answering. So I think that you had a great session. Very different one. No one expected to learn about petroleum industry in this session. Abhay, thank you so much for doing this for the community. Any final thing you want to say before we move to the next session?
No. I mean, you have my contact. If anyone has any question after the session, please feel free to contact me. Or if you're looking for any job or anything, if you
Yeah.
find something in Istanbul, yeah, you can always connect with me.
I'll reach out to Abhay. He's on this site, right? Thank you so much, Abhay. I'll let you carry on with your day, and yeah, have a nice week ahead. Thank
Thanks
you
for
so
the time.
much.
Thanks, Simon. Bye.
All right, ladies and gentlemen, that was Abhay for you, telling you about everything you need to know about the petroleum industry. We now move to the final session of the day. Oh my goodness, and it's also about cloud. Naga Santosh Reddy, he's going to talk about best practices in building cloud distributed system. What best session could be other than this one to end the day two of Software Architecture Conference? Without any further ado, let's bring the gentleman in. Hi, Santosh. How are you? Oh, you're muted.
Hello. Can you hear me now?
Yeah, I can hear loud and clear. How would you, first thing first, how would you like me to address your name? Santosh Reddy, is that the right way to do it?
That's a bit longer name, so you can just call me Sunny if you want.
Oh, yeah, I remember
Yeah.
that. Sunny
Mhm.
thing.
Yeah.
All right, Sunny. So, where are you joining us today from?
I'm in Seattle, Washington.
Oh, I see. I mean,
Yeah.
do you work with the Azure Data team by any chance?
Yes, Azure Data.
Oh, I know, like literally everyone there. I know Asad
Everybody in Azure
Khan,
Data.
Rohan.
Oh,
Yeah.
wow. So they are our CVPs. So
Yeah, I mean,
Rohan used to be the CVP before. Now Asad took over. So
yeah, I mean, I've worked with both of them a lot, along with Bob and Bob
Oh,
Good, Bob
yeah.
and
Bob Ward.
David A. Yeah.
Mhm. Yeah.
So we do a
It's
lot of events with them. I'm so happy that I get to host one of the other team members today, Santosh. Cloud distributed system is something that it's really excite developers. So I'm not going to take much of time. Please feel free to go ahead and share your screen, and then we can get started.
Yeah, sure. Just a second.
Well, someone told me it's a bright sunny day in Seattle today.
No, not at all.
Oh, oh, sorry.
I mean,
The previous
yeah.
guy was from Texas. I missed it.
Okay, so you can see my screen, right?
Yeah, I see your screen. You're inside StreamYard now. Once you move out, yeah, you are in your slides. I have added your slide to the stream. Everybody else can see it. And Sunny, next 35, 40, 45 minutes, all the time you need is all yours.
Okay, sure. So are you seeing the main screen or with the
We see your slides.
Okay, yeah. I mean the main ones, right? Not
Yeah, the first
one
slide.
with okay. Yeah. So yeah, thank you. Yeah, welcome everyone for this session. So I'm gonna talk about the patterns and practices in the cloud distributed systems. So quick introduction about me. I work as a senior software engineering manager at Microsoft Azure SQL Server team. I write blogs and articles on DZones. I'm an MVP there, so you can reach out to me on the DZone or on the ADP list. So ADP list is also a non-profit organization where we do free mentoring. So I do have conducted a lot of mentoring sessions for people who wants to break into the software industry. So yeah, that's quick introduction about me. So, oh, oops, did I click on? Okay, sorry for that. I think I clicked on the wrong one. Okay, so yeah, so the main agenda for today is like we'll go through the introduction of the distributed system, the characteristics and the types of distributed system, and also the best practices. We'll also look into some of the design patterns for the cloud distributed systems. Yeah. So yeah, so basically, like talking about the distributed systems, right? I think because of the cloud computing and the way we have revolutionized the things, now almost all the systems are into the distributed systems category. So what exactly is distributed systems, right? So it's just a collection of different nodes or computers which are set in a different geographical location or a different data centers, and they communicate over the network. And that's how you can imagine a distributed system. And these nodes are physically separate, and they communicate with each other
Santosh,
over.
I'm really sorry to interrupt, but you missed your slides.
Okay.
Yeah, yeah.
Do
you have only one screen?
I have two screens, so that's why I don't know which screen is getting
So
shared.
you need to. Yeah, I was like, what just happened? I just went to get a glass of water. I was like, something
Oh
changed.
no. Okay, sorry about that. This is like my first time using the StreamYard.
Yeah, I know. Browser
Let's
tools can
try one
be
more time.
sometimes tricky.
Yeah, sure. So let me also check which screen is it getting presented. Yeah, can you see it now or?
I don't have anything on my end. It's not coming yet. Yeah, I see something's loading. Yeah, you're inside the StreamYard now. I can see that.
StreamYard now? Okay. So let me just go ahead and share screen. So, okay. So can you see the distributed systems slide?
No, it's white. It's white blank. You see, it's blank. Perhaps you have to stop the screen share and then restart again.
Okay.
Yeah, there's always some demo daemon or anything like that.
Yeah, that's
it has to happen. I'm glad this is the final session, so we have enough time. No problem at all.
Okay. Yeah, one more time. So can you see anything now? Or maybe I'll also open YouTube just to see.
So actually, this is what I see at this instance, right? So maybe you can move your this StreamYard to the other screen, slide it there, and move your presentation over here.
Yeah. So yeah, that's what I'm doing. Yeah. So can you?
Yeah. So that is what we see now.
Okay.
So you're doing entire screen share, right?
Yes, entire screen share.
Screen.
Yes. Yeah, entire screen share.
So I would suggest you go on the presentation mode first on your PowerPoint, right?
Mm-hmm.
Then come back to StreamYard, then share your screen.
Yeah, that's what I'm doing actually.
Oh shoot! Still, it doesn't work.
Yeah. I don't know why this is not working.
Or what you can do also do, Santosh, if your slide are on your local desktop, you can actually upload your slides too.
Yeah, I can. Yeah,
I mean,
can do
inside the
that.
StreamYard itself.
Yeah, sure, I can also do that. So I'm doing like entire screen. I tried the window as well as the entire screen. So
yeah, entire screen.
That's weird. Yeah.
Oh, sure. It still gives you the StreamYard. So how about you click on present and there's an option of slide, and then you upload your slides.
Okay, sure.
Do you have any demo or anything by any chance?
No, it's totally
Okay,
it's
that's
gonna
the
be
serious.
yeah. Oh, it's asking me to close before upload.
Oh, I see.
Okay, that's a bummer. Okay, it's uploading.
Yeah, it's gonna take a while, like 10-12 seconds. Let's wait. Let's see.
Yeah, last session, and I think I'm making everybody wait for this presentation now.
Sundari, what time? We started the streaming at 5 p.m. I'm based out of Delhi, right?
Okay, yeah. So what's the time? What's the time over there now?
It is 1 a.m.
1 a.m. Okay.
We've been streaming for the last 8 hours. Oh, I see your slides now. And now you can use your keyboard to move next, and or maybe even if you hover over this canvas, you can have an arrow.
Oh, okay. Yeah, it's not showing me here.
So can you not go to the next slide? I can go to the next slide like this.
Oh, okay.
If you bring your mouse on top of
here and then next slides.
Yeah, that's right.
Oh, okay. Yeah, fine then. So yeah, maybe I can just do it with this one then. Okay. Okay. Yeah. Perfect. Yeah. Sorry about that. So yeah. So let's go back to where we were. So yeah. So talking about the distributed systems, right? So yeah. So the general way how this works is like you basically have multiple nodes which are placed in different locations, and then you communicate through these nodes over the network. So that's the difference between having a centralized system and a distributed system. So now we're going to talk more about the characteristics of the distributed systems, right? So there are like many, but generally like 4 of them comes to my mind when I talk about the characteristics. So let's look at each one of them. The first one is the service discovery. So basically, this is as the nature of the distributed systems is that you have multiple services that are interacting with one another, and they are completely decoupled. They are not in the one location, they are completely decoupled. So you need to know how the service gonna communicate with other ones, right? So somehow they have to discover the other service. So let's say you are scaling up or scaling down on one services dynamically, and now how will you able to communicate with them, right? So that's how the service discovery is basically off. So there are multiple different ways to actually do the service discovery. So one of it is DNS based discovery, and the other one is client side and the server side. So in the DNS based discovery, what you do is basically you use the domain name service to map service names to IP address and ports. That allows services to discover each other's location. And for the client side discovery, you involve the client. So basically the client has access to some sort of a registry with all the list of all service locations. And based on that, it will identify which service to invoke. And similarly, this is on the server side. So it will maintain a centralized service registry where all the services can come and register themselves. And then you can query that registry to discover other services. So the next slide is on the load balancing. So yeah, so this is also another key important aspect in distributed systems when it comes to like load balancing, right? So how you are planning to distribute your load to multiple different systems. So you don't want to, if you don't distribute the workloads properly, right, then you have this problem of using only one server, and you will be prone to cause some server failures, and there will be a performance impact as well. So there are like basically two types of load balancing, static and dynamic. The static ones use a predefined set of rules to distribute the traffic, while the dynamic one, it quickly adapts to the change in the traffic volume, load, and the server availability. And based on that, it will pick whichever service is available. It will automatically do the load balancing. So there are a couple of like pretty good commonly used algorithms are there, like round robin is there, where it will distribute the traffic evenly among the group of servers in a circular manner. And then there's something called least connection algorithm, which actually distributes the incoming traffic to the server with the fewest active connections. So let's say only one server is taking care of the load currently, and there are other servers with the least active connections, then it will distribute the traffic evenly to target those servers. So that way you're preventing any one server from being overwhelmed and reducing the downtime. And there's something called a DNS-based algorithm, which again uses the IPs and the domain names to distribute the traffic. So it quickly resolves different IP addresses or servers, and based on that, it will redirect the traffic. So there are the industry standard ones are already available. Like I would always recommend not to reinvent your wheel. Whatever is available out of the box, like you can use the Azure Load Balancer, Service Mesh. If your application is containerized, use Kubernetes. It provides the built-in load balancing for distributing node across multiple pods of services. So whatever is available, rather than reinventing the wheel, make sure you use the industry provided products. So the next one is distributed tracing and logging, right? So this is very important because, like you have multiple services now in the it's intertwined in the distributed systems architecture. Now you wanted to make sure that how your requests are coming into your system. Like if there is any issue or any service is down, right? So you need to make sure that you have the ability to look at the logs and also the request to identify any bottlenecks. And if there is any issue, you should be able to debug it quickly. So that's where the importance of the distributed tracing and logging comes in. So there are a lot of open source distributed tracing systems available. Like you can use Zipkin, Zeiger. If you're going with the distributed logging, you can use Elk Stack also. So this way, it will really help you to process each and every event that is occurring in the system. And when you combine both the distributed tracing and logs, right? So you can easily identify any bottlenecks, go through the diagnosing those errors and enhancing that overall system performance is good. So, and I should really appreciate the way that the .NET Aspire team, they have built this dashboard. So this comes by default. Like if you are creating any .NET core web application, right, with onboarding to the Aspire, it will by default give you a dashboard where you can go and look at each and every trace request. You can identify how your services are getting called, from which IP address. All these details will be available right out of the box. You don't have to do anything. And it's an easy way to identify if there is any services having trouble. You can look at those logs and identify if there are any latency issues. And the fourth one is on the service monitoring. So service monitoring is very important because like now you have all these distributed systems connected over the network. What happens if one of the service goes down? So you need to have some sort of way to find the health of the systems, right? So for that, right, we have a lot of tools available again, like Prometheus is there, Grafana dashboards are there. So in our systems also, we use Grafana dashboards where we identify the node health and make sure if the nodes are down, we will trigger some sort of notifications to our teams, and we will also create some incidents, and based on that we will identify this bottlenecks and we will fix it right before our customer or somebody complains. So when building the distributed systems, make sure that service monitoring, like you have to understand the importance of health of each and every system. As long as you are getting this notifications and managing the health, I think you will have a reliable distributed system. So let's look at some of the key benefits of using the distributed systems. So the first one that comes to your mind is like, the scalability, right? So there's different scalability options that are available. So you can do vertical scaling or the horizontal scaling. So vertical scaling is basically, it involves increasing the hardware resources of a single machine, which is often limited by the physical constraints, because there is some sort of a restriction for you. Like you cannot go maximum number of cores or memory capacity other than it supports by your system, right? But when it comes to the horizontal scaling, so instead of increasing your system, now you can add in more systems to your service, and you can scale out. So that way, if there is a new load, or if there is a system failure with one service also, you can automatically make use of the other systems in the service. So that's the advantage you get with the distributed systems. And there is something called reliability, right? So the distributed systems are more resilient to failures compared to the centralized systems. Why? Because the data has been replicated across multiple nodes now. So the failure of a single node or a subset of node does not necessarily bring down the entire system, because automatically the failover happens if let's say you're doing some sort of a master slave architecture where there's one primary node, all the traffic is actually handled by that particular primary service, and then there is suddenly some sort of non-transient failure. So automatically you'll fail over to the secondary one, but still the system will be handling to the user request. So the overall reliability of the system is there when you choose the distributed systems. And the next one is basically on the performance. So as long as you involve breaking down your complex workloads into the smaller manageable parts, right? Now you take advantage of this multiple machines. So sometimes you can distribute your work into small chunks where the primary will be handling some task, and then there are active secondaries which are like initially it can be idle, but then if you have a complex task like doing some sort of large scale data processing, or going through millions of logs on your local system or a centralized network share, now you can take advantage of the secondaries also. So that's how you will get more improved performance. And yeah, so let's look at some of the distributed system patterns. So here there are like a lot of them, but I've captured like some 7 to 8 which I use regularly, and the most common ones. So I'm gonna go through each and every design pattern and let's analyze more. So the first one is basically on the ambassador pattern. So think like let's say you're working as a director in a big company where you have a personal assistant who takes care of all the appointments, all the communications. So everybody who wants to book some time with you, they will first go through the personal assistant, right? So that is nothing but your ambassador pattern. So you have your application code, and then you will develop another service which actually handles your application code to do logging or monitoring or retry service. So all the communication acts or goes through via this ambassador. So it's just like a gateway, and it provides a simplified way to manage communication between the services. So yeah, so that's about the ambassador pattern, and the benefits you get is like reduce latency, enhance security, like the overall architecture of your distributed system is also improved. But if your service grows, right, then it only works for the smaller distributed service. But as soon as your network, as soon as your distributed service grows, then this has some bottlenecks also. So let's look at the second one. Second one is my favorite one, which is a circuit breaker pattern. So this circuit breaker pattern is actually used in distributed systems to prevent cascading failures. So cascading, so there are two types of failures, right? So one is the transient ones and the other ones are non-transient ones. If it is a transient ones, it can quickly recover and you can do just retry policies, if maybe a linear one or an exponential. Some of the other time it will come up. So that is non-transient. That is the transient ones. But for the cascading failures, which are the non-transient ones, there you need to have a system to identify. Okay, if I make a call to this continuously, even though the system is down, right? If you're making continuously calls, you're just simply wasting your resources. So that's where the circuit breaker pattern comes into picture. So it is basically used in conjunction with the retry pattern and the timeout pattern. So the beauty of it is basically it has like three states. Let me go to the next slide. So yeah, so it has three states here, which is the closed, half open, and open. So consider that when the state is closed, that means it is connected. So whatever the calls that you make from service A to service B, it will always go through and you will get the response back from service B. But let's say for some reason, service B, actually the performance or because of some issue, it went into non-transient failure, right? So this is down now. So even if you're making continuous calls from A, you're not going to get any response. So that's where you can plug in the circuit breaker, where it will automatically change the state from closed to open, right? Because it has reached certain failure threshold. So there's no point in now invoking that service. So it will go to the open state, and then based on the timeout, like, let's say if you expect the service to be back online again in half a day or in 1 day, right? Then you can add some timeouts, and if the timeout has expired, it will again check. So in order to check, now it will change its states to half open, and then it will try to make another call to service B. If at all, if the service B comes back online again, then based on the success counter, it will again go back to the closed state and it will close that complete path. If at all, if it doesn't get the enough threshold, it will automatically go back to the open and it will open. So this way you're basically not wasting your resources. So as long as you know when the service is down, and if it is a non-transient ones, circuit breaker pattern will definitely help you in not wasting your resources. Yeah, and the third one is basically the CQRS pattern. So this design pattern that basically separates the read and write operations of a system. It allows for better scalability and performance by optimizing the system for each type of operation. So consider you have a big Amazon e-commerce application, right? Where you see like lot of read, like a lot of people will be browsing through the products, and then if they like any product, they will add into their cart, and then they will purchase the product. But the user traffic is more on consuming, like the reading and going through the products compared to actual purchases, right? So that's where you can actually segregate your workflow, where you can write a separate handlers for doing the command invocation and separate for query invocation. So that's how you will separate the read from writes. And then from the database side, you also need to maintain eventual consistency. Like if there has been any operations on the right side, you just need to make sure that you have the entire data flowing into the read database as well. So that's how you'll maintain the consistency. But if you look at the architecture, your code looks really good. Like if you're jumping into any project with a lot of distributed systems, when you separate your methods and separate your calls into this CQRS pattern, it's so easy to follow. Yeah. And the next one is the leader election pattern. So here, what you're trying to do is you have bunch of nodes, right? So each nodes will actually try to elect a leader. So this leader node is responsible for coordinating and executing tasks. It is used to actually build highly available systems which can tolerate failures. So what happens is if at all, if the leader node goes down, then again, all the nodes will try to elect a new one. So the main advantage here is all the exchanges, all the decision making, everything happens via the leader node. So that way you can avoid conflicts, and the decision making is completely owned by the leader node. And the next pattern is on the event sourcing pattern. So this is also very important one, where what happens is basically you have some changes in your system, right? So you handle those system changes as events. So it keeps a journal of all this live events, whatever is happening in your system, and it makes a record into this journal. So that way, when you want to actually go back and do some sort of auditing or do time travel debugging, let's say some issue happened in your system, if you want to identify, rather than just updating the database record, if it's storing the actual event, what is happening, right, then it's an easy way for you to debug and understand what exactly happened during that point. So one main example is think about the Git version control, right? So where you for every commit that you do, it will actually present a change. So it's easy for you to actually look at each and every one's change, and it also gives an ability for you to revert back and without losing your changes or without having any conflicts. So similarly, in the distributed systems world, you can use the event source pattern for that. And the next one is the publisher and subscriber pattern. So yeah, most of the distributed systems, like, in one or the other way, they use the pub-sub model, where it actually decouples your systems. Like you don't have to worry about who is your publisher, who is your subscriber. So some sort of information is actually published into this the event center or event broker, where it will handle all the messages coming in, and then whoever wants to listen to it, right, so they will go and they will subscribe to it. And one beautiful advantage that you get is, like, let's say you have multiple distributed systems where you went ahead and changed your profile name and picture in the main portal, right, in let's say in your profile page. This should be automatically reflected in multiple different services or the systems. Even if you go to any other page, right, it should automatically get reflected. Why? Because it will make this change and it will submit this information into the event broker or event center, and then whoever has subscribed to this, they will automatically get a notification, and then they will look at this message, and based on that, they will automatically change. So that's the beauty of publisher and subscriber model. So let's look at some of the types of distributed systems, right? So there are multiple, but I've captured like the most used ones here. So there's something called the hub and spoke architecture. So where it's actually it's very simple and efficient way to manage the communication in a network, because there will be like a central hub. So all the communication happens via the central hub. So which makes it easy to manage, secure, and troubleshoot. But as soon as the system grows, right, then it will also become a single point of failure. So there will be a bottleneck. If the system is small enough, then the hub and spoke model works for your needs. But as soon as the system grows, then it becomes a bottleneck. And the other one is the peer-to-peer. So in the peer-to-peer, right, so basically there's no central hub. All nodes are intertwined. They communicate with each other directly. So the problem here is like the challenge is to actually how to manage and handle, right? So every node is like, able to directly freely go and talk to each other. Let's say you have some centralized database where you need to update information. Now it gets trickier because the communications is happening node to node. So other nodes are not aware of it. So sometimes there is a problem with the eventual consistency, right? So you'll not be able to keep up the data so that other nodes can actually look into it. So it works for the smaller systems, basically. And the third one is the messaging queues, right? So this is a highly scalable architecture where messages are sent to the queue and then consumed by more consumers, like exactly what we discussed in the PubSub model. So this provides more scalability, because if you want to increase your consumers, you can go ahead and do that. Even if you see a lot of publishers publishing the message, you can also scale publishers without impacting the consumers. So that's how you'll get more scalability and flexibility. And this is like, one of the commonly used type of distributed systems. And the last one is like hybrid, like mix of all. So based on your requirement, like I've seen people doing, mix of both worlds. They have used hub and spoke architecture for controlling the control traffic, and for peer-to-peer architecture they use for data traffic. So as per your needs, as per your requirements, you can mix and match other types of distributed systems also into one. So now let's get into cloud. Like now you have understood the distributed systems and the types and everything. So now when you're designing for the cloud, right? So you also have to make sure few things, like for the cloud providers, when you think about the scaling, right? So let's say you have created some sort of batch nodes where you are getting new nodes based on your traffic. So you can write some sort of formulas where, based on the node, based on the load on your the batch node, you can automatically scale up or down. So you can also make sure that you control the cost efficiency, but also at the time when the load is very high, you should be able to scale up and maintain that load health. So that's how you can basically think about the auto scaling. So it has like more benefits, like you can improve your application availability, and also risk of any performance issues or downtimes due to the sudden traffic spikes. And the next one is about the health checks. So when you have this distributed systems, right? So as I mentioned, maintaining the health check is very, very important, because if at all, if you don't know if there is any system that is actually went down because of some issue, right? Then how do you actually recover from that? How do you know that there is some actually a problem in a system, right? So that's where the health checks are very important. There are multiple different ways you can do, like active and passive checks, but what you can do is basically make sure you have your systems in such a way that there is some sort of monitoring, some sort of health checks happening. Like if you go ahead with some of the industry standard products like Kubernetes or Service Fabric, where they will automatically publish the health event. They will tell you that, okay, there is some problem in actual node, and you will automatically see those nodes getting into warning or error state. And that's when you have to plug in your services to look into those errors and quickly recover from there. So the health checks is very, very important. And the next one is security. So when you're dealing with cloud, right, so make sure that you follow the best practices in terms of security. So wherever required, you need to encrypt your data. Make sure that you need to prevent any unauthorized access. The access controls, like when you're dealing with the storage accounts or the passwords or anything, use AKVs, or try to avoid using the SAS keys for accessing the storage accounts. And make sure you do the threat monitoring. So this helps to identify any security threats early in building your system, and based on that you can actually address and you can improve your system. So the security is a key aspect when dealing with the cloud-based distributed systems. Yeah, and the next one is the fault tolerance. So this is basically it's an ability for the system to operate even in the event of a failure. So some practices are like, you can go with redundancy, where it's one way of like, making sure that you have fault tolerance in the system by having multiple instances of critical components. So the system, what happens is like, even if one fails, then it will automatically fall back to the other ones. So that's how you'll make sure that there is always, even in the event of failure, your system is able to respond to the user request. And then you have failover mechanisms, which are like basically it will identify in case of the failover, right? So it will automatically switch the backup system. So how do you do that with a minimal downtime? That's what matters, like when you're building distributed systems. And again, the monitoring for the failures, this is the key part, where you have to make sure you detect these issues, notify the users or the admins of your system, and then make sure that you don't cause a significant problem. So that's how you have to design your systems, addressing the fault tolerance. And yeah, coming to the performance optimization, right? So so this is also another key part, where you want to make sure that your cloud systems are operating efficiently and effectively. So the few ways of doing this is basically using the caching as a technique, where you improve the overall system performance by storing the frequently accessed data. Like you can make use of Redis cache, or most of the databases now have the caching ability in them. So you can make use of them and reduce the expensive and time consuming data operations. And so there's something called for the data access also, right? So you can make use of some of the techniques like indexing, prefetching, and minimizing the network round trips also. You don't have to make a call to your database every time you want to retrieve some information. So if it's non-changing information, you can maybe store it in your cache and make use of that cache every time, rather than hitting your database. So that way you can avoid some network round trips. And so I think that's a wrap. Yeah, so thank you for listening. So maybe we can take a look at some questions, Simon.
Yeah, let's do it. Pretty fine session, I would say, right? I was behind the scenes, made sure there's no slide demo demon happening. So let's take a question one from. Let's take from Sophia. She's asking, what real-world examples demonstrate successful implementation of resilient and scalable cloud architectures? Or perhaps from your experience.
So I've worked with Microsoft. So I've built a lot of the products. So I would say, all the products that we built from Microsoft, we have to make sure that it is completely resilient and scalable. So any product that you take, right? So not just products from Microsoft, but any public widely used products that definitely have this resiliency and scalability built in them. I would say, like, if they want to go ahead and look at some of the examples, there is one which has been published by Microsoft. This is a famous GitHub project called eShop on Web. So that's like a standard Bible. Like if you want to look at some of the distributed service best practices, I always refer to that project. Maybe I can give the link to the GitHub code. So
yeah. Okay, that would be nice. Okay, while you do that, there's another question by Ferry. She's saying, how do you handle data consistency and integrity in cloud-based distributed systems?
Yeah, so basically this is kind of tricky, right? Like when you have some sort of microservices or any distributed systems, like microservices, again, another pattern, another architectural pattern. So what we generally do is, like, we try to maintain the data separately. It's like whatever service, if you can break down your big service into multiple chunks, and have database separately, so that one database can handle only the requests for that particular service. So that way you are avoiding the need for other services to go and hit this database. So you have completely isolated your data, and now you built your service which will actually handles the data. So that way there won't be any data consistency. So that's how, like, I've seen like a lot of the cloud based, like we talk about the cloud native distributed systems
Yeah.
also, like keeping cloud as the first citizen as soon as. So the traditional ways are you are building a system and then you take it to the cloud. So that's like a
right.
different shift. And now everything is cloud native with Aspire, with a lot of projects from Microsoft. You are able to build cloud native system from ground up. So when you're doing
Yeah.
that, you should also think about how you are able to handle your data consistency and integrity. So if you, as long as you identify your services which requires the data, separate it out, segregate it in a separate way, and then only your service invocations will handle the data exchange between services. So that way you can maintain the consistency.
That's very well answered. We'll take final question for the day, and that's by Rohit. I don't know where is Rohit from. I hope he's not from India. It's very late. He's asking, what architectural patterns do you recommend for achieving scalability in cloud native system?
Yeah, so it depends on your requirement, basically. Like, so what I would suggest, like the horizontal and vertical scaling, right?
Yeah.
So you need to understand the load of your system. So when you're doing the Amazon big billion days or Walmart days, right? So that's when your traffic and load is very high.
Yeah.
So you should understand your system by writing this auto scale kind of logic, where based on the peak traffic and the volume, it will automatically increase the number of services, whether you want to do more number of payment service or more number of basket service. So depending on the load, you can adjust it. So normal times you will not see like need for you to increase your payment APIs, right? Only during this kind of the big billion days or some sort of prime day, that's when you will see a lot of traffic and a lot of purchases. So that's when you need to understand when and where to actually increase your system scalability.
That's well said. That from Big Billion Days, it reminds me it's August 15th here in India. So for those who celebrate, Happy Independence Day.
Yeah,
That's
happy
what Rohit
Independence
is
Day,
saying.
and it also happens to be my birthday.
Oh
So,
wow! Happy birthday!
Yeah, thank you. Yeah.
Oh wow! We should have done it for some other day. I mean, you don't
Yeah.
want to spend your day birthday
No,
telling about
that's totally
distributed
fine.
systems.
Yeah.
All
Well,
right.
yeah, it was a nice session, but initially I had this issues with the presenting my screen. So yeah, maybe I
Yeah.
should learn from it next time. So
It's okay. It's always
yeah.
happened. It always happened. Thank you so much, Santosh. I mean, if you ever come to India, right? I say that here in Delhi we do North India's largest developer conference in person. We do many virtual, but we also do in person. So if you're ever here, we would love to host you there and also in other events. Let's stay in touch. I work with
Sure.
many of your colleagues,
Yeah.
right? And have a great day ahead and enjoy your birthday, man. Go
Yeah.
enjoy your birthday.
Yeah. Thank you, guys.
See ya. Bye bye.
Yeah. Good. Bye. Yeah.
All right, ladies and gentlemen, that was the birthday boy for you, Santosh. We wrap up the day 2 of Software Architecture Conference. We have been streaming for last 8.5 hours continuously. Kudos to everyone who's been working behind. We'll talk about them tomorrow. So thank you so much, everyone. That was the wrap up of day 2. Tomorrow we'll see you same time. Let me see. 8:30. No, tomorrow we'll see you 1 hour later than we started today, but we'll wrap up around the same time. Happy Independence, everyone, to all those who celebrate. Happy birthday to Sunny. Happy day 2 of Software Architecture Conference. See ya. Bye bye. I gotta find a video to end. Bye.